Cultcast Hall of Fame in 2015 and participating in his local Aries Emergency Communications Team. He's the founder of the World Radio Sport Team Championships and the president of the Yasby Foundation. This can't be all, right? But this is a short version. Right.
Condensed.
Outside of ham radio, Ward plays the mandolin, dabbles in digital photography, and enjoys camping, canoeing, kayaking, and ultimate frisbee. Please welcome Ward Silva.
Yeah.
For the outreach and nuts and bolts.
Oh yes, and the nuts and bolts column is going very well. How many nuts and bolts do we have here now? A couple of nuts, 4 bolts. Okay, super. Yeah, it's been interesting to interact with that group. Anyway, thanks for inviting me back. This is about my 5th or 6th MicroHAMS convention or conference or whatever it is, free for all. And I'm going to run through this talk really quick. I know we're all fully caffeinated at this point, so I can go up after the training sequence. We can jump up to 9600. It should be no problem, and we'll see what happens. Anyway, this talk has 2 audiences, and I've given it to several groups. And one audience is the changers, which I think are you, and one audience is the changees, which are the people who are watching all this come on, like an onrushing train. And for there to be this change process within amateur radio, both groups kind of have to understand each other, and they have to respect each other. So this talk is not so much a technical talk. You guys are all fairly deep in your respective technologies, and I'm not going to tell you anything you don't already know. So this is a talk about what's changing in amateur radio. It's not a prediction talk so much. It's a basket of observations and suggestions. And to do that, we're going to start with a little discussion about the golden age of amateur radio. And who knows what the golden age of ham radio is? It is the 5 years centered on whenever you got your license. And everything before that was primitive wasteland. Everything after that, been going to hell in a handbasket. Okay? So we all have our little golden ages, and that really sets the tone for what we expect out of ham radio. And those of you that got into it in 1959, when the solar flux was so high, you could work the moon with AM on 10 meters. Well, then you have that perspective. If you got into it, the great FM explosion, you have that set of expectations. If you got into it, the packet, you have that set of expectations. And everybody that gets into ham radio, it's kind of like your first love interest. It never gets any better than that, really. And so you have this vision of what ham radio really is. In May of this year will be my 50th anniversary of wandering into the Lewis and Clark Library branch and discovering May QST on the shelf. You know how the lights come up in the movie? It was kind of like that. And that was the equivalent of the internet at the time. And I would wander around in magazine stacks, and I found this magazine, and there were these guys, and they were doing these things, and the rest is history. Well, that's kind of the golden age of ham radio. So we all have to recognize that we all have these different set of expectations for what ham radio is. Okay. But we've got 100 years now of ham radio goodness in the log, so to speak. Started out back in the day of Marconi, and it's come all the way through. There's been all these wonderful technical operating advances. I wrote a book called History of QST Technology as part of a 2-volume set for the centennial. And as I went through it, I found some amazing things that hams have contributed even as far back as the teens of the first century, back there in 1915 and 16, and then in the 20s and so on and so forth. And it really continues all the way along through it. It's really quite a story. And we're developed this incredibly skilled public service component. We adapted radio grants. We built these networks. We did all these really cool things totally on our own. The American Radio Relay League was founded, in fact, to create a network. And it was one of the first wireless networks. And it's a good thing that the ARL and amateur radio got started in New England, because you could only hear a few miles. If it had started in Kansas, it would have been dead within a week. But if it was in New England, then you had all these little boroughs and towns and stuff. And so they developed this system of getting messages from town to town in a few miles. so forth, and then stations gradually got bigger and bigger. And they were doing transcontinental stuff before you know it. But this was something we developed completely on our own, with our own technology. Today, there are millions, literally millions of hams worldwide. Started out with a handful of wild-eyed experimenters, and now there are millions of us. So all over the world, and each little group around the world is sort of coming along at its own pace and with its own priorities. So we have the most hams, we have the most frequencies, we have the most technologies ever. And so that's really quite an accomplishment. And so I quote U.B. Blake here, the great ragtime player, about if he'd known he was going to live this long, he'd have taken better care of himself. And somebody asked U.B. one time, what do you attribute your long life to? And U.B. grew up in slums of New Orleans playing piano in barrel houses. And he said, always sit facing the door. So, good advice. So we talk about, we've got all these frequencies and hams and technology. Okay, so what's the problem here? Well, this is a very similar situation to where Intel was back in the 70s. And some of you will recognize the name Andy Grove. He was the CEO for Intel for its great world domination period from the mid-70s into the 80s and early 90s. Andy sensed that even though Intel was the world leader in memories at the time, that they were selling a ton of stuff, they were the world leader, they were making more memories than anybody else, the market was going to change. Soon, memories would be a commodity, and what was a big wave of technology now would suddenly fall at some point. And he said, we've got to get out of this. And of course, the board is going, what? And the sheriffs are going, what? And the sales guys are going, what? And he says, no, we're going to change into these new things, called a microprocessor thing. And they became the world leaders that were titans of their day, were soon bankrupt, whatever, as everybody overbuilt their memory capacity, and what was a technology leading kind of thing became just another device. And so Intel got off that horse, and Andy called that the strategic point of inflection, where everything's going well, but you sense things are changing out from under you. And that's where ham radio really is today. A lot of people, a lot of technology, a lot of cool stuff going on, but I think we can all sense the changes that are coming. And primarily, it's a technology sort of thing. Okay, so this is what I call ham radio 2.0, the big pivot. Ham radio 1.0 has been going on for 100 years. Certain modalities, certain ways of doing business, certain expectations, certain technologies are involved, and now we're sort of getting to this point where the technology is changing. You're going to see several changes as we go through this stuff today. And so now that the centennial has passed, and we've had our big party, and we've congratulated ourselves and patted ourselves on the back for 100 years of innovation and good stuff, now we have to turn around and look out the windshield. Okay, the centennial's over, now what? And we got to start getting away from the nostalgia for the past and looking toward the future. If we don't change our emphasis on the past, then we get to what I call the American Radio Reenactment League. Okay, there's a lot of value in 1.0, but we've got to go to 2.0. And as you guys know, when you release software, and a lot of software people here, going to 2.0 doesn't mean throwing away 1.0. It means taking what 1.0 has and carrying it forward into 2.0. That's what we've got to do. And the other challenge is the demographics are not that favorable to us. If you look around, there's a lot of gray hair. I have some. A lot of us are in our 40s, 50s, 60s, and 70s, and that pig and snake is moving to the right. We need to be aware of that. We need to start looking to people. I see 3 young people here. Look, young people, ladies and gentlemen, young people, look at them. That's all right. We get a little creepy at times. Okay? I think if you look on Reddit, the word geezer comes up an awful lot. Usually, they're okay for a bunch of old geezers. They're kind of weird, but we're cool with it. Okay. But the demographics have to change, and I can tell you from conversations with people back at HQ, and I can use my standard disclaimer. I have a brown badge, okay, and I'm a contractor with the ARO. I'm not staff. I'm not elected, and brown means loose cannon. Okay, so it's falling off here. So what I say is not legal policy. It's not sanctioned. It's just me. Okay, so I have plausible deniability, and so do you. Anyway, the new CEO really gets this issue of demographics, and that we have to do some significant amount of outreach. And I think that leadership at the ARL is coming to this realization as well. So look for some recognition and some support of new programs through the ARL. They want to hear from you. What are you doing? What is cool? How can we help you promote it? How can we help you publicize it? How can we get the word out and distribute it? What media channels should we be on? Where should we be talking about this stuff? All this is going to happen. And as you know, the technology changes are huge. They're enormous. And that makes a lot of people nervous. And this Suzuki guy is a Zen philosopher. And it's just really tough. And what he's saying here is, this is hard. We all know that things are going to change. Those of us who have been around for a while, and I've had my license since 1972, it's tough. We want to do what we want to do. And as these changes come along, well, is there going to be a place for me? Is there going to be a place for the stuff that I like? And so we suffer. Okay, so let's move along then as all this philosophy talk. What do we see? We turn around, we look out the windshield. What, in fact, are we seeing? So the idea of what a station is changing. It used to be, it was your backyard, you put up antennas, you had receivers and transmitters and towers and what have you, and all that kind of stuff. And just due to the changing way that we live today, the idea of a station itself is changing. You've got remote stations, portable stations, mobile stations, people moving around. You can use your remote station from wherever you are. You can just whip out your tablet, bing, 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 you're on from anywhere. I know two guys who were flying next to each other in an airliner, and they both took out their tablets and they opened up their stations on the ground and worked each other, even though they were sitting next to each other on a plane. This drives some people absolutely crazy. And other people, it drives absolutely crazy. And I'm going to be remoting my station. The point is, the purpose of a station is changing. What your expectations are going to be changing. And people that come to the hobby now are going to have a completely different set of expectations about what they're going to be doing. They're not so invested in this, well, I've got to have this giant console down in the basement with all these wires and these things in the backyard. I may need to have access to that, but I don't have to necessarily have it myself. Okay, you got digital voice, you got digital data, it's alongside the analog modes. 40 meters is crazy. Have you listened on a weekend where there's the big RIDI contest and a digital contest, and you've got the WinLink guys, and there's single sideband, and there's a Morse code contest going on at the same time. And it kind of sounds like a truck full of hogs running into a truck full of tin cans up there around 7060. I talked to the cognitive radio guys, and they're always like, well, we have these algorithms. I said, look, just come down to 40 meters, watch the hams do it. We've got 5 or 6 completely incompatible nodes, and sometimes even hostile user groups, and they work it out. This is how we do it. We have single sided, we have RIDI, all this kind of stuff, and they're all piled in there together. We do cognitive radio. We've been doing the white space thing for years, for decades. Come down and see how we do it. So that's really a cool part of what 2.0 is going to be. SDR is replacing all of analog technology. As a handbook editor, I have this big challenge. I've got this big book of 1,300 pages. A lot of it is receiving and transmitting, all this stuff. It has all this legacy stuff about mixers and modulators and demodulators, detectors, and all this stuff. And I also got to explain all this stuff about SDRs. SDR receivers behave completely differently from analog receivers. So how do I, in a chapter about receivers, do I have to write 2 chapters? What about the hybrid stuff? How are we going to do this? So we're in this transition period. We've got Casey and Morgan's hand shield. Is Casey or Morgan in the audience here? There you go. Hey, I'm waiting for my ham shield, buddy. Come on, come on. I'm waiting. This is good. So this is happening. The Rebel Tintech little thing, somebody figured out how to jam JT65 into an Arduino. And so you can get on 40 meters and work JT65 with this tiny little QRP transceiver. You've got ham mesh networks that are sprouting up everywhere. And they may be the answer to holding our microwave bands. I mean, contesting on the weekend isn't going to do it. And you're certainly not going to rag chew on 5.6 gigahertz single sideband. So how do we use these allocations? Well, the networks are a great opportunity. What if we could have contests with networks? Think about that. Some kind of distance, bit rate, error rate metric that you would immediately run out to the nearest mountaintop and be scanning around, try and find other people. We've got digital codes and protocols that are just coming out like crazy. The new version of FL-Digi has over 100 different modes. And there's menus and sub-menus and sub-menus. I'm mentoring a young guy who's just thinking about getting his license, and we went through that menu. He said, "What is this?" And I explained a bunch of them, and then you get to this one, and I said, "I have no idea. I have absolutely no idea." Somebody invented it, they published it. If you invent a way of exchanging data and you publish your protocol, you publish your modulation scheme, go for it. It's a totally open area of innovation. We got very low signal noise stuff. You can't even hear JT65 signals half the time. You don't even know they're there. You're doing stuff off the moon, you whistle with your ear, you can't hear anything. But it's decoding. It's terrific. 27, 28, 29, 30 dB below the noise floor. JT65 is pulling this stuff out. It's handy to have these Nobel laureates writing stuff. Very handy. 1.0 is kind of a linear thing. And we have this model of the spectrum that is a linear thing. It goes from over here to over here, and we have all these stations that are beads on this little string. And our receivers throw away all of those beads. And the better the receiver is, the more the beads it can throw away until you just get one of those beads, one single bead. And then we have this knob thing that changes from bead to bead. And that hasn't changed since the 1930s. That's the model that we have in our heads of what the spectrum is. That's the model for our user interface of how we deal with stuff, is we have the string with beads and we throw away everything except that one bead. Okay, 2.0, you've got data. You've got lots of data. We can inhale great leaping chunks of spectrum with an SDR. Bring it all in. Why? Then we can throw it away and apply the 1.0 model to that. Why not? Let's turn around, look out. Let's use that data. Let's go out and grab some of this data off the internet. There's a guy who's got a really neat little reverse beacon network app where you click on the spot and it goes to that frequency and you see everything that's been spotted within that little thing. He can take the call sign, he can go out and he can find out where that person is. He can put the picture on the top of that signal, so I would see who I'm talking to. In Mike's case, that might not be a good idea, but
especially if it's female.
there you go. Yeah. So your anonymity. Well, you get avatars. If you ever wanted to be a 16-year-old Ukrainian ballet dancer, here's your chance. Okay, whatever. It's like Facebook. So we've got all this data, this metadata, all these things. We've got enormous amounts of processing power. This is all going to change. So it's no more going to be this knob with numbers and a box. It's going to change. This is a cool thing. We got weird solar behavior. We know more about the sun than we ever did before. We got real-time ionospheric data. We've got groups that are, research groups that are now pulling in this automated receiver data and building an enormous data set. You know, there's going to be a total eclipse of the sun here in the United States, August 2017. Starts in Portland, Oregon, and goes all the way across the country to Charlotte, South Carolina. It's going to be the most watched total solar eclipse in history. And we are putting together a solar eclipse QSO party to generate signals that can be decoded and captured by this reverse beacon network and other beacons. But we've got WhisperNet, PSK Reporter, a bunch of other stuff. And that data set is going to be pulled into the Virginia Tech cloud of computers, and it's going to be available for ionospheric researchers to play with. And hams are going to transmit everything from 160 meters all the way up to 70 centimeters. So they'll have all of this data about how signals go back and forth around the country through the totality. Under the totality, you'll be able to see totality happen and then move on. It'll be an amazing thing. Watch for this. You can participate yourself. So we've got all this new data, new understanding of the real world. We've got hundreds of tiny satellites. We've got Fox 1, geosynchronous. I think John's going to talk about phase 4 possible. I think Inmarsat is providing, one of the big companies is going to provide some kind of platform space for us up there. So we will finally have a geosynchronous satellite service. That'll change things. Awards and contests in this new environment. What does it mean to have an award or a contest program in this environment where we all know about where we all are receiving and transmitting at all times? All this information that was previously hidden is now available to us. So what does it mean to have these programs? Well, you have to boil them down and say, how do we make this about radio know-how? And that's really kind of a key element, is remembering that we are doing radio. We're not playing a video game. We are doing a radio. We are interacting with the natural environment in a certain way. So we got all this data. We've got all this technology. What are we going to do with it? That's just what we can see today. I fully expect within the next 5 to 10 years some really amazing additional kind of innovations that will change technology as much as that it's changed over the last 20 years. Things are really, really happening, and they're really, really happening fast. So who, ladies and gentlemen, who do we see doing this kind of stuff? Who are all these people? I think mostly it's you guys, okay? You guys inventing new things, figuring out how to connect this technology to this technology. Somebody out there is fooling around with an interesting new user interface for the radio that is not going to be a knob and some numbers. It's going to be something completely different. There's a guy in Germany who took a Hercules DJ controller with the 2 little spin knobs and some joysticks and some other stuff, and made an SO2R controller out of that. The YASME, the foundation, is thinking about awarding a prize for somebody who places in the top 10 of a major contest using completely virtual reality, like Oculus Rift. You know, you put on Oculus Rift. What if you could see the radio spectrum and see the ionosphere the way radio does? What if you could see the signals coming in from every place? Artificial reality goggle, and suddenly you're in this giant planetarium of radio. Wouldn't that be cool? That would be really interesting. It's not unimaginable. It's a simple matter of programming, the 4 most dangerous words in the English language. And it's going to happen. Somebody is going to do this. So these people that are coming in their teens and their 20s and their 30s and 40s, plus you guys, are all technically savvy. They're totally into having a point of presence on the global network at all times, 24/7, 365. What do you say to them when you go through this process and you're trying to explain that you talk to whatever it was, Afghanistan last 920 meters, and they kind of reach into their pocket like I'm doing now, and they're looking for this. Here it is, big pocket. And they go, that's nothing I can do. I got one of these. I can do this anytime. Well, my story is, yeah, but I can hear the world turn. And they go, what do you mean? I said, well, Now I've got a story. Okay, now I can talk to them about the sun and the way it interacts with the ionosphere. They have no idea there's an ionosphere up there. Okay, who knows? You know, you don't even hear about it unless there's a giant solar flare, we're all going to die. Okay, you don't hear about that stuff. We've got something that no other service or activity has, and that's propagation. So my answer is, I can hear the world turn, and I can tell them about bands opening, bands closing, all this kind of stuff. And that's interesting. So these people are coming because there's a whole new way of experiencing the world that they've never experienced before, and is unique to amateur radio. That is something that only we have. That should be one of our big selling points. So that's an interesting thing. Everybody's naturally online and connected. This whole artificial division between, well, this is real ham radio and that's not real ham radio. That all has to go away. We have to allow this hybridization to occur because we've got online connectivity to giant resources. For example, right now I think of my radio as being in a box. This is where the decoder is, this is where the PC is, you know, everything's on my desk. If I've got fiber to the curb, why does my radio have to be on my desk? Why can't I have a digitizer over here in this county, and then it sends the IQ data to some kind of a decoder in the cloud, and it sends that back to some kind of a processor someplace else, a server, where it decides who and where and adds the metadata, and then it shows up on my tablet, my desktop. Where's my radio? Am I a single op now? Am I distributed? Am I worldwide? Am I multi-op? What? This is all interesting stuff. This can be done. This is just imagination coming on. So there's lots of these other nearby communities as well who are interested. The makers, the robotics guys. How many people know about sat-navs? There's couple, okay, winner of the 2014 Hackaday Prize. It's a totally robotic satellite ground station, and all the gears and stuff are all 3D printed. The antennas are all homemade. It's got an Ethernet jack into it, and so basically you put this thing up someplace, you tell it what satellite you want it to watch, and you give it the orbital elements, and it checks its watch and it says, oh. And then it watches go across the sky and it inhales the telemetry data and sends it back to the researcher. Well, if you've got a ham license, you can also transmit through that as well. Satnavs.org. Check it out. It's pretty cool stuff. So all these people in these nearby adjacent communities to ham radio might be interested in a hybridization of ham radio with what they do. The 3D printers, the SatNav thing is really good because it's got 3D printing, it's got the network stuff, it's open source, it's ham radio, all these things coming together to make a new thing that's greater than the sum of the parts. Okay, so why would these people become hams? Okay, so they get kind of close. Well, it's interesting and it's fun. My meme lately has been science, service, skill. So it's all three of these things. You can come in through the science door, you can come in through the public service door, you can come in through the I just want to have fun door, and then there's a big party going on. Okay, so they come in and they see all this cool stuff going on, and then we bring them into the rest of the party. So the idea is that if you're primarily a public service person, you can become a much more effective public service person if you learn some of the technology, if you learn and practice your operating stuff. So why not get on in a contest or two? If you come in from the technology thing, like I did when I was a kid, I was a nerd, no big deal, right? You come in and then you go, okay, well, what's this net stuff? What's this public service stuff? I think I'll go try that. And a lot of us got into ham radio through the technology thing because it was the internet of its day. And then we got in and we found out that we could participate in these net things. And we learned how to pass traffic and all this kind of stuff. And then there were these CD parties, which were the forerunners of the NATP QSO parties. And so we became contesters. Even though we came in through the technical door, we went through public service and then got into the operational skill part. The amateur has to be balanced. You have this three-legged stool of science, the technology, the operating skill, and the training to put that to work as public service. And that's the quid pro quo of Part 97.1. We get access to all this cool stuff because we are willing to provide service, we're willing to push the envelopes, we're willing to build and experiment, test, all this kind of stuff. Okay, so they come in, they're interacting with the natural world, they hear the world turning. This is emotionally and socially satisfying to them. And we can't forget that ham radio is about people. It's a successful hobby only if you cooperate. It's like these contests that I get in. They are competitions to cooperate more effectively than anybody else. It's the only sport in which you have to cooperate with your competition in order to score points. It's a really weird sport in a lot of ways. Okay, so, but it's about people. It's about people, about friendships, lifetime friendships, and you can go anywhere in the world, and if you meet another ham radio operator, you are a friend for life immediately. They will take you to their house, and they will feed you dinner, and they will show you around, and put you up, and all sorts of amazing things. So it's a neat social group as well as just the technology. But we have to let these people that are coming form their own groups. Young hams, like youngsters on the air out of Europe. This is, the word youngster in Europe means something different than it does here. Here it means a child, a young child under 10. Over there it means teens and 20s. And so youngsters on the air, check them out on Facebook. A totally motivated, interesting group of teens and 20-somethings that travel around. They have their own conferences. They get on contests. They have special call signs. They're having a ball. They're doing it on their own. They're not doing it to please version 1.0 guys. They're doing it on their own terms. This is what we have to encourage these new people to ham radio to do. They form their communities online, and clubs have changed. You have noticed it's hard to have club meetings in the evening. People are too busy. The club meeting is now an online thing. 24/7, 365. You have Yahoo group, you have a website, you have Google group, whatever. These things are happening all the time. Facebook, all this stuff. So the social part is changing as well. We have to allow that to go on, and we have to encourage it, frankly. What are they going to do? Okay, so we've got the new people. We've seen this all stuff coming in the windshield. What are they going to do? Well, it doesn't dump 1.0. And that's something that as changers, we have to make sure that the changees understand this. We're not talking about saying, okay, all you guys take your equipment and throw it away and replace it with tablets and incomprehensible user interfaces that you don't know anything about. That's not the point. What we're talking about is taking the essential elements of 1.0 and carrying them forward into 2.0 in order to build the second century. And that is sort of a covenant between the old and the new. We have to work together, because otherwise people will not change, and they will resist change, and they will resent change. And so if you work with them and you understand what to support them and bring them forward, that makes change possible in a non-destructive, non-competitive kind of a way. So what are they going to do? They're going to do whatever they want. Okay, we can stand up here, and I can, I've got 40 years on me here, and I can say, well, this is good, and this is what I do, and this is what I enjoy, and you should try this, and all this kind of stuff. They may go for it, they may not. I have a feeling they may not. They may come and they say, well, with this cool networking stuff, we're going to go off and we're going to do X, and I don't get X, but I don't have to. Okay, it's not about me. It's about what they want to do. The FCC said, look guys, here's your bands, here's the rules, have fun. Okay, we're not going to tell you how to operate, we're not going to tell you where to operate, we're not going to tell you when to operate. We put certain limits and constraints on what you can do. Okay, no giant EMP generators, all this kind of stuff. Okay, you have to play nice, but it's up to you. there's no rule in the FCC that says there will be 20-meter contests and they will sound like this and they will go on all weekend and they will be 48 hours. None of us made all that up. Other people can make up their own stuff, make up their own technology. You guys are doing this. You are part of the audience here. You are the irritants, okay? You are going to make the pearls, the oyster. The other thing is convincing the oyster to let you irritate them, okay? So the new people that are coming, the new technology and stuff, it's going to come whether the old guys run it or not. And as old guys, it's our obligation to be open to this because we forget that we were new guys too once. There was a whole bunch of us. When we all came in, we were the kid brat packs, okay? We were the teenagers, we were the high school kids that got on as the novices, and then we upgraded to general and so on and so forth. And we irritated the old guys, just like some of the new people are going to irritate the old guys. But that's part of life. That's just the way life is. Just because it's ham radio doesn't suspend any of those rules. And they're going to do methods that are completely unique. I was watching Chris Testa, KD2, what's his call? DMH. He is a partner with his parents, K6BP, in this effort called ALGORAM, ALGORAM, or you might know it as white box. And both of those are worth Googling. They're inventing what they call the handheld of the future. Imagine a handheld. Who's got a handheld here? Give me a handheld. Uh-oh, I broke it. Who's got a handheld? This is what you need. I've been on ICOM about this for years. Thanks, I'll give it back to you in a day or two. I hold this up and I go, Ray, this is what you want. Not another welded together brick full of incomprehensible things that I can't do anything with. This is what I want. I want the RF brick back here that you make and you certify, and I want the app to run everything. If I want the app to look like an old ICOM IC2AT, I run the IC2AT app. If I want a digital voice app, I run the digital voice app. If I want a data thing, I want a data thing. And it has
How
little...
loud did the Gray laugh?
What's that?
How loud did the Gray laugh?
Well, you know Ray, he gets this look. And I love Ray, and he is pushing the envelope as much as he can. And it's a big change. Because the traditional manufacturers are all about selling this proprietary closed thing. And you look at Yaesu with the System Fusion, and you look at B-Star, and you look at other stuff, and it's a closed proprietary thing. It doesn't give you this. What we need is a point of presence into amateur radio, whatever that is. Whether it's a network, whether it's a digital voice stream, whatever, here's the power. Put this power to work for us. So Chris was talking about building the handheld of the future. And he was talking about the architecture and how he's going to split things up between the RF and the network layer and then the user interface. And he said, well, I needed a signal source, so I wrote a transmitter. I just almost jumped out of my seat. And I said, I wrote a transmitter. Yes, that is version 2.0. Didn't say I soldered one up. He was doing this big FPGA thing. He said, I wrote myself a transmitter. Compiled it straight to silicon. Bang, there it is. That's the kind of modality change that we're talking about. In technology, as you know, we're sitting in a disruptive technology zone right here. It doesn't change like this. It goes, no. Yes, faster. If you look at Logbook of the World for the ARL, it came out. And those of you who were around at the time, it's like everybody's going, oh, this is so hard. I have to send in a postcard. I have to remember a password. I have to go back. I have to do this. I have to do that. And then it was like we got 100 million contacts in there. And then people started putting in a little more in their old logbooks. And it got to be more fun. And when it hit about 300, 400, 500 million contacts of data, all of a sudden it went from to it's not fast enough.
I put in my thing, and it's been 15 minutes. I can't even see it. What's the matter with you guys? I'm sitting in there, it's not good enough. It's not fast enough. So it goes ping like this. It never stays in the middle. It just goes from here to here. And it's like spotting networks and other things. All these technology changes are jumps. So we gotta challenge ourselves to deal with this in a positive way. Interests are fragile. When these new people, new technologies, all this stuff comes in, all it takes is one old toad in the back. Going, well, that's not real ham radio, you're not real ham. And these people can be squashed. I mean, you bring out your baby, it's version 1.0 of your protocol, and someone goes, it's not going to work. And it can be very difficult to push that on through. We must not be toads. We must not make them, whenever we have this urge to say, well, that's not real ham radio, we've got to stop it. And as changers, you guys are going to be the ones helping this happen. Help that happen without that emotional reaction. Be aware of it, see it coming. So, this ties down to what I call the good arrow. Well, first of all, this is a really great quote. And survival is not mandatory. You can stay like you want. You can be the American Radio Reenactment League, but survival is not mandatory. Okay, so this ties into what I call the good arrow. What is the good arrow? You make a zillion decisions every single day. And according to what you perceive is your good arrow. Where does the good arrow point? You can't write everything down. You can't have a manual for every decision. So where's the good arrow of ham radio? Well, if it helps you understand radio's physical environment, that's a good thing. If it improves your efficiency, your accuracy, your breadth of expertise, that's a good thing. If it encourages technical learning about communications, that's a good thing. If it helps us develop new radio services and techniques, that's a good thing. If it creates new opportunities for building innovation, that's a good thing. If it grows the worldwide community of hands, all of these things, and if you're, for the advanced reader, you will probably recognize most of them as sort of vaguely lining up with 97.1 A, B, C, D, and E of the FCC's Part 97, which are a basis and purpose for amateur radio that were stated in 1934, and they really did a pretty good job. Pull back. Don't focus so much on the technology or the actual activity. Look for these fundamental things. And when you see innovation coming down the line, see if it lines up with the good arrow. Push the things that line up with the good arrow, and don't push the things that don't. Outreach. Here's, well, shoot, I had that right there and didn't even put it up. Okay, so outreach, outreach, outreach. Well, the good arrow has to be carried forward by somebody. Who is that going to be? Some of us are in our final couple or 3 decades, you know, and we're going to be handing this stuff off. We have to articulate what the good arrow is, and we have to be prepared to hand that off. And that means every activity that we do has to have some component of outreach. Outreach to hybrid communities, to younger people, to older people, to other technologies, all these other groups. Outreach, 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 outreach. No successful technology is used or adopted in isolation. It has to be shared. That's why we invent it. It doesn't matter if only you can use it. Ham radio is about communications, and communications implies at least one other station. Open all the doors that you can think of. Don't build walls around the hobby. As changers, you are the wall removers, okay? The changees would like there to be a wall. Like, remember the CB thing? We didn't want CBers in the 70s and 80s, and we built all this castle stuff with boiling oil and parapets and all this kind of stuff to keep the CBers away. No, no, no. Well, a lot of people still live in that castle. And if you go up and you look over the wall, there's nobody there. Okay? They're all over there. They're all doing makerspace. They're doing robotics. They're doing all this other cool stuff, you know, 3D printing and things. So we gotta let the drawbridges down. We gotta let these people in. The public service model has been very effective in this. We go out, we recruit out of CERT, We recruit out volunteers. All these people see us doing these things. They want to serve their communities and their fellow citizens. Ham radio is the way to do that. Open that door. Once they come in, show them all the rest of the party. But open that door. Hybridize with technologies. The SatNogs thing, geocachers. You ever done a geofox where the geofox is you put somebody with a GPS together with a ham with a handheld and a little Yagi. First thing you do is you give them coordinates and they go find the geocache. What do they find at the geocache? Oh, the frequency of the hidden transmitter. Okay, so that flips over. Now the ham is doing this thing. They go out, they find the hidden transmitter. What's at the hidden transmitter? More geocache components. So now it flips back to the guy or the gal with the GPS, and they go off and they do this, and back and forth and back and forth. By the end of the day, the two have learned a lot about each other, and a door has been opened. Maybe that geocacher now wants to get their ham radio license. We used to run the CERT communication test on Vashon Island. We would have one ham with a handheld that would work with the island repeater. And then we'd have the CERT people using their little FRS doodads and a handheld CB trying to talk to all the different fire stations. Well, you know what's coming. Okay, they can't talk to any of the fire stations with their stuff, except maybe a little bit. But the hams are like just chatting away on the repeater. By the end of the day, they're like, the heck with this, I want one of those. How do I get one of those? Well, come on, we got a meeting, we got a class, we'll show you. And so there's like 150 hams on Vashon Island. It's just amazing. But you gotta have this outreach. Well, you gotta go to where people are. You gotta get out of the basement. I'm really sorry, you gotta get out of your basement, okay? I know most of us have spent a long time in our basement, ever since high school, building these amazing things, but you gotta get out of your basement, and you gotta act like you want people to interact with you. How many times have you gone to someplace where somebody's demonstrating ham radio, and they're just sitting there behind the table, like this. It's like, excuse me, I'm just gonna back away slowly here. Or you go out field day, and public welcome, and you go over there, and what it looks like is crime scene tape. All of no, it's dangerous, so you can't come over here. You gotta act like you want people to interact with you. For technical people, that's difficult, I understand it, but you have to, if you're gonna change people, even in other hams, you have to act like you want them to come to where you are. Have fun, smile, give them free cookies, okay? Give them free beer. Then the problem is to get them to leave, okay? But go out to where they are. Instead of saying field day, for example, say ham radio open house. Nobody knows what field day is, just hams. You can put up all these signs. Field day, ham radio field day. I'm like, well, they're in a field, okay. But they don't get it, that you're trying to get them to come over. When you say ham radio open house, oh, it's an open house. I get it. I'll go over there and I'll go see them. Everybody understands what an open house is. And if you put free cookies and coffee over there, you'll have people coming all day long, for the price of some, Safeway Oreo sandwich cookies, whatever. It's great, but smile. Act like you want them to interact with you. Okay, so everybody has to be a ambassador. That's what I call it. You have to take ham radio with you wherever you go. I have a little button, about yay big. It's not a very fancy button. It just has big letters on it. It says, ask me about amateur radio. That's all it says. It's this big. It has some, web URLs on the outside of it. The point is that I don't have to come up to you and look at you and get in your personal space to see what that little blinky light, super cool button is that you have. I can look at from like 10 feet away and say, oh, it's a ham radio guy, and then go over there and talk to that person. When you get a chance to talk at your church, at your school, at your clubs, even if they're not ham radio things, offer to give a talk about what ham radio is. That's it, open that door. Go out there, be a little ambassador, and say, if you want to know some more, ask me about it. We've got a club meeting, I'll help you get going. All recruitment is personal. The ARL, God bless them, they can do all these wonderful things. They have great flyers, they have all this stuff. But people don't join amateur radio because of a national organization. They join activities because they see you having a good time, and they're not, okay? So if you're having a good time, and you're putting up all this stuff, and you're doing all these cool things, that gets them interested. Not a flyer, not a poster. Now, once you get them over there, well, the ARL has lots of cool stuff to help them understand what ham radio is. But it's like politics. It's all local. It's all personal. Don't wait for the ARL to do it. You got to do it. You got the coolest technology. It's just amazing. People have no idea. Take it out there and show it to them. You got online tools. You got simulators. When you want to demonstrate ham radio, and somebody says, "Well, why don't you come down and put a ham radio set up at the mall here this weekend?" Well, you know how that goes. You go down to the mall. You're 500 feet from the door. Yeah, okay. So you got a zillion miles of cable. It's all made in 100-foot chunks with barrel connectors. 1, 2, 3. You get it outside and put up your antenna. There's no place to put up an antenna. So you put up an antenna anyway, and all it is noise. It's about 8 feet off the ground. You can't work anybody. That's really not a very effective presentation, okay? So what you do instead is you log on to a remote station. Get somebody with a remote station to say, okay, you can do it on Friday morning or Saturday morning or whenever you're going to do it. And so you have a nice big display and your laptop, and you're logging on to this thing that's got signals and buttons and knobs and all this stuff, and voices from all over the world coming in because you're logged on to a big station, not this little pathetic 8-foot high dipole out in the bushes, okay? Show them what ham radio really is. Log on to something like ViewProp, which is the cool propagation display program. Put the world up there and turn it loose on one of the spotting screens. And as these things come through, ViewProp will put them up there, ding, ding, and there'll be a line between them. And it'll be a color based on the bands. And so as people make contacts and report them, bing, 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 and people come up and go, what's that? Okay, well, they understand what the world is, and you say, oh, these are hams, and they're making contacts, and they report it, they contact between AAP. People get that. They understand that. And then they start asking questions. Well, what do the colors mean? Oh, well, the color is a different frequency. Well, why are the ones in the dark different than the ones in the light? Oh, well, that's because, and now they're interested. You got it. Okay, you got a story. You got a story to tell them. Imagine what that big globe looks like at the beginning of CQ Worldwide Friday afternoon. Yarn ball, it's really pretty interesting. Maps and colors and graphics and stuff like that. Show them what you're doing. Go out to the robotics and the makerspace and all these other places, the campers, the hikers, the geocachers, the programmers. You guys already have an in to all of the digital people. Go out there and say, look, I'd like to give a presentation on my ham radio new game here. Okay, cool, bring it in, show it. Open that door, go there, talk to people about what they do. And then mentor and recruit. Once you get a person in, remember how green we all were at the beginning and how easy it was to get completely stuck because of something absolutely, totally simple. Help them over those little curves. Now, you don't have to make them into little carbon copies of yourself, okay? Just help them over the curves to wherever it is that they want to go. Will Rogers had it right. The best advertising doesn't look like any advertising, okay? Just do your thing, okay? But put it out there where other people can see it. Talk about ham radio's uniqueness. But I've already covered this, and I'm kind of running out of time, so I'm going to jump over this. But we do something that nobody else does. Capitalize on that, sell that, put that story out there. Okay, we're doing all sorts of really cool stuff. And then, once you recruit them, train them. Okay? You'll retain them. Recruit, train, retain. And those of us that have been in it for a while know that even as we get up through our first pass, we're going to learn about something else. So we need to be recruited to do something else within ham radio. And then we need to be trained, and that will retain us. And then we learn about something else. But we have to go through this process over and over again. And that's how you make a lifetime. That's how you get away from somebody who just comes to ham radio and puts their radio in the drawer thinking they're going to use it when the big one comes, okay, but they never interact with anybody, and a couple of years later they can't even find the radio, okay, or they join and they go to breakfast on Saturday morning with the game for a year or so, and then the novelty kind of wears off. What else is out there? Recruit them, train them, retain, make the lifetime ham. It's really, really important, along with balance and science, service, skill. They come through that door, whatever door they come through, your job is to say, welcome to ham radio, and walk them around and show them all these other cool things that hams do. And all of us that have developed this technology, we can apply that. Maybe we can apply it someplace other than where we thought it was going to go. Maybe somebody else can say, oh, that's cool, I could use that for this. That's your job, is to go, really? Cool, let's give that a try. And that helps bring this to fruition and broadens the technology, opens angles that maybe nobody ever thought of before. So we got to watch out for the fact that we've been sitting in our basements for all these years. Stuff. There's no greater threat to the future of this service than demographics, which are relentless, and complacency about how we're going to deal with it. Okay? We've got to recruit. We've got to take this technology that we built and take it out to other people. They will like it. They will enjoy it. They will join the amateur service. But we can change ourselves in the process by opening ourselves up. So, get on with it. We've celebrated our legacy quite enough. I'm tired of the centennial. It's over. We need to move on. Okay, we need to look out the windshield. Ask yourself what the deep underlying principles are of the hobby, the service. Figure out how to carry those forward. Let the technology go. Let the form of the operating go if it has to. Whatever. Carry the principles forward. That's what's the baton. That's what we need to be handing on to the next group of people that are coming. Invite and involve other people into amateur radio. Ask what you and your peers and your club and your section and your division and the ARL are doing to recruit hams so that we have a second century of ham radio. And I think technology and innovation and application of new things is the best recruitment tool that we have. It's really cool. It's been here for 100 years. And every activity can have an outreach component. So ask yourself, why not? What can we do? So as science fiction guys, you probably know this guy, the future is here. It's already here. Microsoft is about the future. Okay? MicroHAMS is about the future. It's just not really distributed. You just have to go out there and proselytize about it. So Clinton DeSoto understood this when he wrote 200 Meters and Down in 1936, and he was anticipating the coming of television and how that would fundamentally change the nature of ham radio. If you've read 200 Meters and Down, it's a fascinating story of the early part of amateur radio. You'll recognize a lot of elements of it. He was confident, and it turned out that he was right, that the society of amateurs would persevere, regardless of what the technology was. The spark was still a recent memory for a lot of these people. Tuned radio frequency receivers were still in use. But here comes coming television, and it was going to change everything. So what I see, to paraphrase DeSoto, what I see as ham radio 2.0 is incredibly exciting with all sorts of new technologies that are going to change the way we operate. They're going to open up a whole new set of services and activities and goals, and a whole new group of people will discover on their own terms what we refer to as the magic of radio. And that's what we're trying to carry forward. It is now our job as innovators and evangelizers to take amateur radio and set it loose out there and bring in these people and take pride in what we have accomplished, thus ensuring that we're going to go forward into the second century. Thank you very much. I can take questions.
Restrooms are down in the hall to the left.
I'm not recording. I'm just, and I should when I go to record, I'm not going to do it.
Scott.
So the string has it.
Always come as a group.
create a blank screen. Hey. Yeah, well, let it, yeah, I mean, you could stop it. It says it's not receiving. Right, because I changed. Okay, I'm setting up to stream out MicroHAMS HTC. I'm set. Okay, I'm going. Yes, yes. Goodbye. I wish they didn't have this problem. All right, here you go. We're out.
All right, so we're missing a whole row here.
So,
All right, let's go ahead and get started. I wanted to mention we actually are live streaming on the web, correct?
yeah,
So we tested it. Probably.
we are streaming. Well, wait.
That'll happen as well. We'll get them posted at some point, but we are streaming now, and then they'll get edited down. We'll post them back up there. So if you go to microhams.com, if you want to send anybody a link, you can go to microhams.com. It's right there, the very first. It's right on the main page. You can't miss it. So anyway, I wanted to introduce our next speaker, Alex Schwartz, VE7DXW. He's an advanced amateur and the graduate, see how to put this here in German, right, of the Höhere Technische Lehranstalten. I can't do it. It was close. That was close. Higher Technical Institute in Innsbruck, Austria. He moved to Vancouver, Canada in 1990 and has since been involved in professional communications and digital wireless network systems. In 2005, he started work at the Biomedical Engineering Department in Children's and Women's Hospital in Vancouver. He's published the development of the MDSR BiLift system that allows users to upgrade an analog HF transceiver to an IF, SDR, and QST magazine July 2012, and yearly at the Tapper conference every year since 2010. And he's got a website, he's got a demo station outside, so you can catch up with him. But I'd like to welcome Alex Schwartz.
Well, thank you very much. And we already heard.
You're not live.
Sorry? Okay. Is it working now?
Maybe? What? There you go, that's a little better.
Is it working now?
Yeah.
Okay. Go to the side. Like this?
There you go.
Okay. All right. Okay, so we heard already about that we're facing a version upgrade. So how we're going to get from version ham radio version 1.0 to ham radio version 2.0. So there's a lot of great rigs out there that come from ham radio version 1, and they're very good radios. They have very good specs. And a lot of those radios we don't want to give up because they're such good radios. So that's why we developed the MDSR as a omni-rig computer interface for demodulation and modulation of radios. So what we developed is in 2009. I was looking to do some development regarding playing with the IF signal from a DX390 radio. The DX390 radio was my first radio that had an IF of 455 kilohertz, and I wanted to put that IF, mix it down so that I could plug it into the audio card, so I could play with a DSP program I just got, and I wanted to see how if you could do digital demodulation. So did an internet search, and Kyle Rowell's website, ON6MU, came up, and he had a tiny little mixer circuit made out of an SA602 chip, and it was really easy to build. So I looked at it, I contacted him, he gave me all the details, and I built it, and I connected my DX390 and to my radio and to my software. That was a lot more rudimentary than what we have now. And I said, and I listened to SSB signals, and the SSB signals sounded clear, clean, and I was able to understand the signal, and I thought, oh, this is amazing. I just connected my DX390 to my computer, and I'm able to do SSB demodulation, and it sounds like, you know, like a $2,000 rig. So I did some more research and developed, and Guy Rowell, thank goodness, he was a good programmer. He developed the MDSR SA spectrum analyzer, and it's also integrated the CAT OmniRig interface, which was developed by Alex Schofkolev at HAM in Toronto. So go on to the next slide. There we go. And so there were still a couple of things that we needed to work out. We needed something that would provide us with DSP engines for the audio card, high quality, at no license charge. So there's this Professor Phil Burke. He's the developer of the JSON Java 24-bit DSP. And this was originally designed to build musical instruments like synthesizers and or guitar, what you call it, guitar, the fuzz boxes. And anyway, so we adopted that technology, and you know, all the audio DSP process units are called something more like out of a musical environment. So if you want to do a frequency, if you want to capture the frequency of an incoming audio wave, you know, instead of you know, just measure the frequency, you measure pitch, for instance, or you instead of if you want to measure signal strengths, you would measure you do envelope control. So it was a total new thinking of adapting this technology to ham radio, but we got the permission from Phil Burke to use this for this purpose. And so this is the major reason why we're able to provide the MDSR software to the ham without any charge, because we don't have to pay any license fees. So the other people that are involved in this program is Alex Schofkolev, I already mentioned him, and he developed the OmniRig CAT interface. The interesting part of the OmniRig CAT interface is that it is user configurable. So that means he came up with how you translate what OmniRig expect to see and what the rig is giving out on its CAT interface. So it's like an interface that is easily updated through user commands. And at the moment, I think right now they have a CAT interface protocols for 103 different radios. So if the radio exists, our program can integrate that CAT command protocol. And then there's Guy Rowles, and he developed the MDSR SA, and also integrated the CAT interface into his program, which is written in Visual Basics in a Microsoft program. And the NDSR software, that's the radio software, the modulator and demodulator. I'm responsible for that. And that's written in Java, and we integrate the different programs by flipping files and data around in the computer. Adam Farson, unfortunately, can't be here today. He was so nice to allow the use of his test lab. So in the beginning, before we had the hardware down, we were almost every other week in Adam's test lab trying to figure out how to make the signal not to cause any bursts, and how to make it compliant to the FCC, and also how we're gonna make sure that the people that download this program and built the BIDIF or IF interface can successfully integrate that into their station without causing interference. So there was a lot of research and development done in Adam's lab.
How's it sound?
Also, his knowledge and experience definitely guided us on the right way to let it go. And then we have a lot of hams that contributed to this program by building the left BIDIF board and integrated into their rigs. So there's a Maximo Barovil. He's from Philippines, and he just bought the kit like a couple of months ago, and he's built it into his TS850S. He loves it. So it really works well, and there's all these people that are contributed in some way or another by either building the kit, documenting it, and there's also the 100 different amateurs. I can't mention them all. That just bought the kit and helped us going on the right way. But anyway, we're going to go on to the next slide. So now you might say, why do we do NDSR? And how does it make my radio better? Well, first of all, the NDSR is a professional grade transceiver that performs very well, and it connects to a professional grade 24-bit ADC at the IF level in the computer through the sound card. This gives us superior dynamic range, and I will show in the next slide of how much difference there actually is. It provides the one thing that NDSR is, it's affordable, it's easy to put together, it can be done within a day or two, it's really easy, it makes you confident, like once you've built it and you put it together and it's working, it makes you confident, it makes you the feeling that oh yes, I seem to have a grasp on this new technology, on this digital technology, and it's not all that scary, because the NDSR interface deliberately was developed to look like a rig you recognize, and it had all the names are the same, the functions that you see. So when you start the software, you don't have to start from zero. You already know, oh yes, I have to do this, I have to do that. And also the software comes with a full manual. So we got an 80-page manual that comes with that is a PDF file that comes with the download of the radio, and it helps you through. It helps you get an idea of what you have to do to make it work. And also we have a Yahoo user group. So if you really get stuck and you need help, drop us a line at the Yahoo user group, and we'll answer always, or email me personally. I will respond to that, and we'll sort out whatever is not working. And the more feedback we get, the better we can adjust our program to the users and that actually are using the software.
What's the name of the user group?
It's NDS Radio Yahoo user group. Okay. Sorry about that. Yeah. Okay. All right. So on the, what it also does, it expands the capability of your existing rig. Let's say you have an FD 857, and you want to connect it to the PIDIF, to the NDSR software. First of all, you do a CAT interface, which is straightforward. You select the CAT protocol for the right rig, and you set up your parameters and your audio parameters like frequency, the frequency and radio status are getting pulled from the radio and put into the NDSR software. And all then you need is the audio interface, which is either the LIF or the PIDIF port. And it also provides a platform to learn and experience hands-on DSP processing, and it doesn't cost a lot. So this is my comparison to why you should be using a 24-bit ADC sound card, and on the top it says 24-bit ADC provides 16.8 million quantumization spots for the sound card to make the decision of what the audio level is at that moment of the quantization time. And if you only have a 16-bit ADC, the quantization steps comes down to 65,000 quantumizations, and it gets very dicey to do a decent receiver with that 16-bit, because when you divide the bit steps by the bit rate, and then you get with the 24-bit card, you get a average jump noise of 0.059 microvolts, which is very low. When you compare that to a 16-bit sound card, which is 15.2 microvolts, which would be about an S5 signal. So if you're receiving a strong signal and you want to listen to a small signal, the small signal won't be heard because the quantumization noise of the ADC will blank it out. The higher quantumization noise of it says degrades the dynamic range versus the 24-bit ADC. And the usable dynamic range of a 24-bit ADC is 130 dB versus 80 dB on a 16-bit. And when you work 80 meters, that could make a big difference of he's seeing the weak signals. And so this is why we use a high-end 24-bit ADC sound card, and it definitely makes a difference. We tested it, we measured it. Okay. So what does the hardware look like? And now you say, oh, this looks very ancient. It does. There's nothing new about the hardware. We wanted to build a hardware that is simple, yet effective, and it doesn't interfere or degrade the performance of the radio that you have it connected to. So it's very simple. It has a single crystal oscillator. There's no digital stuff on this board, and so the the phase noise of this board is very low, and we did comparison with phase noise testing and NPR testing, and there was no difference between the MDSR and the system and the onboard demodulator on the radio. So the system itself does not degrade the performance. It just gives you a lot more possibilities to do with. So there's two boards. This is the lift board. It's a simple board. So I think it's like 35 components, and you can build it within a day and set it up and have fun. And it's not an elaborate project. This down here is the bi-lift board. That's the up converter, and the lift board, and the bi-lift board actually connect to each other here. And then you got the bi-directional converter that you can plug into your computer to work your radio via the NDSR software on modulation too. Okay, here we go. So this is again the lift and bi-lift hardware together in the metal box for to get better signal protection from RF. As we always have to protect these sensitive circuits from the RF from the transmitter. It's a pretty straightforward box. It's nothing fancy about it, and it just works, and it doesn't interfere with the existing performance of the repeater, the radio. And this is our new hardware, which is mobile. So what we did is we got an aluminum box, and we built the U7 sound card into that box, and at the same time our bi-lift assembly, and they connected them together. So all that needs to happen is that puts the flips on top of it, and that connector plugs into the bi-lift. Connect the bi-lift up there, and you fold it together so it goes sandwiched together like this. And you can have this box, and I have this box here for demoing, and it's a full-blown RX and TX hardware for the bi-lift interface for the MDSR software. We have also available. If you don't want to go that far, you can just build the RX interface and just do receive, and then if you like it, you can continue on saying, oh yeah, I really want to go further with this, and you want to go the whole version. You don't lose your investment because you always need the RX board on top of the TX board to make the whole bi-lift assembly. Okay, so now we know what the hardware's like, and now we have to say, yeah, great. Now we'll have to connect it together. So this is a sort of a block diagram of what changes we introduce into the receiver valve while you're using the bi-lift interface. So first of all, nothing downstream from the IF is used in the radio. It's all sitting in the radio. It's not used because we're taking the option from the port and just plug a coax cable into the option from the port and have it brought up to the bi-lift interface and then to the audio sound card. So we're just using the app converter, the transponder features of the radio itself to bring the signals that we're creating in the bi-lift up to frequency that the radio dials in. So at the current time, we have documentation for 8 transceivers like the ICOM 7037000. We got the 8FD 857, 897. And we got also the 817, and the 817 actually brought along. I got that for them on the side, so if somebody wants to look at it. It's a really great little radio, and it's ideally suited for the MDSR application. So we can also do the TS2000. It's a unique radio because it already has a 12 kilohertz IF. So you don't even need the PCB port. You just go download the PDF, and it tells exactly what you need to do to make it work on the MDSR software. And then we got the FT950, which I really like. I've used that as a base station and a test station at home. And then we got the ICOM 756, which is also a beautiful candidate for doing it, very simple. And we've done some receivers. I just, in a couple months ago, I got a Bearcat scanner for Christmas, so I've said, oh, let's see if you can adapt that to a pilot. And sure enough, yeah, we were able to do it. We got the documentation right there. And we also got the Panasonic RF 4900 or RF 4800 receiver that converted to PDF. Converted to MDSR, and it also needs a LIF board to do this. And we also have additional radios that we have documented on our Yahoo user group, but we haven't been able yet to write a document of how to integrate it. And the TS850 actually, I mentioned that earlier that the ham in the Philippines was modifying this one, and I sent him the raw document to fill out the form, so we may be able to post his research and his development, how to convert, how to put in a lift port into your radio if you have a TS850. Anywho. So it gets a little bit more complicated because we have to be compliant to existing existing digital audio software, like let's say JTX or like Whisper. And in order to do that, we had to separate the baseband audio and the IF audio with two sound cards. So what we're doing here, or what this actually shows you how to connect the pilot port from the IF section, from the baseband section, and how to use a second sound card, so that when you install the audio digital audio modulation program, like let's say Whisper, Whisper will easily see this card and will automatically that will configure itself as the default settings, because it sees this card as the card that is used for base audio. And we also have another way of doing this. So since we are using a notebook transformer book to do this, to run the MDSR, which works quite well on an Atom processor, so you don't need a lot of processing power to work this program. And so this is a digital mode adapter. What that does, it takes the audio card that's in a metal box that you've seen earlier, and this is the plug there, and it brings it out so that it can be plugged into the laptop on the side, so it uses the microphone input, and that works quite well. So if you want to go mobile, that's, you need that adapter if you're using the laptop. Okay, here's what it looks like connected to my ICOM 7000. And you can see the MDSR software. This is the spectral analyzer, the cap control, and this is the software that runs the feature. And I can go, when you go to the presentation, I have a presentation table outside. So if you're interested in what you can do, that would be a good point to see, and I can show you what it can do. So this in general allows, when you have it on the business notebook, allows you to take it mobile and portable. So you have SDR performance wherever you can set up your laptop. Okay, and then this is mobile performance. It's a little bit crowded on the wires, but I'm working on ways to combine some of these wires so it's easier. So I took that into on a road trip into the States, and I had great fun doing JT65 while driving. Here is the portable setup on the FT817. This is the one that I have here. It's going to be receiving JT65 protocols. And as you can see, the wiring here is a lot simpler than it was with the ICOM 7000. It depends a little bit on the radio, how well you can integrate it and how well you can put the wiring together so you don't have the least amount of wires. And what you can see here plugged in is the digital adapter that brings the baseband audio from the live box into the computer, and then the JT65 program can detect it, and you can work JT65 anywhere you like. Okay, so now we got new stuff. We just released version 3.1 of the MDSR software was released in the fall. And we haven't felt the need to upgrade it or to release another version of it just yet. I have a couple of ideas, but I don't know how much time I have to make it work. But anyway, when you download the MDSR software, you get the full-blown receiver and transmitter. You don't have to take, there's no compromises. It does provide modulation of USB, LSB, CW, AMW, DRM, demodulator only. It gives you 4 filter bandwidth, and it provides you with a 60 dB deep notch filter. It can be 100 hertz wide. It has post audio noise. It has post audio noise filters that allow you to open and close the filter, the audio filter band, to tune it so that you get the best signal to noise ratio. It has a capability of letting your radio connect remotely. Like if you have a second computer, like let's say you have your computer at home connected to the radio, and you want to work remotely, you can set it up. It's very simple. You set it up on our remote manager, and you click on that, and it opens the server, and the server will wait for the signal of the base of the client to log in. And the client is the same software. So the MDSR software can be either client or server. It's the same software. And what will happen when you dial into your base station, the MDSR downloads all the other configuration files that are located on the server and turns them and makes them active on the client. So your client computer will become the server, or the duplicate of the server. So whatever you do on your MDSR's GUI on the client will be replicated on the server. And also the audio is streamed. Right now we can only do RX audio streaming, and unfortunately it's a bit delayed. And, but it works great for just monitoring. The other option to use it would be if you hardwire the microphone and the audio the speaker connection into another room where you want to listen to it. So you can control the radio via remote control of your laptop and talk to the and RX and TX using the audio cable. Anyway, so now we go to Java, to the new Java SE 1.3, which we're just in the process of releasing. And what the Java SE does, it has some really neat features, and I guess I'm going to continue now. So what it does, it provides a spectrum analyzer. It has spectral amplitude correction. And so now you say, what's spectral amplitude correction? Well, it's actually quite a simple process. It's when you have a standard receiver connected to your spectrum analyzer, what you get is a spectrum looks like a hump, because that's the filter bandwidth of the radio, replicate the filter bandwidth of the radio, and that's what you get. And it's better than no spectrum analyzer, but that hump is annoying. So what we came up with an idea to correct that. So what we do is we have either a noise generator, or we tune the receiver to a section of the band that has noise but does not have any signals, and use that as your reference. And the software assumes that the noise band is flat. So when you do that measurement, it takes about 5 seconds. It measures the curvature of the spectrum, and then applies the opposite curve to make the spectrum flat. And this compensation has to be done for each band, because each band is different. So it allows you to get the best approximation and get a fairly flat spectrum. And if you're interested in seeing how flat it is, I think you got some pictures. Oh, here. Yeah. Okay, so this is the spectrum analyzer version 3.1, and here you can see how absolutely flat the spectrum is. If the SA correction wouldn't be there, you would see humps, and I can show you that out in the demo room and how well that works. And while we were doing that, it was kind of interesting to see, like what kind of IF signals you actually be able to get out of different radios that I own. So I have an FD817 and 7000, and I'm sorry, that should be FD950. So anyway, so this on top is the correction curve for the FD817, and it's not very good, but you still be able to get a fairly flat spectrum out of it. This is the ICOM. Hold on. Yeah, this is the ICOM 7000, and you can see that's actually a lot better. Like this up here, the filter is just terrible. It just looks like an FM filter or something. It doesn't look like an IF filter to me. Here you can see it is better here on the 7000, and of course 950. This is like what you really expect from a radio. Like it's a nice passback curve that you would want, and so you get a flat spectrum. Now, anyway, and here's our last. We're running out of time. This is our new development, and I just put that together like last month. And it was kind of an idea that I had over the years, and it came up with, like I'm always looking at the ARR site to see of what the solar activity is. So I just thought, this is kind of cool. Why wouldn't we be able to do a noise level measurement, very similar to the way they detect noise from the sun through a computer and using a ham radio. So this is what we came up with. So it's an RF seismograph, and what it's a very simple tool. It measures the noise level of the receiver on a certain frequency, and it plots it on a time scale. So each plot is about 52 seconds, and it can hold up to 24 hours of a plot at the moment. And so that means when you have your radio, you don't turn your radio off anymore because you want to know, like when you're not there, you want to know what the noise level does or what the band does. So that means you get a better understanding of how the band changes throughout the day, and it gives you a more precise opportunity to figure out, like which are the best moments or which are the best hours in the day to operate my radio to get to certain areas in the world. And right now, this is still a fairly early program, and one thing that I would like to add is a scanner, so that you can not just scan one band, you actually can scan, 5 or 6 bands. I don't know how much space I have, and display it all. So what would happen? You set up your scanners, you set up your frequencies that you want to monitor, and it would come up with multiple graphs, tell you what the band activity is. Anyway, so this is still something in the future, but it's the near future because it's not that much. It doesn't take that much work to realize it. It takes more time. Anyway, while we were doing development, we were able to already do some very interesting measurements, and this one came up here on this part. And this is what you see that peak up there. That is a C2 solar flare, and we were actually able to confirm that C2 solar flare with NOAA's side to confirm that that was actually what we saw. And over here, this is the standard time graph of how the signals would come in and how we detect the signal. And this is the 40-meter band, and at 3:30 in the morning, we had an opening in the band, which is rather rare. I haven't seen that again. And then also here, you can see these ones are stations that I worked. When I use my transmitter, the noise level of the transmitter is slower, so that why the noise level is lower here. And here you can see, at around 8:15, the band also all of a sudden just clogged up with stations from North America. And what I actually missed here is this part where it's actually very reasonable signals coming in, and we can see where the signal is coming from because I'm looking at the JT65 channel. So I'm receiving all the JT65 traffic, and so I can locate, this atmospheric opening, for instance, say, gave me access, would have given me access to Australia, for instance. Whereas here we have so many signals that we can't get past North America. So this is all part of the software, and we're still developing it, and we're making it better. But we're trying to increase the knowledge of how the noise level and how band openings work, so that it enables you to choose the best time and the best location to do your DX. And I guess I'm already a minute over, so I have to quit. Anyways, thank you very much for listening. And I hope I can see you all at the demo booth. And we got kits, the lift kits. We sell those for $30. And we got all the instructions and everything. So if you want to build one, it's so it's simple, it's effective, it works great. I'll love to have as many people joining us and help us to make this software better for everyone. Thank you very much.
We actually have a couple minutes for questions if you want to take a couple questions.
Yeah, any questions? Yeah.
Anyone?
Anyone?
Wow, hang on. Mike.
So it's digitizing the 455 kilohertz IF.
That's correct, yes.
They can hear me.
Not on the live stream. Please talk into the mic.
Down when it gets to the internet.
So it digitizes the 455 kilohertz IF.
Yeah, or 450 IF.
What's the sample rate, please?
Oh, the sample rate right now we're doing 48 kilohertz, but we could go as high as the sound card allows.
Okay.
The reason why we don't go 48 kilohertz is because we want to be able to run the SDR software on machines that are not as great as the one we have.
Thank you.
Repeat the question, or at least so they can hear it on the stream as well.
So, someone over here had a question?
Was it?
We're good. Okay.
No more questions?
All right. Thank
I'll
you.
see you all at the demo. Thank you.
Yeah, so again, coffee, bathrooms, we'll come back at 11 and start up with the ham shield talk.
Scott, also say the slides are on the website.
The slides are already posted on the website.
Yeah.
Kenny, who do you have watching?
Excellent question. Last time I looked, there were 31 people watching.
Cool. So we actually do have people watching.
There are actually people watching.
No, there are two.
Okay, thanks again. You're welcome. Sorry. Context switch. All I did is he had to cancel. So yeah. You're welcome. Did you just get here? Yeah. Almost. But I'm glad apparently I got it. Was over at a barbecue at a friend's house last night. So, about 3 this morning or so. So, doing better now. Sorry. Good. There's, it's tight out there. Okay.
There's 2A.
What is 2A?
2A is that camera.
You know which camera that is?
That's the camera that's on the speaker. So it's the speaker camera.
What do you need? 1 and
2. Speaker camera.
It's about a 1 minute lag. Well, that's
Slap him upside the head because it's flash. Damn it!
Yeah, well, that's that.
Or you don't have any control over that.
Do you want to pay for the streaming to have it streamed someplace else, or are you okay us using YouTube's solution.
I'm okay with YouTube, but I never use Flash on YouTube.
I don't know what to tell you other
I
than...
know.
Dude, is it
I
this...
had to download a Flash. It was working, by the way.
You know you're here in the room, right?
No, but I was curious. There's about a minute delay.
Yeah, there is. There is a slight delay.
I had to see. I'm not running it now.
You guys just had to see if we were doing our job.
So what format are these cards? Or the video files? There's no file extension or anything on it.
They're just straight video SPX files.
SPX.
Yeah, which is the compressed file format. Just copy them up. He can read them.
No, I am. It's
Yeah, I know. There's
slow. They're large.
No.
I'm gonna leave that key and run to the bathroom.
That's why I have multiple cards, Kenny.
Yes, I get this now.
Come on.
Well, one time I went to Station Island, watched the TV, and we went from the other actually drove down to that end, found out he did very we drove back to the
So what I have been doing is I have been
So I drove around, and they called the airline. So and I missed. It was foggy. It was early morning. So I just had to drive speed limit up around. All the way to the gate, and they were waiting for me. Get in the plane, give it to the stewardess, whoever, and put it to bus.
running toward the gate, and at the gate,
Yeah.
the door in your hand.
A little fun.
Mr. Davis, yeah, stop. Point you down there.
nothing worse than
Dude, it's still popping.
Take your bag, take your side ring, and I met the same elderly lady. The second time that she witnessed it, she was looking like this, like this, and smiling. And
Yeah, but that's only because you have a license.
Software.
Yeah.
So, we have to buy the software. YouTube is putting the dog
You know, don't take it like a question.
And before you get to the airport. Oh, I was looking for him.
Hey, can you check to see if we're streaming right now?
I don't believe.
Make it Bryan.
No, it is. It actually is still up.
Yeah, so we're still streaming and we're recording. I got both of them.
Good. Recording's good.
Recording is good. All right. So I'm just gonna let it run.
Yeah.
You have those two things. You're copying those. I don't want those. So you're done.
I'm not even halfway done with the first one yet.
Yeah, you still got the second one.
I thought this was A.
One, yeah, it is. 1A.
Okay.
So 2A, 1A.
2A and 1A are in the process.
Yeah, and we're in the B section. The B's are in the machines. So,
All right.
so we'll do B to lunch, then we'll do C's after lunch, and then I think you go back to A's. When you get those copied off, you want, well, I have to format them up on lunch. At lunchtime, I'll format them up. Morgan?
Yes. I'm Kenny. Kenny, good to meet you.
Hi, Casey. Nice to meet you. I just want to introduce myself. Thank you guys for coming.
Oh, yeah, no problem.
I really appreciate it.
Thanks for having the organization.
So, I'm not in charge of anything. I'm just pushing people together.
You know, it's great.
Yeah.
So, cool. So, and I did go post the link to the live stream on your Facebook page.
Oh, great. Yeah.
Okay. I actually got a couple of text messages from people saying they're watching, so we got
no guarantees about the quality. So
I had some people tune in earlier, and they like the quality they're able to see.
yeah, so the last speaker, there were sound problems, and I think what it was is that he was holding the mic, and that doesn't work on the directional mics. So
Yeah.
we get it pinned
All
to
right,
you
let's go
guys.
ahead and start, get
You're up. Cool.
back together here.
Good luck.
Find a seat here. There's not many.
All right, I need to start the camera.
We wish you well.
Did you get a flu shot? Well, then you should drag off one. That's why I'm sitting next to you, all right?
Come on, everybody.
Okay, cameras are on. Yes, camera is on. We are recording.
We're about a minute. So I really don't see what's live right now. I see what's there.
That's it.
Yeah. Just gotta, there's you.
Yep, doing my thing.
Making everything easy.
Yeah. So we are recording and playing and doing good work. All right.
I had someone else complain about Flash, and I said, you know, if you want to donate the bill,
You want to pay
we'll
the
be
bill?
happy to stream it via something else next year.
Yeah, but you got to pay the bill.
Yeah, the bill.
Agenda online?
Yes. Go to the MicroHAMS website and go to the page for the.
You need a copy of the agenda?
It's at the bottom of it.
All right, let's go ahead
Is
and
this
get
extra
started
or is
again.
this,
Huh?
is this extra or is this yours?
You can keep it. It's my email, but
Okay, no, that's fine. Okay. Okay, okay, thank you.
Right, so for the next session here, we have two speakers, Casey Halverson, KC7 IBT, and Morgan Redfield, KG7 OGM. They are part of the Ham Shield, or they are the Ham Shield Kickstarter amateur radio project. The Ham Shield is a successfully funded Kickstarter project that allows an Arduino to control an FM transceiver. In this talk, they're going to discuss about how they designed and kickstarted the Ham Shield and the lessons they learned in the process. So please welcome Casey and Morgan.
So before we actually get started, I want to talk a little bit about the ham shield and kind of how I see that fitting in with the rest of this conference and what we've already heard. At the first presentation today, we heard a little bit about ham radio 2.0, ham radio 1.0, the transition between those two. And really, one of the reasons that I'm so excited about the ham shield is because I kind of see it as an intermediate step, maybe ham radio 1.5 or something, where it still uses analog modes, but it allows people to control the radio from an Arduino or from their computer through an Arduino. So it really kind of serves as a transition step to get from just like a standard handy-talkie to something that you can actually control from your smartphone. And to tell you a little bit about myself, I actually just got my ham license last year and really came into this through the maker movement more than anything else. I was really excited about robotics and about electronics, and when Casey first got me involved in the ham shield, that was really kind of what I was most interested in. But then as I learned more about ham radio in general, I decided, oh, I don't just want to like work on the electronics for this. I want to get my ham license and actually make some contacts and do some more interesting stuff with ham radio in general. So that's a little bit about me. I'm going to turn it over to Casey here, and he can tell you about himself and the ham shield.
Hi, I'm Casey Halverson, KC7 IBT, and I've been an amateur radio operator since I was about 14. Got my ham license, my Tech Plus, and you know, I used a VHF handy-talkie, but I always dreamed of a way to create a more dynamic radio where we could control it via software to create new ideas and new inventions. And you know, that bug is, you know, it's been in my head for quite a few years, and finally with the Arduino, I realized that it could be possible. So we took a off-the-shelf component, all-in-one radio IC, and we made something really cool with it, and I hope you guys like it. So,
We will.
So.
Today we're going to be talking about, is this advanced?
Oops, sorry.
Button we press here.
We probably have to click on this screen here.
Oh.
Well, while I get that figured out, I'll just kind of talk a little bit about what we're going to be talking about today. We're going to go over exactly why we built the ham shield and kind of why we made some design decisions that we did. We'll talk a little bit about the design and testing of the ham shield as we were first getting started with the hardware, and then we'll go over the Kickstarter, what the process of kickstarting a radio project is like, and some lessons that we've learned from that, and we definitely learned a lot of lessons from that process. And then we'll talk about the stretch goals, some RF issues that cropped up, and manufacturing and user support. And we're hoping to leave a lot of time for questions. I know we've got some backers in the audience, so feel free to ask us whatever you want, or heckle us, or whatever you want. But we'll save that to the end.
Okay. So, why did we make hand shield? You know, we wanted a handy-talkie that we could automate. There's a lot of handy-talkies out there. Some people have made up little connectors into the audio jack, and they're able to send and receive audio, maybe key on the transmitter. But we really wanted something that allowed us to change the frequency, you know, do sub-audio tones, you know, create maybe a new amateur radio mode using FM, maybe combine packet radio with another technology. So we were looking to build a fully configurable handy-talkie that also enabled, you know, Bluetooth connections as well. We wanted this to be a little box that maybe you interacted with your phone. I mean, it was a sort of a, you know, up in the sky idea. Well, we could make this really cool thing. Maybe even, you know, tack Android onto it or just something like that. But we got a bit ahead of ourselves. But that was the original motivation for the ham shield. And so we started investigating different radio technologies, different radio ICs out there. There's a lot of really low-cost, off-the-shelf radio ICs that power a lot of the handy-talkies today. I'm sure most of you are familiar with those. And then also there's some stuff in the SDR field as well. So we took a look at all the different technologies. But we we cracked open a Baofeng radio actually, and we found there's a neat little chip inside. So we decided to see what we could do. You know, originally we were going to hack into the radio and pull the I2C lines off, and well, that wasn't the right way to do it. So we just decided to build something very basic to experiment with it, and that was a Arduino shield. And I'm sure most of you know what Arduino is, but if not, they're little microcontroller boards. You can buy this thing off Amazon for $10, and you can write in C++ and control, you know, different functions of the Arduino. And if you don't know how to program, that's fine too. There's a million examples out there that you can just plug in and maybe tweak a few values and learn from there. So we made an Arduino shield because you know, it's easy to program, it's easy to repurpose, it's used in all kinds of different prototyping, and so this is one of our early prototype Arduino shields here, but a shield is essentially a little board with a header on it that docks onto the Arduino, and you can stack them. And you know, to enable the Bluetooth connectivity, you could probably even use a second Bluetooth Arduino shield, where you can maybe connect, you know, maybe an audio shield to maybe, you know, play back some recordings for repeater ID or something like that. So you can definitely add on different things to the Arduino and change the functionality of this radio.
All right, so basically we came up with this idea that we wanted to really enable a lot of different ways of controlling the radio, but already there were Arduino shields that could implement most of those controls. We just had to do the radio portion. That was the real contribution that we would make, which means that the shield that we're making actually is fairly simple. It has this radio transceiver on it, and the radio transceiver is off the shelf. We know it works. We know it works pretty well because it's used in quite a number of handy-talkies. And then we build everything around it that we're going to need. So we have the audio for it. We have the control signals, which originally the plan was to use I2C. And then we power it. We run that through a PA, through some filters, and then let people connect that to whatever they want, whether that's just an antenna or another PA with more gain. So this was really the high-level block diagram of what we were going to build. And what we did was we separated each of these different pieces of functionality into a separate board. We tested each board individually. So we had one board that just broke out the transceiver that we were using, the AU1846, and connected that to the Arduino and let us test the communications with it, and just connected that to a separate board that tested the PA, separate filter boards, so that it would make it really easy for us to iterate quickly and test a lot of different things. We got a lot of help from the community, and this was something that actually surprised me as I was getting into ham radio, is just how open and welcoming everybody was, and how much, when I said, oh, I've never done this part of radio before, like, people just introduced me to a lot of different people. People volunteered to let us use their test equipment. It was really great to get that much help from the ham radio community. And we ended up with a set of boards here. Casey showed you this board. This is one of the first prototypes that we have. You can see this is the transceiver. We have an audio jack on there. We have some power on here. But most of the RF circuitry, especially the PAs and the filters, we implemented as separate boards for our first prototypes. And we tested all of this out. We got all of this working. And then we went forward to the Kickstarter. And I'll let Casey tell you a little more about that.
So, let's see. So Kickstarter, I would imagine some people are familiar with Kickstarter, but I've noticed it's relatively new to amateur radio. I know there's been a couple of amateur radio Kickstarters out there, but for the most part, it's for novelty tech items and potato salad and all kinds of goofy stuff. But people have raised a lot of money for a lot of different projects with Kickstarter, and some actually have raised millions of dollars. We didn't quite raise that much, but we raised actually a pretty surprising amount of money, and it kind of goes to show that this is a great tool for amateur radio operators, because we're always building something. We've got lots of great ideas, but you know, we need, you know, money, of course, to actually put everything together and make our ideas, come to reality. So really, the best way to get people excited is just explain why it's exciting. And we all know amateur radio is exciting, but we need to convey that in a video. And also, let's see, hold on a second. So the other neat thing about Kickstarter is there's a really big community of supporters looking to back different technology projects. So it's not, once you kind of get somebody's attention, it spreads like wildfire, and they start posting on Twitter and so forth. And we actually got picked up. It was really funny. I think we went live very early Tuesday morning. I finally finished the video, and I posted to Kickstarter, and I was about ready to go to bed. And apparently somebody saw that it popped up on Kickstarter as a new project, and it got retweeted, and then suddenly we're in a bunch of different news cycles over in Europe before I even woke up the next day.
And I just want to say a couple words about the process of putting together a Kickstarter. We had working hardware. We knew that we could make this thing happen, but the big question is, how do we actually put together a Kickstarter that's going to A, convince other people, and B, make it easy for other people to get involved. Like I said, we had a lot of help from the community at the beginning, and we wanted to keep that help going. We wanted to make sure that we were engaging with them and really showing people what it is that we could do and why this was exciting. So at first, we spent a lot of time going back and forth. Okay, we really want to be successful with this Kickstarter. Maybe we should ask for a low amount of money. Or maybe we need to have this super fancy video that has all these special effects, or shows us doing really cool things. But actually, what we settled on was one of the most important things for making a successful Kickstarter here is just showing people, this is what we're doing, this is why we think it's exciting. And so we just basically stood in my apartment with a camera facing at us and talked about why we were excited about it, and got enough from that we could then put together most of our video. And then we filmed some of the projects that we had already wanted to make for it, and kind of went over some of the examples that we had. And like I said, and like Casey mentioned, we originally thought about asking for actually less than we thought we would need, in part because there's this kind of general wisdom that oh, on Kickstarter, if you just meet your goal, that's a failure. You have to blow it away. You have to do all of raise millions of dollars. And so there's some amount of strategy that people talk about with Kickstarter about setting your goal lower than what you wanted. And what we decided was we just want to be really honest. We actually, this is kind of a difficult thing that we're doing for the first time. We're going to ask for as much money as we think it takes. And we did kind of explain where we expected that money to go. And yeah, the response was really great. We ended up getting much more than our goal. And,
and we took a look at different cost factors of actually taking this product to market, and we asked actually for $25,000, and we actually got that in about a day. But you need to set your expectations, something realistic. We put in a lot of hours here, and I would imagine that some people maybe even sell themselves short, maybe even not ask for the amount of money they need to actually produce the product, and you don't want to be spending money to be shipping your Kickstarter.
So one aspect of the Kickstarter that I think kind of had its pluses and minuses was we had a lot of stretch goals. So we met our goal of raising $25,000 to actually start production of this pretty quickly, and said, okay, well, if we raise even more, then we'll make all of these instructional videos. And if we raise even more than that, we'll give people really nice antennas. And if we raise even more than that, well, we'll completely redesign the PA section. And we ended up raising enough that we hit that point where we said, okay, we're going to redesign the PAs. We're going to give people higher output power. And, well, then we had to turn around and actually do that. And that's where we started to have some problems. So we designed the PA. We've got a little bit over half watt output power now for all three bands that we're transmitting on. But that did cause some last minute headaches that weren't expected, which definitely pushed out the timeline. We were originally planning to ship in October, and I've definitely talked to some of you today. We're like, where's my ham shield? Well, this is why. The stretch goals that we set, I'm really happy that we set them, but they definitely impacted the overall plan. And so this is one of the lessons that we learned about Kickstarter, is when you're setting stretch goals, make sure that you're taking those stretch goals into account when you're communicating your schedule and kind of what your plan is to people.
Yeah, we actually added, well, we figured out how long it would take us, what we thought, to make Ham Shield, and then we added a couple months, and apparently that wasn't enough. And it seems like, things always come up. So actually, I think my lesson learned is don't be afraid to maybe, add a few more months or just kind of overshoot, what you think from the start, how long it's going to take you. The other thing that's interesting about Kickstarter is, unlike any other technology project, and I'm in the technology industry, when you make a product, you don't have a bunch of backers, basically waiting, okay, when is it going to ship, when is it going to ship? There's obviously all kinds of delays that occur, in hardware, since you have, software and hardware to worry about. And it kind of goes unnoticed, but it's sort of like a public display of a technology project in general. And I think that's why a lot of hardware Kickstarters are, delayed. And I really was trying not to be, one of those projects, but unfortunately, we ran into a few issues here and there, and it is what it is. But I think the thing that at least Morgan and I tried to do is at least be extremely transparent in how things were going. That's really important to kind of build trust, because there's been some Kickstarters, and I've actually backed a few of these, where they kind of disappear for a while, or very vague updates, and that makes me feel uneasy. So we've tried our best to kind of communicate, what's going on. Thank you. We tried to do something a little different, and we did think.
Great job.
Oh, thank you.
I had no anxiety because of your communication.
Oh, thank you. Glad to hear that. So, and another thing that wasn't too transparent is, maybe funding or schematics, or like very fine details as to what we're doing. Oh, go ahead.
Kind of on that note of transparency, one of the things that we wanted to take a moment to do right now is tell you about what exactly the issues were that pushed out our timeline. So we redesigned the PA, and the PA that we redesigned actually worked as a separate board. And then when we integrated that onto the ham shield to make a single board, we got our first prototypes in, and sometimes they worked and sometimes they didn't. It was very sporadic, which made it very difficult to figure out what was going on. And that's not something that we can ship to you. So if we say, oh, this works 70% of the time, that's not good enough for you. So what we did was we spent quite a bit of time just debugging this, looking into the hardware, seeing, okay, is it a problem that we had with the design of the power amplifiers? Is it a problem with how the power amplifier is integrated in with the transceiver? Is the matching not right? And we really went through every single thing that could possibly be, kind of several times, and had a lot of trouble figuring out what the issues were, which is kind of, that's one of the things about radio projects, is that they can be pretty difficult to debug. What we ended up realizing is that there were two different issues. These two issues both had similar symptoms, which is one of the reasons it was so difficult to debug. In general, some of the boards would just stop communicating over I2C, often during transmit, but sometimes they wouldn't even communicate over I2C during receive. Now, one of the issues that we found was a ground loop. For those of you who don't know, a ground loop is basically just if you have a big circle of wire in your ground plane. Now, you'll notice the Arduino here is basically has a full ground plane across the entire thing. The ham shield has a full ground plane across the entire thing. There's pins on both sides, so you slot them together, and because there's ground pins on both sides, that makes a big circle that can then act basically like an antenna. So if you're not careful, this ground loop can pick up a lot of the RF energy that you are that's in your radio that you're transmitting, and this causes a lot of problems. Now, luckily, once we identified this, it's easy to fix. just don't connect to your ground pins on one side of the Arduino, and that solves your ground loop issue. The other problem that we found was actually quite a bit more tricky because the shield that we designed, the updated shield with the higher power amplifiers, was a 4-layer board, but our original board was only 2 layers. Now, we didn't expect this to have any issues, but because it's a 4-layer board, the distance between the ground plane on the board and our I2C traces was actually quite a bit less than what it had originally been, increasing the capacitance on those traces. And the RF transceiver that we chose had a bus capacitance limit of 40 picofarads, which is actually not a lot. By contrast, the Arduino has a limit of 400. So this transceiver, we were kind of like pushing the bounds of what capacitance it could actually communicate into. And the problem with this is that that's actually a pretty difficult problem to fix. If our bus capacitance is, say, 20 picofarads due to the ground plane and the pins that we have on our board, we don't necessarily know what somebody is going to plug the ham shield into. Maybe they plug it into an Arduino Duomelanova, or an Arduino Uno, or Arduino Mega, all of which have different geometry, different design, different capacitance, in fact. So rather than trying to fix this issue, we actually switched the communication interface that we were using to control the transceiver chip. And we originally went with I2C because the alternative interface for this transceiver was non-standard, kind of this weird hybrid of SPI and I2C. So the new ham shield, it's a lot more reliable, it works a lot better, but it uses an extra pin for communication, and also requires bit banging. So it's a little bit less efficient, but still can totally accomplish everything that we had intended it to do. And once we had identified those 2 issues and figured out how we were going to fix them, we had a test board made and it worked beautifully, no problems. So now we were ready to actually go into manufacturing. And manufacturing hardware projects, especially Kickstarter projects, is a little bit of a minefield. There's a lot of different directions you can go, some of which are very, very complicated but very cheap, some of which are very expensive but also kind of take a lot of the headaches away from you. For a little while we were thinking, well, maybe we'll actually have these things manufactured in China where it's really cheap. But we had a couple of reasons that we didn't want to do that. One, we really liked the idea of having the ham shield be American-made. But also, to some extent, for small projects, especially for Kickstarter projects, having things manufactured abroad can be more expensive than having them manufactured locally. So it's not just we want it to be American-made, but it actually did make sense for us to have it made locally. Our manufacturer is in Tequila. We're using electronic service providers. And we had our PCBs manufactured, but our PCBs are actually at the manufacturer now. So we should be getting our first set of PCBs back in about a week and a half. So those of you who've been asking when you're going to get them, it's very, very soon. But just to say a couple more words about why we do really like working with local companies. When we had issues crop up, like when we realized that we had those communication errors with our first prototypes, it was really easy to work with the manufacturer because we already knew them. I could just drive down and talk to them in person. There was no language barrier. It was very, very easy to work with them. They made things very simple. And there was definitely a lot of back and forth that I think wouldn't have been possible if we had made some other decisions there. So I do definitely think that local manufacturing is something that for radio projects is totally doable.
Yeah, this company, they do surface mounting and pretty much all the new fancy mounting technologies. So very easy to work with, and what's really neat is when our first boards, the final run, come off the line, we'll be able to actually pull that off and do some quick testing and then kind of authorize the rest of the run to complete. And you could not do that in China. I guess if you were on the ground there, but this manufacturer's been easy to work with. And actually the price isn't bad either, so it's actually very competitive. All right, so
So once we actually have these ham shields, once we're shipping them, they really don't do anybody any good if people can't use them. And this is one place that I think a lot of Kickstarters actually fall down, is user support. Like if I get my whiz-bang new product and I don't know how to use it, there's no instructions. Maybe I kickstarted a project a couple months ago and then got my board and there was no instructions, not even a link to a website where I can find more information. So we really wanted to avoid that with the ham shield. Just like through the whole Kickstarter process, we're trying to provide as much information as we can to everybody about how to use the ham shield, provide a lot of examples, different Arduino libraries, basically make it possible for people to get started in like 10 minutes from when they get their ham shield to assembling it to being ready to actually put some code on it and make a contact. So to that end, we've actually put quite a bit of effort into making some videos, writing up some guides, and all of this is going to be going on our website as soon as we start shipping so that we can really make things as easy as possible for people so that they can take the ham shield and then make the next thing with that.
Yeah, one thing I guess we forgot to mention, although some people know already, is that Ham Shield is open source hardware and software, meaning we give away all the designs, Gerbers, schematics, all the source code, everything. And so, you'd have to read the GPL license, but basically it allows pretty much anybody to take that design and change it around and maybe even make their own ham shield if they want to. You could even, make it yourself. You could get the PCBs manufactured and, put one together yourself, buy all the components, or, maybe you wanted some digital capability and you wanted a reuse or amplifier stage we designed. So you can definitely take things to the next level, even before we kind of move on to the next ham shield.
All right, so that's a quick discussion of the ham shield, the process of kickstarting it, and the process of designing and dealing with design issues that have cropped up. You can see here kind of the specs of the ham shield, and what we'd really like to do is give you a lot of time right now to ask whatever questions you have. I know we have some backers here. Any questions you might have about the ham shield, the design process, the Kickstarter, anything like that.
Can you make sure that they have the mic?
Okay.
Oh yeah, sure. Yeah, I'll just pass around the mic here.
The possibility of the Chinese taking your design, taking your Gerbers, and then manufacturing it using inferior components or leaving things out, doesn't that concern you? Because those boards would, quote, be called by the same name, be sold for half the price, and probably wouldn't work very well, and it would end up giving you a bad name.
And technically the license says that you're not allowed to benefit commercially, I believe, in some aspects. But
well, I think another aspect of that is that because these are open source designs, we kind of expect that to happen over the next year or so, for there to be clones of this. And to some extent, we're kind of hoping that happens because we want to really push things forward and make radio easier and more accessible to people.
There's a couple of already, I wouldn't recommend buying any of them, but there's some RF boards I saw on Deal Extreme for $10 that apparently somebody put them on a spectrum analyzer and it's just like all over the map. But the hope is that the economies of scale, maybe somebody can leverage it. I hope that they do something responsible with the ham shield design and lower the cost. I think that's a great idea.
So I may be the only person in here that doesn't know anything about Kickstarter, but what's the expectation of, for lack of a better word, the investors in this? I mean, it's not like angel funding a startup, right? I mean, you pay some money. I mean, what's the expectation for the so-called investor at the end?
So that's an interesting point, and I guess we have a little bit of time to talk about that. But the way Kickstarter works is, if somebody has an idea, they have a pitch video that you can watch in the description. And then there's reward levels on the right. And it could be something simple like a recognition of your name and something, or maybe a postcard. We did a QSL card, it's kind of cool. And then obviously we have different ham shield reward levels. And what happens is you give your money to Kickstarter, which in turn takes a small little cut and gives it to the person or business, and there's some gotchas there as well, to go make this thing. Now, I know that Washington State has kind of gone after a few Kickstarters where somebody didn't do anything, they kind of ran off with the money, and that does happen. I mean, you can read all about it. I mean, it's a small percentage of projects, but that can happen, and that's actually completely irresponsible. But when you fund something in Kickstarter, you get this. The only thing you don't get a share of the company, you don't get any sort of investment at all. The only thing you get is sort of a reward, which is the product that they intend to make. It could be maybe not exactly what it was described as, and there might have been some technicalities, but as long as they make an effort, you'll get something. And I've done, I don't know, maybe about 20 Kickstarters, and for the most part, people do hit the mark, and then others are really late and might sort of hit the mark, it just depends. But there's a lot of risk involved. It's not, I think people mistake that Kickstarter as a store. It's not really a store. It's sort of a way to help a small business build something cool. And a lot of people have done some very responsible, things with it. But it's sort of a grab bag, if you will.
I wonder if you could spend a few minutes talking about the certification process for spectral purity and other things, and how a Kickstarter style RF project would approach such a thing.
Well, that's a really good point. We've been able to leverage a lot of different tools, and as an amateur radio kit, we can kind of, as long as we're within the spectral, requirements the FCC has, we do well. But we're okay. We don't need to get. We can't really get a board certified anyway. The FCC doesn't certify modules like that. But we used a variety of test equipment, spectrum analyzers, and we've looked at the spectral purity of the radio, and it's within compliance. And we actually put a great deal of filtering, which I think it might knock the power down just slightly, but for the most part, it works really well, and it keeps us within, the emission requirements. But, go ahead.
I think that's also one of the places that we have actually found the ham radio community to be most helpful, is people pointing out, okay, this is the exact specification you have to hit for your kit. Here's some test equipment that you can just bring in your device and you can use this. So people have been very, very generous with loaning us test equipment, giving us advice, and making sure that we're actually going to be compliant by all of the regulations that we need to as a ham radio kit.
Hi, I'm not a FM ham, but I've got a question about, it appears you're using the same chip as the Baofeng radio. Can you tell us what the aspects of your kit are as compared to these little handheld radios that sell for $100 or something?
And the Baofengs, apparently the prices drop even more on the Baofeng, and I had one delivered for Amazon Prime Now, where literally a guy shows up 10 minutes later with the radio. I think it was like $25 or something like that. So the radios are dropping down in price, and we can't compete with that, obviously. We don't have we're not, we're not a business in China and so forth. But I think where we actually shine is a Baofeng is a fully complete radio. There's no serial port. You can't access the features of the radio. Where we come into play is our radio is fully configurable, programmable. We basically give you the full audio input and output. We can actually turn off, pre-emphasis, de-emphasis, and essentially give you discriminator output. But you can take this audio and do packet radio. You can do voice. You can do SSTV. You can create new modes, maybe a new digital mode. So this allows the user to build whatever they want. They can change the frequency. You could make it into a scanner. You could create some sort of packet radio voice hybrid where you did maybe voice trunking. So there's a lot of different things you can do. It is FM, so you can't do high-speed digital modes or anything too creative, but it gives the user a lot of configurability.
And one other thing to add to that is that with the hand shield, you can actually add on other boards very easily. So you're not just able to really innovate on the radio portion. You can add Bluetooth, or you can add GPS, you can add all of these things and automate it all. So you have this one package, you add a couple of other Arduino boards, which also have really well documented libraries, and suddenly you have a totally new thing that can act completely on its own if you want it to, or that talks to your computer, or that talks to your cell phone. So really, that's the real contribution here, is that it makes it really easy to integrate with anything else.
Oh, okay. All right.
If I had a minor criticism of your effort to date, would be that it wasn't really yet easy to understand exactly what the capabilities were going to be, and you explained it perfectly that it's an FM radio and all the other operational aspects, frequency, et cetera, are under software control. But you know, the hope was going to be that you could, you know, say use codec 2 or some of the other, you know, modulation methods, or high-speed packet. And I'd encourage you to do that for a follow-on project.
Yeah, and it was interesting to communicate to a broad spectrum of audiences. You know, obviously there's people with different, you know, technical capabilities, and so when we made the video and the material, we wanted to hit the broadest market there. But yeah, it is just an FM. Although the neat thing is since we went through all this trouble of building this wonderful amplifier, this chip up here on the left, there's some great digital chips out there. Silicon Labs has a few of them. You know, there's a couple others out there. But you could easily do a follow-up project, you know, whether it be us or, you know, the community. It is open source, so.
How does your product compare to, or your project compare to the Radio Shield RS-UV3 from Hobby PCB?
That's a good point. It was actually interesting because we've been working on this one a couple of years before the Kickstarter started, and it just so happened that Hobby PCB also had another, something very similar, with very similar specifications. And I think it was just happenstance that this radio IC hit the market and people started messing with it, and so Hobby PCB made it's sort of a kitchen sink. It's got everything imaginable. It's got a microcontroller on board. It's got Arduino Shield compatibility. I believe it's got a serial port and all kinds of things. Our ham shield's a little bit more simple, and I don't know if they give you direct access. I don't think they give you direct access to the Octus chip itself. But it does have sort of a serial layer to it. I would imagine they're similar in some aspects. I believe our ham shield's smaller, so it might work in different applications. We have some people interested in doing high altitude ballooning and so forth, where every ounce counts. But yeah, they're very similar products. And I believe we have a bit more power output, but I believe they're working on a new amplifier stage, and I mean, it's a great company. I think it's just they're kind of catering towards everything, and we're catering towards just Arduino and you know, customizing and configurability. So, okay. Any other questions?
So you guys actually got a totally custom antenna made from, was it Smiley?
Well, I think it's just undiscovered. I don't know about custom, but we did have them make a whole bunch of these for us, so it might as well have been a custom order. We kind of overwhelmed them. I told them, yeah, I need about 1,000 of these in a month or two, and they kind of like fell over because apparently they only keep about maybe 100 in stock, and then they slowly dwindle down. This is the Smiley antenna, and they went out and bought all the parts for it and everything, and put them together. And you can, it's a metal antenna, which I'm not a big fan of metal antennas, but it does have this. Hold on. It's got like a flex base at the bottom, so it kind of makes up for it, so you don't have to worry about, breaking it. And you can match it across the 3 bands, depending on what mode you're in. And I've noticed too, I put this under a nested, or what was it, network analyzer, and you could even finely tune it across the band if you wanted to, and maybe mark it off the Sharpie. But generally, just kind of go by dropping down the different segments. There was a question back here.
And was this a full-time job for you, or was it more of a second job, evening and weekends?
Well, that's a good point. I've got a full-time job currently, so it's a bit challenging. And Morgan, has work as well. So this was sort of it's kind of funny how this worked out. So we put this out there in the world. We're like, well, I want to validate to see if the ham shield should exist or not. Let's just put it on Kickstarter, see if people like it. And we didn't know what was going to happen. And we didn't know that we were going to have such an amazing response. Like we expected, it'd be awesome if we hit our goal at 25,000. Well, we hit 117,778 backers and after pre-orders, over 1,000 of these ham shields, which is just remarkable. So this kind of was supposed to be a hobby, kind of like a fun project, and it turned into, well, to Morgan especially, since he's the electronics genius, into more of a full-time job. But he has I work at AT&T. I've got, I'm an architect there. I've got a full-time job, and Morgan's, got to pay the bills as well. So it's been interesting. And the way we formed this Kickstarter is and if you ever do a Kickstarter, please keep this in mind. But we actually formed an LLC rather than just like a sole proprietorship. Some people just put their social security number in and they're like, send me the money. But from a tax standpoint, you have to be very careful. So we actually formed a company, an LLC. We got a company bank account, and we kind of did everything the right way. It's the right way to take money from Kickstarter, and it's sort of a side business, I guess you could say. The idea is we're going to ship all our Kickstarter items. We have a store up now to sell these ham shields as well to people that weren't on the Kickstarter, and then we're going to try to work out a distribution deal because I don't know if we can you'd be packing boxes forever. That should kind of bring the load off of us so we can work on designing something new.
No, I need the microphone.
Oh, you need the microphone. Okay.
I'm going to do something really horrible. So we're live streaming, and I have 2 questions from the people watching. And of course, I've taken Morgan's or Casey's mic voice. So first question is, you tried to partner with someone else on Kickstarter for GPS tracking. Were there any other vendors that you tried to partner with or test with? And that was from Greg Evans. And Tom Hayward asked, and I'm not sure if I got this right, if not a fan of metal antennas, what conductors does he prefer? I didn't know if that was an inside joke or not, but I had to ask it. Are subaudible tones and DTMF tones part of the Adreno ham shield combo, or do those still need to be added / developed? Okay, I'll bring this back to you. So you got 3 questions queued up.
Okay, I have a terrible memory, but I'll try to remember all these here.
DTMF tones, metal antennas, and partner.
So there was a Kickstarter, I believe what he's talking about is Traxor. And that was an idea of creating a little ballooning transmitter. And I believe that Kickstarter was not successfully funded, which is really unfortunate because it was a really cool project. But I believe the guy actually went off and built a website and is taking pre-orders. And I believe that's what he's talking about. I'm trying to think of other folks out there. There's been a few other folks. Somebody was trying to do SDR on the Raspberry Pi, and I don't think we specifically partnered with him, but we were trying to help promote different amateur radio projects out there. There's no compensation or anything like that. I just was trying to help some of these projects come to light. And the comment about metal antennas, that's actually really funny. I know literally there's a metal conductor inside, but what I was referring to is just the actual metal, the rigid, there we go, that's the word we want. I'm not a fan of rigid antennas. I've broken enough of these. And then there was, but there was one last thing about DTMF. So there's two ways you can do DTMF. You can generate DTMF on the Arduino, and the other way you can generate it is using the Octus chip itself. It actually has a DTMF generator. In fact, it has a fully configurable tone encoder and decoder. And although I'm not going to do it, but supposedly you might be able to use that to even do a digital mode perhaps, but I'm going to leave that up to somebody else to figure out. But the Octus does have a lot of different tone capabilities.
So I have one last question. Is there going to be a live demo today?
Yeah, we're looking to do a live demo today.
Okay. I didn't ask if it would work, I just asked if you were going to do a demo.
Yeah, we're going to do a live demo today. Great, so we have
any other questions? Okay.
Oh yeah, go ahead.
Oh, well, hold on a minute.
Oh wait, yeah, I should probably
You
stand
can't
here with
speak
this.
unless properly authorized.
Okay, so having learned after you've shipped it, after they're for sale to the, after you've satisfied all the Kickstarters, so having learned all that you did, what's next? If you don't want to, if there's no spoilers.
Well, I will say that I'm just going to take my ham shield and use it for all the things that I wanted to use it for originally. I have a couple of robotics projects that I'm thinking about putting the radio in and just like, we built this thing, now let's use it. But also we do have some ideas about ways that we can do other modes than FM. And so we're looking into ways that we can do that. But
One last thing. So this was an amateur radio project. Did it bring people out of the woodwork and start firing some imaginations from the non-ham audience?
Yeah, actually it did. I think what was really striking about this is, well, you have some hams out there that maybe have their license and are not active. And in fact, I got a lot of messages from people that were like, "Wow, I can use this. I can come up with something cool and actually use my license." And then we had some people that went out and got their licenses to use Ham Shield, which was really interesting. And in fact, I don't have any official metric, and maybe when we do the survey to collect addresses, maybe we'll ask a few key questions. But I believe we have a lot of relatively new people to amateur radio, which is kind of cool. There was kind of a bit of a spark, a kind of a wake-up call, because Arduino, it's always in the news. If something has an Arduino on it, obviously it makes a lot of headlines for some reason. Arduino attracts a lot of attention, and people are really excited about actually having a radio that can actually do something meaningful, as opposed to Bluetooth or something that goes maybe 30 meters, if that.
Was there any other questions?
All the way to end.
I guess we got 10 more minutes before lunch, so.
So what sort of successful contacts have you had on the air using your ham shield? Have you tied into repeaters? Have you done, just communication with the simplex? What have you used it for?
We've used it for simplex. We've done maybe a couple repeater contacts just to test. One thing that I like doing is packet radio. So I was using APRS, and we hit. I can hit Mount Baldy from my house in Federal Way, which I believe is about, it's about 35 miles away. And that was without the best amplifier stage. And then I also, in Portland, we did a few demos, and we were able to hit some APRS gateway that was like in Washington, on a mountain peak on the other side of the Columbia. So we've been able to do some fun stuff with it. One thing that I haven't been able to do is actually sit down and enjoy it, because I'm too busy, testing it and making sure that everything's good. So we've done, a few, token contacts and done some stuff with the UDRx, but I'm looking forward to actually being able to, relax and use Ham Shield, after we ship.
Quick question. I'm a backer, but I'm curious to find out, of the 700 that you've obligated to provide, how many are in this room?
That's a really good point. Could you raise your hand if you're a backer? Wow. That's really cool. Yeah, we've met a few backers here and there. I did go down to DEF CON, and maybe it might have a bad connotation or not, but there's a lot of hams that go there actually, and so I met a few backers there as well. And it's good to actually see people in person. It's amazing that how many people are out there.
Yeah, so you mentioned earlier the possibility of using Bluetooth or something to connect it to a smartphone or an Android device. So have you actually done that? Have you tried connecting a phone to this board and using it?
No, we haven't. Well, I don't know if Morgan has, but...
I have the beginnings of a project going, but I haven't gotten enough time to work on it. My next step is to connect the to an Intel Edison, which has Bluetooth Low Energy, and then I want to use that to actually be able to change channels and control output power settings and all of that kind of stuff from my phone, while it's still using just a headset for voice. So that's the next step, but I am planning to go further from there. So.
And there's a lot of good opportunity on low energy. A packet radio is relatively low bandwidth, and low energy is perfect for command and control of the radio. Okay, go ahead.
So does the Ham Shield actually have a microphone amp and audio amp, or do you pretty much have to do that some other way?
Well, the Ham Shield has two ways to communicate to its audio ports. One is just through the Arduino pins to the ADC and the PWM, which is filtered nicely. And then we also have a microphone jack. Well, it's actually a TRS jack. So it's similar to what you have on your iPhone or Android phone. It actually takes the exact same headset, so you can plug in, and it's got an amplifier on it, so it's monitored really loud. And yeah.
And then for the speaker?
For the speaker, it goes. So if you have a pair of stereo headphones with a microphone, go ahead.
So we have an amplifier on the audio out, but not on the audio in.
So I have another question from the chat room. They wanted to know how many are going to be available after you fulfill all your Kickstarter pledges, and are you going to do another run so there'll be additional ones later?
Yeah, so we're actually running about 1,500 boards right now, and we have 958 boards that go to backers. I think that's within a couple, correct, within one or two. And then we've got another maybe 100 in pre-orders. So we should have a sizable amount of Ham Shields available. I don't know how fast 100 or 500 will go approximately, but if we do run out, we will do another run, I guess.
So one other thing, there's at least 2 people in the chat room that are backers as well.
Oh, good. Well, nice to meet you online.
Any other questions?
Okay,
You're going to run into your limit here.
5-question limit.
Okay, just curious, what were I'm just setting an arbitrary number, 3 coolest things you heard about that you hadn't imagined that people wanted to do?
I think for me, the coolest project that I've seen somebody wanted to with the Ham Shield is use it on an autonomous boat that they're building, that they're going to have circumnavigate a lot of the San Juan Islands, and they're using the Ham Shield for, I believe, APRS and also as a other command and control channel.
We have several people that are interested in high altitude ballooning, which is really cool. And there's a big problem with getting very lightweight radios. They want to get under this certain, and I can't remember, but the FAA has a weight limit of where if you're under a certain limit, you don't need to do all very complicated things like a notice to airmen and all of that. So they're interested in very lightweight transmitters, and we're kind of within that range of lightweight transmitters. The other thing that sounded really interesting, and I don't know if it's going to pan out or not, but there were some folks that wanted to use ham shield and sort of an AMSAT satellite capability, which would be really cool. And it's kind of in the right power range, the right size, and so forth. So if that pans out, that'd be really cool to see one in space. Okay, I guess we're ready for lunch here, so I'll wrap up.
So, yeah, thanks for coming.
Yeah.
And you guys are going to be out, you have a demo table, so we've got a break coming up.
Okay, yeah, it'll take us a few minutes to set up. Thank you.
All right, so the lunch logistics are, we're going to go out this door here. We switched it up on you.
In that
We're going to
door.
leave. What? No, you said
that
no.
door.
David told me over there.
Come back.
All right, which one is it?
Back. Whatever.
We go out the small door and in the big doors, right?
Right, so in that. No! Stop it.
All right, so
Out the small
we've got
door.
an hour and a half, so 1:15 we'll reconvene and we'll start up with the next talks.
Oh, right. No. You're right, that way. He's right. Listen, always right. Except I don't know my wife, I'm not right.
Okay, Dennis.
Thank you very much. All right. People sit down. Can you hear okay in the back? Is it working reasonably well?
Kurt, talk closer into the mic.
As loud as you can, Kurt.
Yep.
Use your man moves.
Flip it on your nose.
Casey was just amazing. It was just the way you want to do it.
Closer to you get. I'm still messing with it. Is that better? That's better. Oh yeah, even I can hear me. All right. All right, so Kurt had a brief presentation here he wanted to give about Ramrod and digital. And so I will let him go to it. Please welcome Kurt Black. Thank you very much. Thanks to the Microsoft folks, the club, for letting me do this, because it's just a little... Microsoft club. All right. Oh, okay, the MicroHAMS.
Don't give that away.
So I'm Kurt Black, WRFIJ. I do things with Seattle ACS, Red Cross, a bunch of organizations. You may have seen us out there. And I'm also part of the, W7AW is the club call for the West Seattle Amateur Radio Club. So, licensed trustee. Ramrod. How many people have ridden Ramrod? I know there's at least one person. Two. There we go. Very good. That's quite. So Ramrod is a ride around Mount Rainier in one day. So Ramrod, right around Mount Rainier in one day. That's quite something. I mean, it's not just a ride like a motorcycle ride. It's a bicycle ride, right? So one beautiful mountain, 150 miles. 800 bicycle riders. It's limited by the park that they go through. So, I mean, it's not going to be bigger than that. There's a lot more people than that want to ride it. So there's a lottery to get in, that kind of thing. And then 10,000 feet of climbing. That's 10,000 feet up and 10,000 feet back down. So, quite a bit of vertical work. People have to be in pretty good shape, but it is not all about people that are like Tour de France looking folks. The ride strongly encourages, especially older folks. They actually, rider number one is always the oldest oldest participant in the ride. So it's quite something to run into rider number one. They are not at the back a lot of times. They're up there, and they have been 70 and more years old. So anyway, it's not just a bunch of very, very young folks. No lamps, hands off. 200 volunteers, 40 of them are hams. If you're going to have that many folks participating in an event, it needs to be fairly organized. So we have an incident action plan that runs under ICS. So anyway, it's quite an operation. It takes a lot of folks. Last year's RFID team are these folks. How many folks were on that team last year? Oh, yeah, Alan. That's all. Mr. Dr. Scott, I guess is what I would say. We start in Enumclaw, the start-finish line, up at the top, and then runs around through Ording, down to Eatonville. Runs into Alder Lake and along the Nisqually River as it crosses into the park entrance, past Longmire, up almost to Paradise, and then veers off, hits the Inspiration Point. Inspiration Point's at 4,800 feet. Slides on down, goes past Reflection Lakes and things like that. And climbs back up Backbone Ridge. Cayuse Pass, plunges back down into Anacosh, then up the Cayuse Pass, and then kind of a downhill run, although frequently it's upwind, because the wind's coming up the valley edge, and you think you're done, and it's going to be easy, but sometimes it's not. So it is an unutterably beautiful place to do, first, the ride, and second, any ham radio support that you might be participating in, because that's kind of why I'm here, is to encourage some volunteerism in the community, so at least on the data team. So we'll talk about that. Anyway, you can't pick a more gorgeous place to do ham radio or bicycle. It's fantastic. So the profile is like that. This is a slight exaggeration, but if you're on a bicycle, anyway, there's a data reader at Enumclaw, the start-finish line, and then at the park entrance. This last couple of years, Alan Scott was AC7MX was the leader of the park entrance gateway team. We got a team on Backbone Ridge, and this year we're adding Cayuse Pass. So anyway, it's
Hey Kurt, are there any survivors?
Most people make it around, so the vast majority of cyclists do not abandon this ride. So it's a
West Coast thing.
It's pretty inspirational, impressive. I mean, it's very well supported, I think, is the thing. It's a great thing. Anyway, so just talk a little bit about radio frequency ID and the tags. I don't want to encourage too many tin hat type folks. You don't have to polish it up, but they are going to need to be the size of poppy seeds now. I mean, they're very, very small. The ones we use for this event are like this. So I could pass it around or whatever, but it's got an antenna. The antenna picks up enough energy to activate the device. It then transmits its data as a burst. Takes about 100 milliseconds or so for that cycle to happen. So it's pretty neat technology. Works really well. Our frequencies are kind of 860 to 960 megahertz. There's a bunch of slices in there. Anyway, so that's what most of the equipment runs on. They make a bunch of them that work in the kilohertz range too, but they tend to be very short range things. So the stuff we're doing. Anyway, I'm happy to pass it around. Maybe you've seen them. So we grab this data from the cyclists as they're going by. We use VHF data links, things like D-Star and DRATS quite a bit in the past. VHF data links on like FLDigi and FLAMP and NBM's system. We have done some 80-meter NVIS, Winmore, Pactories, and RMS Express. Also 20 meters, so we can just grab the data. We're in pretty remote places, right? You saw like Backbone Ridge. It's just up there, in the middle of the backside of the mountain. So
we pump the data out, say to San Diego on one of the RMS sites down there, or Mexico's got a really good one, Mexico City, up into central Canada, just 20 meters, get it out of there, and it emails itself back. The people at the finish line check, log into the RMS system, off it goes. So this last year we tested some more peer-to-peer stuff, so we could do peer-to-peer win more or backdoor from point to point around the mountain and just kind of send the data inside. In the past we've used Wi-Fi and the internet, but I really do prefer an all amateur approach for the event if we can get there. That's a personal bias. So the equipment, I try to make things reasonably, we're ready, like on this laptop, to plug in a DRAX data cable or the SCS backdoor modem, the rig talk for getting a cat control to a rig, that kind of thing. Stuff's labeled. Kind of trying to get that anything can go wrong will go wrong and not let that happen. This is the data acquisition software, is the screen capture. The character count would go up every time a rider would go by. That's that. That's what the data look actually. So this side of the screen just has a time and date stamp, and then a long string of data, of which the last 4 or 5 characters are significant. And then there's something about how much power the transmission was received at and stuff.
So who's sending you the data?
I'll get to where it's
I don't want to move in.
So every cyclist has that tag, one of those tags on their helmet. They're required to wear the helmet, and they carry the tags. They pass underneath these antennas. Impinge makes them. This is a year when we were using D-Star at this site, so it was going on 2 meters of beam pointing down the valley about 15 or 20 miles, something like that. And I was at the other end picking it up and then putting it onto Wi-Fi. I was getting Wi-Fi from a local hair salon, and just emailed it to the start finish line. But that's not a whole ham solution. I'd much prefer to have another way to do it. So, Alan, I just had the picture. Anyway, so this is that here. This is that data station. And, you look good. Anyway. Yeah, so we're talking to each other. That's the neat thing about like DRAX. You can actually sit there and you do audio and then you send data seamlessly back and forth. Yeah. Just, are you ready? Yeah, I'm ready. All right. Good. On the sound? Was that the sound? Oh yeah, then we're good. Yeah. Yep. So this is the gateway station that Alan was in charge of this last year. It's fuzzy because it's pre-dawn darkness kind of thing. It's the riders leave like 4 a.m. that kind of thing. They have a lot of choices, but anyway. Moving on around the mountain, this is the Backbone Ridge site. This is the last part of the climb for Backbone Ridge. And this is the data team of Backbone Ridge. Looking at a 7000 there is the rig I was using at that station. And the riders coming through. So, same kind of setup. We're going to make these a little bit higher, maybe a little bit wider. But anyway, it's working pretty well. And did I say good operating conditions? Pretty good operating conditions. So new for this year, we're adding a new data station kind of each year. So it's kind of an exponential increase in the number of people that we need help from, which is why I'm talking to you now. So it'll be a reader team at Cayuse Pass, probably sending VHF out, a relay team possibly above Cayuse Pass, or maybe it's Sunrise that's getting that VHF and then sending it out on HF. A data aggregator team at maybe Mud Mountain Dam or Sunrise, and a VHF link from either Sunrise or Mud Mountain Dam back down to the start-finish line. That's new stuff. That means we need more help. So Western Washington Digital Hams are the primary source for Ramrod volunteers, which is a great opportunity if you want to develop those skills, if you already have those skills. Either way, I'd like to talk to you about this thing. It's the same skills you'll be using for things like Cascadia Rising, so might as well get them down. Can you help? There's challenges with helping. One of it is it's in the middle of the week. We set up on Wednesday, the ride's on Thursday. That cuts down the number of people that can play right there. Failure's not an option. There's a little bit of stress involved. There just is. Can be long days, it can be hot, it can be cold, it can be wet, it will be dark, that kind of stuff. And there's technical challenges, at least for me. Other people seem to do it seamlessly, but I was running backups for the backups, focus on any way that can fail around that. So there's a lot of kind of organization. And bring their service attitude or whatever. Most of us are really, really good with that, but we have a great long relationship with an event by the bicycles. I've already saw it alone. I would say it would be worth riding 150 miles on a bicycle. Learn and change and have events like Ramrod and Field Day and Parade, Cascadia Rising, Lighthouse Activation, license class, all this lifelong learning that can happen to us. So anyway, and they reinforce this of good service. So volunteer, WR5J at arr.net. And I have one, I'm going to go back. Anyway, so that's the question slide, and this is the last slide. How do you feel?
Who had the question? No, one back here.
What are the dates for?
Repeat the question.
So I got a question on what the date is. It's something like the third weekend. If you go to the Redmond Cycling Club website, but it's something like the third weekend in July. Yeah, or not the weekend, but the 28? Okay. Okay. So
one question.
We'd be doing 27, 28 July this year.
So I'm not sure if this particular RFID works the way that it's been described to me, but before I got this description from someone, I thought that the way they worked was they absorbed some power from the transmitter and then transmitted a reply. But a radio engineer told me, no, what they do is they change their feed point impedance, which causes a change in the feed point impedance at the transmitter, and there's a circuit there that senses that, and that's how it gets back the reply. So they're loading the transmitter while it's transmitting, and that is a reception.
Can't go there with you. Anyway.
Yeah, I'm afraid we're gonna have to stop there though, because we do have to get set up for the next talk for Bryan Hoyer.
And you get a T-shirt, and actually you get your costs your travel, gasoline, stuff like that. So thank you very much.
Thank you, Kurt.
Get the pitchforks and the torches.
Hey, no one talks about it. You didn't volunteer for that.
This one.
Sure.
Flip it to your view.
You're not going to use it next.
Yes. I'll go to That
sounds good.
That sound good? Jeremy's going to take that when you're done with it.
All right.
Oh, you don't do pants, okay. Understand.
So when we started looking for speakers for this year's conference, I went to Tapper. Kenny and I were at Tapper this last year, and that's where we got to see Alex. And I got a chance to talk to Bryan, and I mentioned that he's spoken several times at our conferences in the past, like the last few years. And of course, every time, right? As much as we love that, if he didn't have a product to show, that maybe we'll take a rest this year. And he goes, I will have a product or I'll light myself on fire. Whoa. So we came prepared. Might need some help.
Okay.
Are they full or empty?
I sure to know.
Yeah, it took me a while to get into I had a hard time figuring, Kenny helped me and we got it working, but yeah. I managed to spew it all, more spray as fuel. Yeah, go ahead and introduce Bryan here. He has been a Silicon Valley hardware engineer for 25 years, analog and digital and RF, Xylophone Creek Engineering in 1994, built analyzer, the first FPGA analyzer with a Windows interface, which analyst for the largest single deployed FPGA, IP, sorry. Boulder Creek sold Altera in 1999, and I can't even read this. Developed, there must be a way to pronounce that, right?
Neos.
Neos,
microprocessor.
And which the world's most popular soft-core microprocessor. Founded Northwest Digital Radio in 2012, and has 10 granted U.S. patents and a licensed amateur radio enthusiast since 2000. So, newbie, right? So, please welcome Bryan Hoyer.
Thank you. This is heavy. Okay. You wanted the display port. All right. Sorry. Okay, so now the continuing saga of the UDRx and a little more. Who doesn't know about the mythical data radio called the UDRx? Carol's never heard of it. You've never heard of it. No, seriously, has anybody not heard of this?
I ordered one.
Okay, so for the benefit of the few new people, and I come here for the new people because to you, I'm not late yet. Here's the radio. Looks like this. It started a few years ago. It's a 25 watt, 70 centimeter, band limited, software defined radio. It runs from a bottom level of 4800 up to over 100 kilobits per second. At the time, we called it the Universal Digital Radio because it does AX25 and D-Star, but because it is a software defined radio, it really could do anything you can program in software. Has an open source Linux server card, but this USB ports a 40-pin and has our goal is where installed on a to walk into a situation and connect via the network, open up a web browser, and do all the things that you need to do. Now, Scott, I did tell Scott that privately, not for publication. But then this happened. Here we are in Chicago, late last year. And we don't have any sound. This is after my talk where a guy yells out in the back, "So when is a UDR going to ship?" And I explained how I don't really know because I've said it so many times and I've been wrong every time. And that's when I repeated the fire story. And Scott offered to bring fire extinguishers and apparently gasoline.
Water
Ensuring success.
Ensuring success. This is me waving my. So that happened, by the way, thanks to Gary Pierce. And by the way, thanks to your host for this conference. I do lots of talks, lots of places. This is the #1 conference that I speak at. In terms of quality of attendees, and the fact that our hosts are very generous with us.
We're just hoping we're not going to pour the gasoline.
So, in the YouTube, which you couldn't get my voice in, what I actually said was, I'm going to talk about shipping the UDR or light myself on fire. So technically, if I just talk about it, is that good? Yeah, you're right, talking about it isn't good enough. So, I didn't know there was a word called self-immolation until it went on YouTube and people said, so, that does not look like fun. But seriously, folks, really? Come on. It's a figure of speech. When it first came out, a friend of mine said to me, he says, wow, I saw your YouTube video. You must have a lot of confidence in your project. And I said, no, it's the exact opposite. I'm so frustrated that I don't know what else to do. But all the chatter on YouTube and marshmallow stuff has made my wife very nervous. And she checked my life insurance policy, and it is still in force. So where are we now, really? Well, a lot has changed in the last year. As you know, we added Jeremy McDermott. Jeremy's someplace here. Jeremy's over there.
Jeremy.
A notable ham and attorney in his own right. We added a team, and he's been doing a lot of stuff to basically kick the whole project. We were falling into we have hardware but no software, or software but no hardware. We were going back and forth. And now Jeremy's kind of helped to focus the whole thing. He's done a lot of stuff for us. GNU Radio's been ported. This is an interesting story. So I'm trying to get enough software support to get the hardware finished so I can push to the next level. And so Jeremy joins the team, and you add a guy, and the first thing he says to me is, I was thinking I should port GNU Radio to this. And I thought, great, I'm just trying to get hardware out, and you want to spend a couple months and play around with GUI tools. And he said, well, I've already got it done. And I went, oh, drove down to Corvallis, Oregon, gave me a demo running GNU. I thought, that's really impressive. So I bundled up and I drove it up from Corvallis over to Dennis' desk, and I said, have you ever used GNU Radio? And he said, no, but it's like an interesting tool for development of things that has helped accelerate the development over the last few months. There's 2 demos, live demos of our hardware doing both APRS at 9600, using our hardware, some of our software, and GNU Radio interface. You can see that out there. There's another one right next to it using a different piece of software called DSD and doing D-Star at 4800. So now we have 2 platforms actually running. This is all over one of the problems with lapel mics is if you turn your head, it goes away. But only Britney Spears wears the little headset thing. It's just not me. I will turn. So we have to finish doing the 100 kilohertz IF testing. So the 25 kilohertz, that's the channel bandwidth that we operate under. We have 2 different bandwidths. We need some more testing there. GNU Radio, it's a great toy. No, it's more than a toy. It's a really flexible platform. And one of the great things it has is the ability to do things like drop oscilloscopes and spectrum analyzers. Because it's written by software people who don't know what oscilloscopes and spectrum analyzers are, they're called time sync and frequency sync. It's an oscilloscope or spectrum analyzer, which lets you drop it in the middle of software, which is hugely valuable. So it's a great debugging tool. It's not going to ship as part of the final product, but you will be able to download it and play with it and get no support from us about it. Because we have other things we have to work on. The pilot units are in layout. So what we're working now is called Prototype 3. There's a 4. It's the final form factor. When I say pilot unit, it's 10 to be deployed in the field and run through the full manufacturing process. We have two different manufacturing processes. We have a prototype process and a production process. Pilot units are small runs on the full production process. We have integrated with the Raspberry Pi. The board got bigger. The flat cable you see out there is gone. There's no interstitial board. The Pi flips upside down, mounts on top. That cuts down final assembly time. And we've engaged with a couple different contract manufacturers, and one is offshore and one is here in Washington. So the final decision on that hasn't been made yet, but we're trying as much as we can to make sure we keep the price in line with what we talked about all those years ago, which was $395, unless you got in on the pre-sales. Who is on the pre-sale list? Oh, maybe a third of you guys. We're going to hold that price no matter what, even if we have to raise the price for standard distribution. So that's happening. Here's a picture of the board. You can see the overlay in the upper right is the Pi 2. Power modules at the bottom. Below that's a real-time clock. We ended up with excess board space, which is good because we have to keep the digital stuff far from the analog stuff. The power converter on the top is a 12 to 3 buck. It's the same one we're using in another product to try to leverage everything we can do. It's a TI design. We're pretty happy with it. There's a new thing in the bottom, which we just learned about recently, is the Pi has a thing called, it has two I2C buses. One is the one you use for peripherals. There's another one which is called device something or other. Jeremy, tell us about the other one that we're using now.
It's part of the Raspberry Pi hat specification, and it's an I2C bus that actually gets cooked to. So the Pi has all of its cores, but the big master thing is called the video core. It's actually the GPU that wags the dog, the tail that wags the dog. So this I2C bus is hooked up to the video core, which boots the firmware to start out with. And what actually happens is that it reads an EEPROM that's hooked up to that I2C bus and knows what devices, or you can load a device tree in there that describes what's on the hat. And then by the time Linux gets that device tree definition, it can load all the appropriate modules for it. So on UDRx, it will, just plugging in the board will automatically get Linux configured, and we'll know that there's a UDRx there and can do things in both the kernel and user land to do that. We'll also be storing calibration constants on there for the UDRx board itself, so frequency offset and things like that, that we'll be able to correct. And that'll be on the board itself, so that if we have to do warranty, if the Pi goes bad for some reason, when you swap the board onto another Pi, it'll remember how it's calibrated. That's part of the Raspberry Pi Foundation's HAT specification. I don't remember what HAT stands for. It's like something above the board or something like that. But anyway, it's some cute acronym.
Thank you, Jeremy. So that'll be on there, and then it'll also store things like MAC addresses and other things we need to be in non-volatile. In manufacturing, every board will go through a complete RF test, full power, high power loads. We have a network-based spectrum analyzer to measure things. That's how we do all the calibrations. So we have a direct digital synthesizer which has fractional hertz resolution. So in addition to the 2.5 dBm oscillator, which really at UHF frequencies gets you in the ballpark, we're going to be tightly on the center of the channel. So that's one of the ways it's going to be a better radio before the SDR part comes in. How about the RPi 3? Well, when a more powerful processor comes out at the same price, you have to ask yourself, why wouldn't you use it? Well, the number one reason would be delivery, but they're starting to roll out now. My second concern is, because we're now single board computer based, people send me emails all the time. I found this really cool processor, you should use it instead. And I look at it and it has a 4-inch tall heatsink on top of the CPU. And I think, that's probably not what I want to use in a radio. So we're very concerned about power consumption, because we know a lot of these things end up in battery usages and stuff. But let me break a little bit there. I put a preliminary data sheet out on the product, and I kept all the numbers conservative, meaning I was pretty sure we could exceed them. Your typical mobile uses about, close to an amp in standby, so about 12 watts. We just powered a Pi 3 up in idle. it was consuming 100 milliamps at 12 volts. Now that's through our 3.3 volt buck regulator, 90% efficiency. So we're shooting to get you a package that's sitting in receive is going to be probably less than 1/4 of an amp at 12 volts. So it should be very efficient. That's before we get all of the Pi things, which I believe are coming to improve its power conservation technology. There's a lot of stuff there that hasn't been exploited yet. But it is a faster CPU. Jeremy, tell us about the CPU differences.
The main reason we're interested in Raspberry Pi 3 is not necessarily the clock rate. They upped the clock from 900 to 1200 megahertz, which is nice, but the bigger deal is that they moved core technology. So the Raspberry Pi 2 is on Cortex A7, and the Raspberry Pi 3 is a newer Cortex A53. And the big difference on the A53 for our purposes is the floating point unit. The floating point unit on there actually has the capability to do 2 wide floating point operations in its neon stuff, so it can do 2 floating points at once per clock cycle, as opposed to the A7 that can only do 1. So the SIMD performance on it is going to be a lot better, and that's going to translate into faster DSP sorts of algorithms that we can implement on there. So it's not, and the Raspberry Pi Foundation has kind of said this as why they chose that processor for the Raspberry Pi 3, because everybody's excited that it's 64-bit, even though the Pi Foundation is running it at 32, and they've pretty much gone on the record as saying, we didn't choose it because it was a 64-bit processor, we chose it because it was such a better 32-bit processor. So that's the main reasons why we're looking at the Pi 3 and are leaning towards that way to ship with.
Thank you. This also plays into the decision to move to a standard computer because the economics are there, and they keep making faster ones without us investing in the engineering. And if we're a year late on it again, it'll probably ship with a Pi 4.
Bad joke.
Demos. Hey, when you burn, you get to make these jokes.
You got medical insurance?
What's that?
You got medical insurance?
I do. I have life insurance too. But by the way, Seattle has a great burn center, I've heard, so good to know. So we have some demos set up in the hallway. A lot of you have already seen them. There's 3 platforms there. One is doing 9600 APS, and we now exposed the GNU Radio Companion. GNU Radio is in 2 pieces, and I'm pretty new at it. There's the GNU Radio code block, and then the GNU Radio Companion is a GUI thing on top of it, where you can drag and drop blocks, and that's where you drop in the instruments to check things. It's very, very powerful. So Jeremy's exposed that, he's got that going. He's also got another one using 4800 D-Star. And then we have the UDRC. But before I go to that, any questions about the UDR not related to me and fire? Yes, sir.
How low a voltage can you run the
How low voltage can you run the radio?
Can you repeat the question?
Yes. You just asked how low can you roll the radio? No, it's not a boost buck. That doesn't make any sense in applications. So we bring in a voltage, and we have a buck regulator which takes it down to 5 volts. We then take it down to 3.3 for the internal stuff. We take it down to 1.8 for one stuff. The Pi needs 5 volts. I spec the regulator at 8 to 16. So that's a design spec. I've tested it. It drops out lower than that, but I've also tested it over current. But for design spec, 8 to 16 volts. So yes, you can run it off battery power, and it wouldn't have to be a 12-volt battery. Now, if you don't run it at 12 volts, you're not going to get 25 watts out of it. Not my fault. But it will operate down to lower voltages. Other questions? Steve?
Steve, just a second.
I'll repeat the question. Kenny just wants to get some exercise.
What modes do you anticipate shipping it with that are officially supported?
What do you mean by modes?
Speeds, protocols, etc.?
Okay, so on the original data sheet, which we're still holding to, we will ship 9600 APRS, pardon me, 9600 AX25, and applications that support that, which include WinLink Client, WinLink Gateway, APRS Client, APRS Gateway. And we're also going to do D-Star, and we're including all the D-Star distributions to do IRC DDB Gateway, so you can do a hotspot. You can also plug accessories in and do all of those. There will be higher speed modes. So at a minimum, we'll probably do 19.2 and probably something like 56K. But we're not going to hold up delivery to get that big one out there a ways that we're still going to be working on. So as soon as I get everything working and I demonstrate at least 56K, we're going to ship it. More to come.
D-Stars require the dongle?
Do the D-Stars require the thumb DV?
Only if you want to use it as a client radio. If it's going to be a hotspot, then you don't have any decoding in there because you're going in RF and then out through the gateway.
Does the radio now accommodate the Pi app?
Pi DV?
Yeah.
Yes, the radio has, if you look in the middle of it, you'll see two 40-pin headers. One of them the Pi drops on. The one below it you'll see is labeled Pi DV. So that's how you get it in there. You could put a thumb DV on the outside. That's mostly a packaging choice. That is, by the way, one of the things that kills the Bluetooth on the Pi 3 is we need the serial port here, and they use that for Bluetooth. Other questions on UDRx? Yes?
Very simple question. Oh, of course, Andrew. All the way. Yeah.
Do you know if you can switch from RX to TX fast enough to do a TDMA protocol?
The spec for TDMA is 1.5 milliseconds, and we have demonstrated a frequency switch in 300 microseconds, and we can do a full power switch. We're aiming to be under 1 millisecond. So that's a goal. The radio will not support TDMA, but we're building the hardware in anticipation of that in a future release. Other questions?
Casey, all the way in the back. I'll get to you next, Bill. Mine's very quick.
Not sure if you went over it, but how are you handling the filtering across the supported frequency range of your product?
Okay, so this is a single band radio. So if you look at, let's take the receive chain. You come into a jump filter, you go into a preamp, you go into a SAW filter, surface acoustic wave, 430 to 450. That's a very steep curve filter. One of the goals is, there's a lot of people who want to build a very broad radio, because it has an attraction to it, but a very broad radio is never, I see head shaking, a very broad radio is never a very good radio. Lots of noise. So we kill it down, we preamp it, we smack it again. On the transmit chain, we come out, we smack it again. Then we have the typical low filter of the power amp. But before the power amp, it goes through another SAW filter to pull it in tight. The IF is another SAW filter. We have two IF paths. One's about 30K, one's about 180. And then that gets oversampled and brought down again. So that's the anti-aliasing part. And then we bring it down again in digital filtering to get our channel selectivity.
Bill?
Are you going to be supporting and testing TCP on the AX25?
I'm going to let Jeremy answer that.
I can't speak about supporting because that's not my call, but as far as testing, I certainly will be testing TCP/IP on AX25. On the receive side of things, we already have two different 9600 baud modems, both talking to the AX25 Linux stack.
So let me address the support side a little bit. So we sell this as an appliance with a web interface which allows you to do everything that we package in there. If you want to do something else, then you have to ask us for the keys, the root password for SSH. And when I give you the keys, you're going to click the box that says, I've now crossed the line and I may do something which is not supported or might break something. It'll be hard to break it, Bill, but you might break something. And if you do, go to ibrickmyudr.com and complain to the other people who bricked their UDRs. Now, the reality is, on those forums, if there's a real problem, Jeremy will look at it and go, I should fix that, if it's a real problem. But it may not be his highest priority. So yes, we'll remain an active part of the community. And there are an awful lot of talented people that I'm going to include you in that group and a lot of you in here that are, you know, software professionals, that I expect that to be very active, and we're going to be very open and supportive of it. So yes, you'll have support for that. Yes, you can do things beyond what we provide. No, we're not going to perform hand-holding support, but we'll be involved to make sure if anything's broken, it gets fixed. Other questions?
Brian, how are you going to handle pushing software updates to all of this wonderful software?
Jeremy can tell you about that. I mean, I can tell you about it, but it would be partly true.
We almost have completed our own Linux distribution called Compass. And Compass will be something that we'll distribute with UDRC and UDRx on flashcards. There'll also be a downloadable flashcard image. And we will push updates to the software that way. You'll do apt-get update, apt-get upgrade. For appliance operators, we'll make a clicky button on the web interface that essentially does that. But it'll be all distributed through Debian packages and our own package repository for Compass. And we will test out that. Part of the reason why we're doing it that way is we need some extra stuff in the kernel that's not available, so we're pushing our own kernel package into that repository. And part of our goal in releasing Compass is to kind of have a Raspberry Pi ham radio distribution that's available for everybody to use. So all the Compass stuff is going to be open source. All our kernel software will be out there in a GitHub repository. We will upstream as much of it as we possibly can, but there's just some stuff that's not going to be suitable for upstreaming that we're going to have to maintain ourselves. But you'll have access to that code in our GitHub repository. And we'll also be adding packages that are nice to have for a ham radio distribution, like the OpenDB packages, and we'll be packaging up things that aren't currently packaged, so that, again, if you had your own Raspberry Pi and you didn't even have any of our hardware, you could still use Compass and get some nice ham radio stuff on there. So that's how we'll be doing updates and distributions. We'll have Compass that will do all of that stuff. Right now, as far as the development cycle goes, I have the private repository done, a testing repository, and we're starting to push out the first test images of an SD card and testing those out to make sure they're ready to go.
So, for example, the codec we use, the audio codec, the TI-3204, which is a good codec, there was a Linux driver for it, but it doesn't support the SPI interface, only the I2C. So Jeremy built the SPI version and then pushed that upstream so everyone could take advantage of it. And then all of the stuff which is unique to our hardware chips, which didn't necessarily have Linux drivers or suitable Linux drivers, we created all those. There's a DDS, there's a SPI, there's an IQ transceiver. That's been abstracted using RegMap and device tree. And where it makes sense, it gets pushed upstream. Otherwise, it's just available open source as part of the distribution. Did that answer your question?
The last question is we let Brian go on to the rest of the slides.
Okay.
This is a question for Kenny. Is the ARETF going to flare to life now that we're in imminent danger of shipping?
That's a very loaded question. The ARETF is based on people actively wanting to make use of it. I think we have all the infrastructure there. We just need people that are actually willing to start pushing standards. To answer the question what ARETF is, it's a standards body group that Brian and I tried to get off the ground for amateur radio things. We've noticed that there's a lot of amateur radio standards that die and disappear, and this is to provide some infrastructure to keep those alive based on the IETF mentality.
So to answer your question, Steve, yes, we'll be the first people to start getting this, because we have to get it away from us to make it truly open and amateur radio. Because otherwise I'm at this cross purpose of, oh, you're just a radio manufacturer like everybody else. And in some ways we are, we're trying to make money. But we have to get all this stuff into the community separate from us. So yeah, we hope to be one of the first people pushing things over there and getting the discussion rolling. That was my last question. Did demos. The UDRC, the Universal Digital Radio Controller. We actually announced this last year at Hamvention, got a lot of interest. Who knows about the Yaesu DRX1 repeater deal? Ooh, a surprisingly small number of you. So a couple of years ago, Yaesu launched their Fusion solution with no repeaters to talk to it, and they kind of got panned because of that. So last year, they put together a program to sell you a repeater for $500 It's 2 mobiles inside the controller in a package. We have one sitting outside. $500. It's dual band. It's not cross band, but it's 2 meter or 70 centimeters. And for $500, it's sold like crazy. They've sold thousands of them. Now, granted, a lot of people are just buying them to have replace their old repeater because it does work analog or fusion, but it's been very popular. And when John Hayes got one of the first ones over a year ago, he looked at the connector on the back with the analog control port and said, I bet I can make the Yaesu repeater do D-Star. And I said, well, I would support that just for the PR value. It sounds like fun. So among great fanfare, we announced last year that we were going to put D-Star over Yaesu repeaters in multi-modes. So we built a Raspberry Pi 40-pin hat. I'm no longer calling it a 2 or 3 because it's really locked to the number of pins for the header. And we add support for D-Star and packet. It has a controller, has an audio codec, not surprisingly the same one as in the UDRx, trying to leverage our engineering here. It's got the buck regulator, not surprisingly the same one in the UDRx. And you could look at this product and say, well, I can do all that with stuff off the shelf. And the answer is you could. But there's a few people who will cobble one together, and there's a bunch of hands who will look at it and go, that's neat, can you make one for me? And the answer is, no, you got a junk box, go make your own. And this solves that niche of how do you get a good idea and how do you make it more prolific? So this is not a technological wonder, it just solves the problem of how do you put the whole thing together. On the DR1X, if you have the old firmware, which is 1.00 M through T, you can do count them 2 modes at a time. Well, all by itself, it does analog and fusion. So you can make it do analog and D-Star. Or you can make it do D-Star and fusion. And because the packet solution uses Dyer-Wolf, which as far as the repeater is concerned is analog, it could do D-Star and packet. And it has narrowband capabilities in the actual repeater, so you could knock it down to a 12.5K channel and do any 2 modes. We did testing with 3 modes, D-Star, fusion, analog, which could be 4 modes. And under certain conditions, the repeater locked up. But Yaesu fixed that in their 1.10D firmware release, which was December of last year. So if you have one delivered then, you don't have the bugs in it that caused a lockup, and you can do that. If you have an older one, you can return it to Yaesu for updates, and all you pay is the shipping cost to the Yaesu facility, which I believe is in Southern California.
Yep.
And John's already done 3 of them, and I'm sure they're anxious to hear them. Mine was late enough, I've already got the latest version. So that's a product we've come together, and then you can do all modes.
Does Yaesu shudder when they hear the word D-Star though?
Okay.
Please repeat the question.
Yeah. He's asking about what's the Yaesu reaction to putting D-Star. So when we announced this last year at Hamvention, our booth was next to the Yaesu booth. We had a big giant booth, and people would come through and go, Yaesu Fusion, Yaesu Fusion. And they'd walk out and there was a sign that says, use D-Star on your Yaesu repeater. People go like, tell me more about that. So as a courtesy, I picked up one of the boards, and I got a hold of Chris Wilson, who's the VP of Sales for North America. And I said, as a courtesy, I want to explain to you what we're doing and why we think it's important. And he was very gracious. And in fact, he invited me to speak at the Yaesu Fusion seminar. So he introduced us and said, this is Bryan from Northwest, and they're doing some interesting stuff. He kind of put us in a box as, oh, you know, it's like cobbled together, not real stuff. But that's okay. He allowed us to speak. We did talk about it. It's been on the Yaesu forum. I met with a gentleman from Japan, the head of engineering. I showed it to them, and they took it and nodded and said, yep, that's a thing. So officially, I can't imagine that they're thrilled about it, but you know, to Chris's credit, they really only had a couple choices. One, you could ignore it, but you know, hams are not like that. Two, you could say it's a bad thing. That would probably draw negative attention to them. Or three, you can embrace it. So I have to commend Chris Wilson for embracing it and saying, yeah, because one thing he pointed out is, one of the things, you know, sometimes ICOM acts like they invented the whole networking reflector thing. They didn't. That was done by amateurs. And so Yaesu realizes that just like that helped ICOM, that HAMS doing interesting work, homebrew, would help their fusion effort. Now, not everybody is thrilled with it. There's been a few people who've been vocally against it, but they're in the minority. Is there anybody here who thinks it's a bad idea to do more than one mode in the repeater?
Yaesu will sell more repeaters.
At a loss.
How they raised the price now, though? It's not $500 anymore, it's $1,500.
Is it 15, 17, 600? I've heard lots of stories.
$600 on their site.
I heard that they ended the $500 program and then opened it up again at 600, but that's a rumor, so go to Yaesu and ask them. But yeah, I think it's an important thing to say. There's more than one thing. And now that we've talked about that, let's talk about the elephant in the room. Who's doing DMR? A few people. Why?
It's different.
It's different. You're experimenting with it. Okay, so DMR uses its own protocol. So the funny thing is, if you look at digital voice, you got D-Star, DMR, Yaesu Fusion, blah, blah, blah. They are 95% the same in capability. They are 100% incompatible. They're incompatible with the air interface, they're incompatible with the protocol interface, they're incompatible with the network interface, and DMR and Fusion use the same ambi function, but D-Star uses an older one. At least they're all drawing from the same pool, so you can get one stick that'll do them all. The reason you won't hear me talk about, or literature that says we do DMR, is DMR requires a license from Motorola. And I have a copy of the license, I've read it, and there's no economic incentive to give Motorola a lot of money to do something we're doing now. Packet. Jeremy's got Dire Wolf running at 9600 packet. He's currently doing APRS receive out there now. So we add that capability to this, so you could take one of the Yaesu boxes and build a 9600 packet repeater. We've also got an add-on for a mini DIN 6, so you could make a client 9600 baud radio using any radio you got. Price and delivery. We did a prototype. We got hung up last year because Yaesu had the bug problem. They were talking about changing the way the repeater operates. They didn't end up doing that. They instead fixed it with a firmware internal upgrade. So we will have general availability by Dayton. It's $89.95, including the cables, the male-male cable for the DR1X, the mini DIN 6 for the transceiver data port. There's also a pad field in the back for if you have a radio that's not one of those two connectors, you can take a connector that fits into it and just solder it to the board. It's all through hole. So that gets you a way to get in there. On the board is transient voltage protection for all the pi pins. ESD, there's two ESD models. The one that come in chips is designed for manufacturing handling. It's not designed to go out in the field. If you want to put it out there and plug something in the back, you need a higher level of ESD protection. So that's on the board. And as Jeremy said, this doesn't include the Pi, but we will have an image available. So you can take an image, or you can get your own and you can get a hold of the source code, or you can buy an SD card if you really want a turnkey solution. Options. Well, these aren't really my options, but in configuring the thing mechanically, I wanted to make sure you could add the things which you likely might want. So one of them is a real-time clock, and we've got a little 12-pin header so the clock can drop on there. Because if in your remote location it doesn't have internet access, so you're not running network time protocol, that's something that you might want. You can buy that from somebody else. Touch display. One thing that's been mentioned is in a lot of environments, you know, these Pis that they're laying around, they're not very friendly to a typical RF environment. So I've got a rack mount box out there. We put a Pi in it. We put the UDRC on top. We added the real-time clock. We connected a display, and you can run all of those things simultaneously. So Jeremy will build the stuff into the current. There's a pilot board. It's a little different than the one that's out there now. A little 12-pin header. It has that EEPROM in the middle. Once again, that's the device ID, which is when you plug it in, the Pi boots, tells the Pi, I have a UDRC hat. So it knows what to do. That's going to be a boon to people who have struggled with getting out of boot and getting everything hooked up correctly. Any questions on the UDRC?
Available by date, which year?
Century. So, in spite of the fact that the UDR has been way overdue, we have now produced and sold thousands of other products. So we have a process to do it. It's Dayton this year. They'll be available next month. But thanks for the dig.
I'd like to mention to folks that the UDRC is also...
The UDRC is putting on, hopefully not putting on too much of a sales guy hat because I'm the tech guy, but the UDRC is actually nice for more than just the repeater sort of thing, because essentially what it boils down to for people in this crowd is it's a really nice Raspberry Pi sound card. That audio codec does sampling up to 96K at 32-bit. So it's a pretty good converter on there that's already integrated and ready to go. And if you want to integrate something other than a standard radio into it, there's header pins to do that with, as well as if you want to run modes that you can do into a 9600 pin on a standard data radio. You can do anything you want and have the plug in there all ready to go with it. So it's more than just doing D-Star on a DR1X, although that's really cool. It's also a really nice sound card for Raspberry Pi that's all integrated and ready to go for you.
You know, in some ways, it kind of does what the Signal Link does differently. It's like, here's a box, you could plug a radio in, plug it in, and you're done. Instead of like, well, how do I do PTT? We've taken the PTT, Squelch, we've got some I/O pins, we've got lots of stuff to play with there. So it's a really good experimenter's platform. Any other questions on the UDRC? Buster, who knows about the Thumb DV and the Pi DV? Okay, so Brian, among those products that we're actually producing and shipping is a couple years ago we came out with the Pi DV, which is a little daughter card which fits on top of the 26-pin header and adds the ambi function to the Pi. We later came out at the request of Flex Radio with a USB version, which is what they use now in the back of the Flex 6000 to do D-Star over HF. So the support, we don't write the software. The support at the time was we had the G4KLX suite, which is IRC DDB gateway plus dummy repeater, which works on Linux, Windows, and the Mac. No, wait, it never worked very well on the Mac. We also have WinDV, which works on Windows. It works on Windows. So a while ago, I asked Jeremy to take a look at the poor audio performance on the Mac and see if he could fix up IRC DDB gateway and dummy repeater. And he fixed it by writing a new one, which is, if you know Jeremy's, no big shock there. And he has an app which you can get from the App Store at Apple called Buster, which the biggest criticism to date has been, gosh, that's really simple and easy to use. So some people think it's because it's not complicated. It doesn't do what the other ones does, and it does everything the other ones do and more, including it's the first app to have, you know about the, like the ID51 has a GPS that reports location. That just gets put someplace. In the Mac version, you can actually click on the location, and via some stuff built into the Mac, you can get an actual location. Originally, it gave you a lot more detail, and Jeremy said, well, it'll actually give the address of where you are. That's kind of scary. So It just gives you lat and law and it gives you a physical map. If you have questions about Buster, talk to Jeremy. He can give you a live demo in the back. If you have questions about anything else, come now. Steve. No.
I was just composing an email to you, but since there's a void. Do you have any, for implementing voice modes like D-Star, et cetera, on the UDRx, do you have any recommendations for a microphone with a real push-to-talk switch so we can feel like real hams?
So the strategy for the UDRx is, okay, so first off, because it's headless, you need some way to control it. So you need something with a browser. You need a phone or a laptop or an iPad or something. So you've got to have that to set the channel and the frequency and everything else. You could use the speaker and mic on your computer. You could plug a speaker and mic into your computer and use that. Or you could plug a USB headset with push-to-talk into the USB directly on there and use that. Realize that you'd still need something to say, what channel am I on? Clearly the industry leaders, Plantronics, but those are pricey headsets. So once we get these things deployed, we'll probably grab a few, do some testing, and then encourage users to report what they're finding. Any other questions? Bill?
Does the UDRC support standard Raspbian? Would you require Compass?
It supports standard Raspbian, but you'll want Compass if you want all hardware to work.
It doesn't support standard Raspbian.
Jeremy?
Oh, the war is on.
The short answer is no, it does not support standard Raspbian, and the reason why is that the codec driver for the sound chip isn't supported in Raspbian because the 3204. So the longer answer is that it uses the Linux SoC, ALSA SoC interface, which the ALSA SoC interface is kind of mix and match SoC platform plus codec chip. Because what they used to have to do is if you wanted a 3204 on the BeagleBone, you wrote one driver, and then you wrote a completely different driver for the 3204 on the Raspberry Pi 2, and then you had to write a third driver for the 3204 on the Raspberry Pi 3. So Linux SoC abstracted those into components that you can mix and match. And part of what I've written is I've not only extended the 3204 driver to support I2C and SPI, but I've written a glue driver that glues the Raspberry Pi to the 3204. And those are not in Raspbian right now. There is a chance we will try and upstream those, but there's no guarantee that the Raspberry Pi Foundation is going to say, yeah, we'll include those. So that's why Raspbian is not supported. If you really wanted to run Raspbian without all our stuff in it, which we are basically Raspbian with, right now we're Raspbian with a new kernel package on it. You can download our package from our repository and do a dpackage -i. It will overwrite the Raspbian, the Raspberry Pi-bootloader package and do the right thing. And we try and but the next time you upgrade off of the Raspbian repository, it may very well blow away that kernel because it's a newer version and go. So you could hack it up so it runs standard Raspbian, but the long and the short of it is you need our kernel at this point in time to support it even on UDRC.
There's also some clocking issues with the way we do the clocking for the codec. So that's also a thing. And it's our intent to make it all open source and upstream whatever will go. But some things simply won't get adopted or won't get adopted in a timely fashion. So sometimes Jeremy's got to reach forward in time and grab a function like the clocking and backport it in and package that for you.
It is largely...
It's just not meant to hide it from you, it's just meant to make it a convenience.
It's largely the same issue as like the Raspberry Pi DAC has. They've gotten their stuff upstreamed, but it's the same reason they had to write a driver for their stuff that happened to get upstreamed. Whether we will be able to get our stuff upstream, I can't predict, so I can't tell you whether that's eventually going to be there or not. That's out of my control, but we will, the stuff that is appropriate to upstream, like that driver, we will certainly be trying to do so.
The source of that driver could be ported into the Raspberry Pi.
It already is. You can. We will have the source is already in GitHub. It's just in a private repository. When the time comes when we're ready for people to see that and it's not quite such a mess, we will flip the bit and you'll be able to go to github.com/NWDigitalRadio/Linux and you'll be able to see our kernel source. The intention on that is to open source everything and not have anything hidden from you guys on that. If you want to do something different with it and compile your own kernel off of ours, that's great. So. We're not trying to, Compass is not an excuse to try and stop people from using anything. Everything's going to be out there if you want to put all the pieces together. It is more of a convenience for people that don't want to put all the pieces together, that it will ship in a condition off of the Compass card where our stuff will just run.
And so, you know, to that point, you know, a lot of this is due to, well, like for example, so TI sells a chip and it says it has two control interfaces, I2C and SPI. SPI is 400 kilobits. Pardon me, I2C is 400 kilobits, SPI is 10 megabits. We use SPI, it's fast. They don't have a driver. In fact, I know that they never even tested it because when we tested it, it didn't work. So we had to go write something custom. So we're not trying to hide it from you, we're just trying to make the chip perform at its best. And by virtue of that, if you grab Raspbian and say, hey, I can't get your codec to work, he's going to say, well, there's the source code. Go read the source code, or just use the Compass kernel. Any other questions?
How's the thermal testing going? What kind of news cycle are you going to be able to?
Okay, so my goal was, okay, so the question was the thermal performance of the UDRx, the 25 watt package. So my goal was that at room temperature in a ham shack, you should be able to operate a 100% duty cycle with no fan. That was my goal. The original test heatsink, okay, how much time do we have?
4 minutes.
Okay, if we got 4 minutes, this is kind of interesting. Stop. Okay. Where are you? Heatsink. Numbers.
Which one? Probably both.
So we did initial prototype heatsink, and last year we put the brick module up there and got it up to full power. We did some testing. Now, you know how thermals work. People go, what about thermals? And it's like, well, tell me the ambient temperature. It's all about thermal rise. So the first thing you have to do is say, oh, are you in Phoenix and you put it in the trunk of your car under your down sleeping bag? Bad. Is it in Alaska sitting up on a pole? Like, not a problem. So you have to do thermals in terms of thermal rise. So here's a spreadsheet with an approximation for, given an area, what's the expected temperature rise. And the first test we did was column here, which is this profile. And the expected rise is 39 degrees. So at 20 degree ambient, I'm up to about 60. Under test, actual load, we hit 69 degrees centigrade after 45 minutes. So that's not hot. The module spec at 175. It's hot to go grab onto, but it's not hot from a semiconductor perspective. The module manufacturers recommend that the case temperature stays at 90 C or below. And my personal spec is 75 or so. But remember, it takes 100% duty cycle for 45 minutes to get to that temperature. Now, if you're going to put this in a repeater application in a remote location, put a fan on it. But my goal was met, but there's more. I'm not using that profile. I've got 2 more candidates that here's 28 degrees, here's 20. So we're going to try to bring that down. We do measure the temperature of the UDRx, and what you're going to find is in the unlikely event you ever got the heat sink up to 55, you get a yellow warning. Why 55? That's the UL spec for the maximum temperature for a piece of equipment with a metal handle that you're expected to pick up. So at that point, we cross the border from, hey, that's a heat sink, it's hot, maybe you shouldn't touch it. Or maybe you should just set your coffee on it. T. So these are the numbers we're looking at. This is going to become a non-issue. Once again, if you're going to be in a rack someplace on a mountaintop, absolutely put a fan on it. And there's a fan connector on it to drive it, and it's modulated.
You monitor the fan?
Yes.
Great.
It's a standard 4-pin fan.
Brian, I have a question from the internet.
Yes.
A filtered question from the internet, not a generic question from the internet.
Are you streaming?
I am streaming, yes.
And one guy actually watched it?
Actually, we were up to 56 people a little earlier. I think it's around 40 or 45 now.
Okay, so that's half the room.
Yeah. So we're out of time. But the question, I think this came from Don, although I'm not sure. Could this do GSM or LTE using GNU radio? And John asked me to pass it along, so blame Mr. Hayes.
Okay, so GSM is a cell phone spec. So it's beyond my capability to tell you everything about GSM. GSM uses GMSK, D-Star uses GMSK, but I don't believe we have the bandwidth to do LTE in 100 kilohertz bandwidth. There are people in this room who know more about that than I do, but my answer is going to be no. Okay. Any other questions? Last chance. Cut me off.
All right. Thank you very much.
You're welcome. I'm going out this way. Just in case.
All right, we have a 15-minute break. We've got some cookies and brownies and some leftovers, whatever.
screen now. Everybody, we're starting off.
Hello, test. Oh, yeah. Okay. There you go. Gotta be assertive.
Without.
Cookies. Open the cookies. Cookies are closed.
Cookies are closed.
Scott. Scott.
All right. Our next speaker is John Petrich, W7FU. He was first licensed in 1955. He remains active on the air as an avid builder and experimenter. For the past 10 years, he's been studying digital signal processing, DSP, and software-defined radio, SDR technology, to the point where his entire station, 160 meters to microwave, is implemented as an SDR with homebrewed DSP software. He's published 2 articles on DSP for QEX magazine and maintains a website devoted to DSP, www.w7fu.com. This presentation is about his most recent project, an affordable SDR transceiver that provides multi-mode operation from 50 megs through 6,000 megs. Please welcome John Petrich.
Wow. You know, Scott, none of that sounds familiar, though.
Did I read the wrong one?
Yeah, you read the wrong one. Anyway, good afternoon, everyone. It's a pleasure to be here, and actually it's a pleasure to meet a lot of friends from the MicroHAMS and the Radio Club of Redmond and other acquaintances from previous digital conferences.
You're not your friend.
Actually, I wasn't including you. I was speaking to Mike and Peter and a few other people. Anyway, this is going to be a pretty high-level presentation of an SDR transceiver and the concept.
Don't break on it.
I shouldn't be trusted with sharp objects, I guess, either. Anyway, and the consequent logic of a potential ham radio, VHF, UHF system. There's going to be no I's and Q's discussed, no Nyquist equations, and only a casual reference to Shannon at the very end. So anybody who finds this stuff kind of challenging, you can relax. I think it'll be entertaining and illustrative. The agenda is to look at the advanced integrated circuit and SDR technology with the UHF in mind. And we've seen some of that already today. I'll make reference to that with the Arduino and with, I think Alex has left. I think he has left. And his project there with his SDR for the HF rigs. I'm going to show some photos of my rig and some selected performance data. We're going to take a little journey into a UHF microwave SDR system from the perspective of our traditional analog phase 1 implementations. The inflection point for me on all this, to pick up on what we heard this morning from Ward, was back in 1990 when Gerald Youngblood published his articles, a 3-part series in QST of, well, I thought it was QST. Well, in the ARRL publication on software-defined radio, push the wrong one, for the masses. And that was like the first generation SDRs. We're in the second generation now. This rig here is a UHF microwave multi-mode, and that means not just AM and FM and single sideband and CW and it's any mode you ever want to program. It's got the bandwidth capability of doing that. It's a direct conversion SDR, hence some of its unique qualities and opportunities. It's a single board solution, and it's sitting out there with a little blue light blinking on the demo table. And it uses open source DSP software, and we heard a lot of that from Jeremy and all about the GNU radio. It's a great program for system development. So here's the project description. The hardware is an Edis Research B200 SDR transceiver, and I'll show you the details about that. It was released approximately a year ago now. It's a single board. I have the maxi version, which is 6x4. They make a mini version, which is 4x3. It uses, and I'm not quibbling on the words here, it's a state-of-the-art RF and baseband performance, and I'll tell you why. The transmitter output, this is about, you might say, a little less than 100 milliwatts, around 100 milliwatts. Actually, I get more, but say 5 dBm. And the receiver noise figure from 6 meters through 6 gigs is approximately 2 dB. It's low at 6 meters, and it's like 2.4 dB or 2.6 dB at 6 gigahertz. The software associated with it, which is the digital signal processing software, the DSP, is GNU Radio open source software DSP library. And anyway, it's a Linux operating system, Ubuntu preferred, and it offers the option of graphical DSP authoring. You can move blocks around and connect the dots, and make your DSP flow graph and your radio work. Again, we'll talk more about that. Here is a fuzzy photograph of the B200 SDR transceiver. And the reason I have it here, despite it being fuzzy, is it points out the architectural highlights of what a second generation modern software-defined radio looks like, whether it's microwave or HF. This right up here is an RFIC, which is maybe a different model and make than we heard about with the Arduino board, but it's the same thing, same principle. It's inside this PC barrier you see around it, RF barrier, and these are the input and output, transmitter and receiver. Just to the left of it here is the other part of the SDR, which is an FPGA. And the FPGA, I'm sure everyone has at least some awareness of what an FPGA is. It's a logic element into which one can code DSP processes. So it's the very beginnings of the software aspects of the radio. The A to D conversion is done in this RFIC, and it crosses the barrier and goes into the digital section here with the FPGA. This other little block here is a USB 3 interface, and then USB 3 comes out here. Up here is the clocks, the clock system, and this empty space up here is room for a GPS module, which you can accessory module you can plug in and use if you want to. I haven't. These are a 10 megahertz master clock, which you can use for, say, from a GPS or a crystal oscillator. And then these are outputs, 1 pulse per second or 10 megahertz output. So here you have the architecture of the second generation SDR, an RFIC up front, digitization to a FPGA, to a data link with clocking and power supply, I forgot to mention down here. If anybody has questions, just put up your hand. Let's see, who's the right button here. Here is a block diagram to complement the picture. And it's exactly the same orientation with the receiver and transmitter coax connectors here. The RFIC, in this case, mine is the AD9364. They make another model, the 62, which actually has 2 transceivers, one here and one there. This fuzzy stuff here is the kind of the modern schematic block diagram representation for an I and Q channel. And the INQs are generated in the analog section of this RFIC, digitized here in the ADC, or for transmitter, the DAC, goes into the FPGA. It's a Spartan version where they have basically a replication of the quadrature mixer system, but done digitally rather than analog, in an analog format. Keeps going out this way, and you end up with the USB 3 controller. The little clock corner I showed you, it has a temperature compensated crystal oscillator, and I guess it's not clear here, the option for the GPS. This is a blow-up of the RFIC, again, an analog device. And its orientation is flipped, so in other words, am I right? Yeah, the input is over here, and the output is over there, kind of opposite to the other diagrams. It's interesting to look at this. I don't want to get lost in the details too much, but what this depicts is they have a number of receiver front ends for the different bands. They tend to break this IC down into like a low band, a middle band, and a high band. The low band is from 50, say, to I think it's about 800 megahertz. Then there's a middle band from 800 to 12 or 2 gigs, and then a high band above that to 6 gigs. And all that is a graphical representation of the different receiver front ends. Again, the INQ mixers, analog filters here, bandwidth filters, it's also in the transmitter. These are all analog. The A to D converter, the data interface, and then it goes to the FPGA. I see. Alex, hi. Yeah. What's your question?
Well, I was just wondering what's the bit width of the ADC?
Alex is asking the bit width of the, oh yes, I know I thought of that during your presentation. What's the bit width of the ADC? It's only 12 bits. Now, we have the option in this, don't want to get too technical, of oversampling. And when I build my rigs, I oversample like crazy. And you know, I understand, I'm no expert, that you could make a 12-bit ADC function roughly close to a 14-bit or more ADC by oversampling. That quantization noise you mentioned in your presentation. Yeah. I was paying attention, I was a little embarrassed, but you would ask. Any more questions? Okay.
Actually, I do have one.
Yeah, Mike.
This wasn't developed for ham radio experimenters. Why did they develop this?
Yes.
For what market?
Yes, yes. That's actually a very good question. Mike Morantz asked, why was this RFIC developed? It was developed for cell phone base station use. You know, so that's the market. However, in the cell phone base station world, where they have these exotic, I would call them exotic because I'm an outsider, modulation modes, you know, like 64 QAM or 128 QAM. And I've even done 256 on this little baby. You know, they have a real premium on these figures of merit, like the linearity of the transmitter, the phase noise of the oscillators, and maybe other things that I can't remember right now under pressure. So it's really a high quality, that's why I said state-of-the-art product. And I don't want to sound like a salesperson, I'm just enthusiastic. So we are fortunate that the cell phone industry wanted this and that it's affordable. Now, we're moving on, that's the hardware. And then the sort of, what is the configuration for a modern second generation SDR. Now, I'm calling this advanced DSP hardware, software. And I put that in quotation marks because it advanced from a certain perspective, maybe from a ham perspective rather than any other perspective. It's an open source DSP library, which is appealing to a lot of people. That's sort of the good news. The bad news for some people, although it's not a problem for anybody who gives it much thought, you have to use the Linux operating system. It does work in, and I see Jeremy smiling back there, because we know it works in the Mac OS and Windows, but I think people have more trouble with it than they do when they implement it in Ubuntu. It uses simplified graphical DSP authoring as an option, and I'll show you an example of that in the next slide. You can program it, it has a C++ API, you can use Python, or you can use the graphics. And I said simplified here because graphical DSP authoring isn't unique to GNU Radio. It's seen in MATLAB, and it's seen in, see some people nodding here, National Instruments LabVIEW software. However, my limited experience with both of those is that they're pretty complex. They may be able to do more DSP processing in different ways than GNU Radio does, but it's a heck of a lot more complicated, and my simple self, I found this much more user-friendly. That's why I call this advanced for the ham. The other thing about it, it's optimized for real-time signal processing. I know Alex mentioned something about latency. He was talking about different things, but there is almost no discernible latency in my rigs when I transmit voice or CW or anything like that. I know it's got to be there, and I can sort of hear it, but it isn't at all very easily detectable. So it's just great for ham products. Volk is I said it's C++, so the code runs pretty fast. And Volk is a module they put in this GNU radio to somehow tie into the specific kernels you have on your computer to optimize the data flow. And all computers don't have the same kernels, so it's some sort of a vector optimized kernel module. This software supports receive and transmit. Again, advanced from the ham perspective. A lot of the software that you and I can get off the internet and download and use successfully for reception purposes, there's no transmit option. This you can transmit. One nice feature of this GNU radio, and what I think makes it advanced, is that a lot of the new development by young engineers is in the Ubuntu, Linux, open source operating system world. And it's very easy for these new products to link up with this software via the universal hardware driver. And that just comes with the package. So they write a driver for this interface, and they can sell their product and claim that they have a GNU radio interface. It's developed and maintained in conjunction with the Edis Corporation, which is a subsidiary of National Instruments. And why do I say that? You know, it's a big-time operation. It gets a lot of support. I think it's serving as a unifying influence for people who want to develop new software radio technology. So here is the flow graph you've been hearing about and that I mentioned. This is just happens to be, it's totally random, a single sideband transmitter, and it just happens to be configured, I notice here, for 80 meters, but it's the same one that I use in the microwave transmitter, or a similar microwave transmitter and all. And just to walk you through it briefly, you notice that there's only one line in and one line out instead of multiple parallel lines, and that is what you sometimes find in some of these other graphical interfaces that I find difficult to use. Single sideband transmitter. This is my microphone, audio source, and then it gets sampled and goes through a volume controller, a gain. It gets converted to a complex INQ in here, and all you have to do is see blue, INQ, blue, INQ, blue, INQ, blah, blah, blah. And then you go through your filtering, upper and lower sideband comes around the corner. You add these together where the upper sideband, say, add and becomes twice as strong, 3 dB stronger. And the lower sideband cancels out completely and is absent, virtually absent. And then this goes to the transmitter, the USRP sync. Okay, So that's a typical flow graph. This flow graph I show you, looks kind of a little bit daunting, I would say. But it can be simplified using a little more advanced DSP techniques. And the one I typically use, actually all of this stuff here is just replaced by one single DSP module, one little block. It's really cool. Any questions about the flow graph? And you can do radio. Yes, Phil?
You might talk about the experience we had when trying to get on the 2-meter or 70-centimeter repeater, I think was what it was at the time, where the tone was inserted in one place and didn't work out so well, and you reconfigured it, and within 10 minutes or so, you're on the air again.
So Phil, he and I have worked on this together. He's helped me with this presentation and with my radio development. And he gave an example of, we were talking on a 70-centimeter repeater and 2 meters as well. And the radio worked, but as soon as I cranked up the volume on it, it stopped working. And he was just commenting that just a couple minutes I was able to reprogram it to get rid of the problem. And what it was it's not here, this is not an FM transmitter, but the PLL tone was in the audio spectrum, and then when I would talk louder or turn up the volume, the audio would mask the PLL tone and I would drop out of the computer. So, and we didn't know that, didn't anticipate it. And I don't think either of us really knew that, but he encouraged me and I made a few changes and back on the air ever since. So it's very flexible, I guess, is what Phil is suggesting. Any more comments or questions? Yeah.
To go back to that previous slide.
No, Dennis, I won't. No, never.
Oh, God.
Just because you asked.
Can you stick in like little oscilloscope
yes.
and look at frequency response,
yes.
all that stuff?
Yes. Bryan was absolutely correct when it comes to troubleshooting and debugging, yes. Unfortunately, I just did this part of the screen. Over here on the screen is the DSP library. It's just not depicted here. And you can go down a list, a pick list, and choose an oscilloscope. And then move that oscilloscope, and I can put it right there. Or a FFT or a waterfall. Yeah. So, but absolutely yes. Because the problem I had with the single sideband transmitter, you have to get the 90-degree phase shift, and then you got to flip it another 90 degrees to get a 180. And I needed the scope, because I don't know these things. I had to sort of do it empirically. This is the user interface, the GUI, for the microwave transmitter and transceiver out there. I chose to use a waterfall here instead of a pen adapter. And this is just scope control stuff. Here is like an example. This one's on 1296 actually. Signal strength, there's no signal. I don't know why it says 106 rather than something much lower, but this one says. I can select the bands if I wish. I can tune it with a slider. It's not a knob, but it's a slider. The AF gain is just the volume control. This panel down here, you just click on it, and it goes from receive to transmit, from transmit to receive. I could monitor myself. I can choose modes. In this case, I just did USB, upper side band, CW, lower side band, receiver bandwidths, power level. I can change that should I wish, and RAT. So that's just an example among the many operational controls that one can implement in this kind of software. It's a bit clunky. It's a WX GUI, and I don't understand the differences, but they're working on developing a QT GUI, which is what you're seeing out there in the demo area at Jeremy and Bryan's. They're using a QT GUI, which supposedly offers more performance and a better look to it. But this is what I did in a WX GUI. Well, here are some performance measures. And I just chose these at random, and again, they're not a list of statistics, dBs and things like that. They're just some ideas that one can do with a DSP to optimize the radio for your particular use. I'm going to show you a filter bandwidth that's optimized for UHF operation, at least my concepts of UHF microwave operation. I'm going to show some spectrum analyzer outputs of spurs and phase noise, because that was a concern of mine about the RFIC. You know, did it really cut the mustard? Here I'm using the oscilloscope, but actually the FFT display built into GNU Radio to test my receive filter. Now, what's special about this? Well, what I can do is, maybe I'll stand over here this time. I can easily adjust how steep or shallow this cutoff is. This is an arbitrary value. I can arbitrarily, you can see the bandwidth here, 0 to 3. I can make it narrow or wide. I can adjust this characteristic, and this is where I'm getting at here. The corner here, make it Gaussian, and or I can make it sort of a brick wall corner. And for VHF and UHF weak signal, which is what I kind of built this around, usually you're talking about signals that are in this top 10 dB of the filter bandwidth. So I don't care too much about how steep or how broad this is down there. Adjacent channel interference isn't a big issue with UHF, it's noise. So I get my noise bandwidth here. And a bandwidth which I often use for weak signal work on whether it's HF or VHF is 50 cycles. So it's really tiny here. And what you do when you move this into 50 cycles, you see you get a nice Gaussian distribution. There's no ringing that I can detect. It's real smooth. Seems to work just fine. So if you don't like what I've done or think it's very smart, change it, because you can do it within the software. Any comments or questions about using the scope or adjusting receiver characteristics or anything? Here is a couple series of slides. This is at 5.6 gigahertz. You can see, a few things. You got this spur here that you can't see, and the noise down there. And this is acceptable for microwave work. Very acceptable. Where am I here? This is phase noise on 1296. The span is only 5 kilohertz here. Any comments? Anybody troubled by that display?
I mean, this is all the system monitoring itself.
Mm-hmm. Oh, well, this is an outside spectrum analyzer.
Oh, okay.
This is
Thank you.
closed circuit.
Yeah, that's fine.
Or, maybe I said that wrong, but it's that wrong. Okay, so now I'm going to get into what I think might be some of the logical implications of what I've just shown you, the direct conversion microwave transceiver. Let's look at the standard analog system. It leverages very highly developed, high-performance transceivers, your Kenwoods, your Icons, your Elecrafts, for the IF function. Then they have, over time, had sophisticated UHF microwave filters, low noise amplifiers, and power amplifier technology, which of course will get better over time, but it's really pretty great right now. And it's a proven overall system design. Ask the people that are working the moon all the time or doing meteor scatter on 6 meters and covering vast distances. Works good. So I'm not going to ask the question though, well, why not improve the transceiver performance and potentially the operating flexibility with an SDR? But why not build on the proven analog system approach with an SDR, the amplifiers, the low noise amplifiers, the power amplifiers, and the filters? So in a block diagram, this is the traditional or typical analog ham system. an HF transceiver, a linear up converter, or series of converters. Sometimes to get in the microwaves, you need 2 up converters, and then your analog interface to an antenna. So what I propose, with maybe a little bit of imagination, you can just have the same little old 6x4 SDR transceiver going directly into your amplifier interface and custom. Okay, so that's maybe see the picture. Here is my early version of my station at home. This is the little 4x6 transceiver over here. This here, as this is a very small computer case, in here it says to 1296. Actually, I have 450, but I just extended it to 1296. My analog interface, and in there is a transmit-receive relay, a filter to filter out the FM broadcast band, which causes a whole lot of trouble in the front end of this SDR, and a series of power amplifiers, and it gives me about a quarter watt on 1296 and about a half a watt on 70 centimeters down to 6 meters. So that's just an example of what I just showed you. It's not the end. Let's see. In the back is the output coax connector, and then I have solid-state power amplifiers for some of the other bands, like 2 meters and 70 centimeters that go up to, say, 100 watts easily. This just is a bit of a gag. This is on the microwave where I don't have an interface. You can connect the SDR to a log periodic antenna and transmit across the room, I suppose. Move the antenna closer to the receiver. The man suggested I get a longer coax cable so I can move the antenna closer to the receiver. A good idea. Okay, so here's the question. Is SDR the new normal? With digital signal processing, I've gotten some pushback on this, but you get near ideal signal processing ability. Not ideal signal processing, but near ideal signal processing. It has a lot to do with the ability of your computer to manipulate single precision floating point numbers. That's pretty good. I call it digital determinism when I'm bragging about the rig. It's pretty hard to beat it. And you can approximate the Shannon limit in any communications channel by having a tight, well-contained DSP. You get wide design flexibility that supports all existing available amateur bandwidths. And I don't even know what they all are, but I know I can do it. It integrates well with existing RF systems. I gave an example, just a couple slides ago of a UHF microwave system. But on the HF, I have a system, same thing. It's a bigger black box, but it's my SDR, bigger black box. And I have 100 watts from 160 to 10 meters. Simple. And with an antenna tuner, automatic antenna tuner. The size and weight of the little 4x6 board is attractive compared with some of the analog counterparts. I promised to mention the Phase 4 satellite, and real briefly, I don't think I'm out of time. No, I got it all good. Phase 4 satellite is right now, I think, a gleam in some people's eyes. There's it's associated with the Air Force, and we have a potential for a ride share, I think that's what it's called, where they give you a perch on a geostationary satellite, like a little square thing. You put your satellite in it and you plug it into the power grid, and they'll put you up there in a geosynchronous orbit. It's hopefully will be launched sometime in 2018, maybe early in 2018, but it's uncertain. And what's a little different about it is that the uplink will be in the microwave range. It'll be a 5 gigahertz uplink. They say you need maybe a 3-foot satellite TV dish, I'm trying to think of the name, and maybe 1 to 5 watts at 5 gigahertz. And there's some technical challenges here, but, and then the downlink is very similar to a cable TV 10 gigahertz downlink. It's about the same size antenna, maybe 3 feet, with a, on the front, the feed, the mixer, the low noise amplifier, and then a coaxial cable that comes down to a box in your shack, a receiver, at 1 gigahertz. In other words, it's a mixing system. So that's what's that's being envisioned. They have higher order modulation potential that allows major increase in the data rates and results in more and higher fidelity information throughput. And Phil gave me some of these numbers here. Within a 3kc bandwidth, you have 256 QAM and PSK31, and you get a data rate that's greater than 10 times the data rate. So there's potential there. And when I say data, I realize I'm talking to a lot of people who are hams here and not technical experts in some things. Data just means numbers. When my DSPs, when I transmit my voice in single sideband, inside the DSP it's just numbers, it's just data. And I talk about the data stream. I didn't today, but in the DSP. It's a data stream. But when it comes out in my voice, good or bad. And so what we're talking here is not just packets of information. Maybe it's packets, but it could be your voice, it could be a video, could be just about anything else. And Phil, you're going to want to say something. No. So that's about it. I think we're at the end of the presentation. And oh, well, no, we're not quite yet. Sorry. I want to thank a number of people. Mike Garrett, back in Illinois, Barry Hansen, local, a lot of you know him, VHF, Phil over there, Mariana Voroto sitting over there for their generous assistance with this project. And I want to thank MicroHAMS again, as I started out saying, for this opportunity to present. Okay, down the slippery slope, it could happen. More information about DSP and SDR. One of the resources is on my website. Another resource is GNU Radio, www.gnuradio.com. And there's additional learning opportunities here on the Microsoft campus, interestingly enough. The software-defined radio special interest group. It meets on the odd month, so January, March, May, that type of thing. On the third Tuesday, sometimes the fourth Tuesday, from 6 to 7:30 here on campus. We have a Facebook page here. You can check in to get more information. And if anybody would like to attend, I wish they would check in via the Facebook page. Everyone is welcome, but we have understandable restrictions as to the use of the property. It's after hours. We have security issues. We've got to know the people who are coming and follow the Microsoft rules. So we start out just not by opening the door, but by asking people to indicate, like an RSVP, whether they're coming or not, and who they are.
John, what's the meeting date this month?
The 29th.
Oh, thank you, Peter. Yeah. Here's some FAQs about hardware. Are there other SDRs, transceivers? Are there alternatives? The short answer is a big yes. This is Hack RF by Great Scott Gadgets. There's the whole Edis family of SDRs, quite a large and I might say somewhat expensive family. And then there's this new product which I'm kind of excited about, is the Blade RF by nuand.com. I kind of sped through the presentations and didn't go into it, but they supplement their FPGA function with an ARM processor. And that's, it's not necessarily a compromise at all. It may be a performance enhancement that we're seeing more and more in SDR designs. So any one of those three are certainly ones to look at. And we just heard earlier today about the Ham Shield Arduino. Is it an SDR? Oh yes, by all means, it's an SDR. Wonderful design, but with a different purpose. and it's not compatible with GNU Radio, just to say that. So that you don't get the flexibility of GNU Radio, but you get other advantages in the ham shield. What about the software? Does GNU Radio function with Windows? And I say sort of. It's hard work with significant limitations. They're working on it. In fact, they just announced coming up March 25th, they're going to have improved Windows drivers for, so that's next week, for GNU Radio. The fact of life is, though, that the developers are primarily oriented towards the Linux operating system, but something to consider. That's where I started, was in Windows, and I have to say it was a bit of a blow when I realized I really couldn't get where I wanted to get, and I had to change or migrate to an unfamiliar operating system at that time, Linux, but it's not too painful. How do I get started in GNU Radio? And I gave the wrong URL, it's org instead of com. This is their website, and this is what these two websites are all about, mine and theirs. General GRC DSP information oriented to beginners. There are some very high falutin details that the real developers can dig into, but there's a whole section on just getting started for beginners. Well, what about homebrew UHF SDRs? Yes, you can make your custom software and you can make your custom analog interfaces, but as you can tell from the photographs and things, the FPGAs and the RFICs require automated assembly. This particular FRIC has 114 ball pins on the bottom. And I don't know how I'd ever do that with my hot plate or my soldering iron. Impossible. Where do I turn for more information on VH and microwave opportunities in the area? And that's where I mentioned one of the collaborators was Barry Hansen, K7 BWS. The Pacific Northwest VHF Society is very active locally and sponsors a wide range of operational activities and is a source of good technical information. This is the VHF Society website. It's just interestingly enough, we're really fortunate. They are nationally recognized. I mean, everybody thinks they're important, but when you look at the ratings of the VHF societies based upon operating activity and things, surprisingly enough, this particular society is right up in the top 2 or 3. Central States or East Coast, MILT are all on the club. So any questions about hardware, software, or other topics? Yes.
The talk was originally, there was a mention of 100-watt output, and just curious about that.
Well,
especially wideband.
Yeah, well, not the wideband, that's for sure. Just to make it brief, I actually don't know where the 100-watt part came in because I have another project, a 100-watt HF system. Okay, so I think somebody conflated a couple bits of information. But I mentioned narrowband, on 2 meters and on 432 at 100 watts, but not wideband.
Here.
Oh, yes.
Not so much a question, but just a quick comment for anyone who's interested in experimenting with GNU or GNU radio. There are images online that you can get that you can actually put on a bootable USB thumb drive. If you happen to be strapped to Windows, you can actually pop that in, boot right into the environment, and do that without having to reconfigure a totally separate system. It's pretty handy.
I wanted to, may I respond to that? I think that's very relevant, and I'm sorry I forgot to mention it. The buzz term within the world is live USB, they call it, capital L-I-V-E, USB. And they're really promoting it. Those of us in the room that use GNU Radio all used it at one time or another, and it works just great. You're limited by the bus speed of your USB port. So it's not really great sometimes for running rigs, or if you're hyperactive, you want things to happen quick. But it's just an excellent way to do it. And all you need is an 8 gig memory stick and follow the directions, and it works great. Yes?
Yeah, I just had a question. In terms of the radio output of the SDR, I can't remember the model number, I think it was B200. Is there a lot of harmonics on the output, or does it do any sort of internal filtering? And how would you envision a chain of filters and amplifiers maybe to bring up to power levels where you could work a local repeater easily?
Yes, I could see why you're asking, given your experience with the Shield. Let's see, I showed the slide of one of these. That's close in. Oops, I guess that's as far out as I went. 500 kilohertz. The harmonics, though, are pretty well suppressed, and I just can't right off the top of my head quote you any numbers. Because it's so linear, your third order products are way down. And in terms of transmitting, my philosophy in my shack is I put the low pass filters on the output of the amplifiers. So like my 100 watt amplifier, just as an example, has a low pass filter, 2 meter amplifier has a low pass filter. My 100 watt 70 centimeter amplifier has a low pass filter. So that's how I handle it. It's wide open otherwise. But the third order products, as I said, are down simply because the linearity is so good. Down, way down.
The 809364 IC is spec'd down to, your RFIC is spec'd down to 70 megahertz, but you had it working down to 50. What kind of problems did you have in doing that? Would it might work down to, some of them might work down to 10 meters, maybe? I don't know.
So what he's asking is, obviously, it's spec'd from 70 to 6+ gigs. But I didn't have any problems, by the way. It's pretty well known that it easily gets down to 50, and I didn't bother with it, but some people are getting down to 32 or 34 megahertz, not quite 10 meters. And I think what happens is, and I don't know for sure, that the specs starts falling out of spec in terms of spectral purity and other aspects that I don't understand. One thing I thought to mention here, the bandwidth of this system, potential bandwidth, is the baseband is 56 megahertz potential, and I can sample rate at 56 megahertz. So what I think is that when they design a system that could sample at 56 megahertz, they put the low end of the RFIC at some number a little bit above that, like 70. Okay. So it's maybe a combination of some specs and then a combination of the fact that this is spec'd out to sample at 56 megahertz. Now, normally, by the way, that's crazy bad. Actually, Ward mentioned that, how we could maybe sample a whole spectrum and gather all this data and work with it. Well, this is what the design philosophy behind these units. And this is not one of the largest instantaneous bandwidth sample rates that you can get, but it's this sort of the state of the art. You get a lot. Yes, Dennis.
John, it looks like the bandwidth of that carrier or whatever it is about 100 hertz, but I'm only guessing. Was it that narrow? Or you can't exactly tell.
No, you can't. And now you're referring to this part or that part?
No, that part.
Okay. Well, I don't think this is the way to tell that. It's a CW signal. And as long as you get, as long as you get your bin small enough, it's going to. Okay, the CW signal. Yes. Oh. Well, you have another comment. Please go ahead.
On the question of bandwidth, 70 megs up to 6 gigs, that's that particular B200 product. As with most manufacturers, they have different models, particularly Edis. That one, the USB model, happens to be a little bit older. That's its bandwidth. Some of the other models actually work with daughter cards that allow you to more accurately get down DC to daylight. So it's kind of your selection there based on what you're doing. And the GNU environment works with that or any of the RTL sticks, the SDR play, that type of stuff. So you can literally plug in multiples and play wherever you want.
Anybody have a comment on that comment? This is where the UHD, Universal Hardware Driver, comes in. The list of radios that it will work with, whether they're transceivers or just receivers, is getting longer every release, and they release at least twice a year. So there's quite a few options, including the dongle, using the Universal Hardware Driver. Well, I think, Scott, we're done. Thank you.
Thank you very much.
Open speakers.
So to me, yes, it's something to think about, but at this price level and the fact that it's an amateur event, you have not hired a professional conference organizer company to come in and run it for you.
So, I mean, I don't have a problem with it. I still look at it as what we want it to be. They charge their own price. Again, they're charging their own we don't have feedback questions about, so we're not doing a full-fledged webinar. We're doing a full-fledged webinar. What are you doing?
What? Well, you probably, I don't know.
You didn't hire a WebEx, you didn't have a contract with Akamai content distribution.
No,
there's just none of that.
we're just touching the
Okay.
And this was an experiment.
Okay. What time is it?
So next year, next year, we can consider charging you for that. Again,
We'll be up for like.
$100 on the road.
Is that done yet?
And the rest of it's all for free. It's not like you're not getting your money back.
Your Google has a handle, right?
Yeah.
Okay. It's ready to go. I pulled all the stuff. It was kind of disgusting. One of the cans ruptured in there. So it looks like somebody took it. It's all brown. The water's all brown.
I should go dump it out. Is that what you're saying? Thanks a lot. Hey, Scott. I'll get you for that.
Good. I hated it. I was just like, oh. I opened it up. It's like, that's the one with the water. I was like, I'm willing to drink it. Man.
You know that. So, just to let you know, when we streamed out that recording, when he announced he was going to have a product and put him on fire. Burned him in effigy. His name on it.
Poor Bryan.
So that everybody knows that we lit him on fire.
You know the thing about the speakers too, is that the ones that have presence, they hear really loud, people are loud. The ones that are low, it's like Casey is great. John was a
Yeah, I got it. Yeah, if you're close to somebody, but his naturally he's pretty quiet.
Naturally did actually.
I always want to make a show.
I told him to the back of the room.
So you ready to go here?
All right, let's go ahead and get started again. One more to go. You need an audio test? Is that what you're looking for? All right.
Where you want to fill the scope?
Scott.
Phil.
Testing 1, 2. Okay.
All right, let's go ahead and get started.
Scream into the mic.
I put that on because John suggested it. Drexel.
You always do everything John suggests.
Well, I guess discretion is important.
All right, so one more to go. Then we have our raffle, and you can. Thanks for hanging in. Looks like most people are still here. I wanted to introduce Phil Horkin, AF7GY. Phil was first licensed in the mid-1960s while junior high school in Southern California. He'd been away from Mojave for more than 45 years while finishing his public school and college, but never far from radio technology. After receiving a BSE from Drexel University, he began his career developing communication systems and RF payloads, and has continued doing this for more than 40 years, the majority of which was on satellite systems such as Iridium. Many of these systems have pushed the envelope to achieve very high channel capacity as available amount of spectrum has been diminishing, while demand for spectrum has increased. In his consulting work, a current client is pushing the boundary on channel capacity well beyond anything it ever demonstrated, and his line of sight MIMO, coupled with some novel polarization tricks, is one of the solutions being studied. This presentation will show how these techniques may be used to achieve bit rates 20 times the channel bandwidth or more, e.g. 20 megabits in a 1 megahertz wide channel. Please welcome Phil Horkin.
Thank you very much, and hope I don't put anybody to sleep, or it's getting late in the afternoon. And just that last point, the 20x, that's a slight exaggeration, I think. It's at least 10, and depending upon circumstances, maybe upwards of 20. So before we talk about line of sight MIMO, because this is a different concept over what you may know about, I need to talk about standard MIMO. Once you understand a little bit about standard MIMO, then we can look at what line of sight MIMO might do. So MIMO stands for multiple input, multiple output, and you've probably seen it on devices like access point routers. They're used in many applications. And the thing that makes MIMO work, if you look at this block diagram over here, for example, they have two transmitters and antennas and two receivers, and what you want to do is send two independent data streams. These may be co-located, generally very close to each other, and you want to send it to a remote set of receiver antennas. And typically what happens in normal MIMO is that you have multipath. That, for example, signals from this transmitter might hit a building over here and arrive at this antenna, but there may be a direct path to this other one. So you get components from each of these two sources arriving at the two destination antennas. And because there's multipath in the environment, normal MIMO will take advantage of that multipath, doing some special digital signal processing at the end to be able to separate out the mutual interference that exists, because each of these is interfering with each other over there. And if you can separate out the mutual interference, then you result in two independent data streams at the output of the system. What I'm showing here is a 2x2, but you can do a 2x3. You can actually do a 2x3, a 3x3, and so forth. But there's some magic property, square property, where if the two indices are the same, so it's like a 2x2 or a 3x3 or 4x4, it has some slightly more attractive features than, say, a 2x4. That's technically possible. So let me change to the next slide here. So I mentioned that the digital signal processing is used to separate out the mutual interference. So how is that done? Typically, there's a tap delay line processor that creates a set of adaptive weights that when you, I'll show some block diagrams in a moment, but if you can set up the right environment, you can effectively null one of the signals, say transmitter 1 that's coming out in receiver 2, you can null out that signal so that what you get out of receiver 2 is only the signal from transmitter 2 and vice versa. You can do that very easily when there's multipath present because the signals are very decorrelated, which makes it easy to subtract them out. And you see the application of this in hotspots. It's used extensively in cellular systems. And the reason they do this is that given the fact that spectrum is at a premium, there's never enough. The telecom companies have spent billions of dollars in auctions to try to get spectrum. Since there's never enough, if you can increase the channel capacity, that's equivalent to getting more spectrum. And so they do this to be able to extend what existing spectrum is able to do. This works because of the impairments in propagation. Is there some way in an environment that does not have multipath that you can take advantage of this? If there is, then perhaps we can apply the same kind of technology in what's currently referred to as line of sight. And so this presentation today will focus on line of sight applications and what it takes to make it work in line of sight scenarios. So when you look at line of sight, what does line of sight mean? The reason, if you go back to the standard MIMO, if you have an access point over here and some computers that are trying to connect to it scattered around the room, there's all sorts of multipath in the room here. So if you look at the propagation models that would describe the signals going from transmitter to the receiver, it is not like free space propagation. Free space propagation is characterized by 1 over r squared type signal loss behavior. And the reason that that's true is that if you can visualize a source, a point source somewhere, the energy is emanating out spherically without interference. And at a receiving site, you capture some portion of the energy on that sphere. And as long as there's nothing interfering with the propagation so that you get the spherical characteristic, then you have free space. But as soon as you get that in space, as soon as you bring that down to Earth, you may start off propagating that way, but then you hit the table, you hit the floor, you hit the buildings, and that causes the waves to interact and interfere with each other. And the resulting propagation that you get is typically anywhere from 1 over r to the third to 1 over r to the fourth. So it's very different. Line of sight, if we were to look at an application, satellite to ground, or aircraft to ground, or mountaintop to mountaintop, for example, we can typically approach line of sight conditions. And so here is an example of where we might be able to make this work. But to make it work, this is the key. We have to find some way to be able to separate out the signals. Because if you have a line of sight condition and you have 2 transmitters and 2 receiving antennas, since there's nothing in between the 2, each receiving antenna is going to fully capture signals from both transmitters, and they're going to look identical. And so compared to the standard MIMO, there's really no way to separate it out. So what we need to do is figure out, is there some way to do that? And actually there is, and it's pretty new technology. It started with some DARPA funding, and so I'm going to describe how it's done. So to do this, I'm going to focus on 2x2 square MIMO, but it can be extended to n by m MIMO. And so if you look at some of these definitions here, you'll see n and m referring to how many antennas you have at the transmitting and the receiving side. This talk could be 2 by 2 and so forth. There's this term B, which is the maximum of N and M, and since they're identical, it's equal to 2 for this application. Not going to spend a lot of effort on math, but this basic relationship, if you use near ideal geometry, simplifies into this expression over here. And I'll explain what near ideal geometry is in a moment, but it's basically where the arrays are parallel to each other. If the transmitting and receiving antennas are in this plane, the transmitting are in this plane, and the receiving are in this plane, the planes are parallel to each other, you get this ideal geometry. And when you do that, this relationship holds. So DR represents the separation of the receiving antennas, DT, the separation of the transmitting antennas, wavelength range. This example V is 2 because we're doing a 2 by 2 array. So this graphic kind of illustrates what the layout would be. One end of the link, you have 2 antennas, and they're separated by a distance. And unfortunately, in this graphic that I pulled off the internet, they use a different term than the standard convention with DT or DR. So they use H1 and H2, but it's the same idea. There's a separation between the antennas at the transmitting side and at the receiving side, separated at some distance, either D or R, depending upon which article that you're using. And what you see is, if the upper left antenna, for example, is the transmitter, and there's a large distance mountaintop to mountaintop between the transmitting and receiving antennas, without any perturbation in between, both antennas on the receiving side are going to capture signals from source 1 and source 2 equally well. They're going to be completely mixed. They'll be the same amplitude. And so the difficulty now is, how do we find a way to separate them out? And the same general architecture that's used in standard BMO can be used, but you have to do something special. Think back on the equation over here. The important thing is that if you are able to make this relationship hold, what you effectively are doing is producing a 90-degree phase shift between the signals. And you're going to exploit that 90-degree phase shift to make the signal processing work. So how is that done? So this is the receiving side. Blue and the red represent the signals coming in from the 2 different antennas. You have 4 of these structures that are referred to as either tap delay lines or space-time equalizers. Transversal filter is another term that's used. And I'll describe the structure in a minute, but the concept is there's an adaptive weight in each of these 4 blocks. And if you take the signal from this antenna through this weight to this summing junction, and the signal from this receiver through its weight going into the same summing junction, if you can create these weights appropriately, then the signal from antenna 1 will effectively subtract out the output of this junction and give you only a signal from antenna 2, and vice versa for this one. So the way this is set up, you have this, and it's all done digitally. So you have a tap delay line processor where you introduce a series of time delays, and at each time delay output, you have a complex weight. So complex weight means I and Q, and I'll talk a little bit in a moment about I and Q in case there's any uncertainty about what that means. And you take those tap delayed signals, you weight them by an amplitude and phase vector, and you sum the output of each of those. And in doing this, what you're creating is the ability to subtract one signal from the other at this junction. And weights are set up to take advantage of that 90-degree phase shift. And if you get the 90-degree phase shift in the environment with the appropriate weights, then the outputs of these two signals will cancel. So that's the necessary condition to make it work. So how easy is it to make it work? Well, it turns out it's not easy. If you try to do this at HF, the numbers don't work out very well. At HF, the separation that you need to be able to get the 90-degree phase shift gets to be very large. So I gave this example with 10 gigahertz and 5 gigahertz. And so this axis would represent the separation of the transmitter antennas. And over on the y-axis, you can see the separation for the receiving antennas. So for example, if we were looking at 10 gigahertz and 20 meter separation, we need 60, 70 meters, something like that on the other end. If and this is for 50-mile separation, if we had these sources 5 miles apart, then you could divide this scale by a factor of 10. And so instead of this point being 125, that'd be 12.5 meters. So you have to maintain that geometry or this isn't going to work. So,
Question?
Yeah, question.
So I'm trying to, is this different from just the fact that there's a slight difference in distance from one receiver to each transmitter?
Yes.
So that you get a different number of wavelengths?
The differential path length,
Yes.
S1 to these antennas, results in a 90-degree phase difference upon arrival at the receiver. And you need that to have a way of being able to remove the mutual interference that's been created.
So I could see that if you knew the wavelengths and you purposely set the distance between the receivers to work with those wavelengths.
Right.
But it wouldn't happen in general, right? It wouldn't be a 90-degree phase shift.
No, you have to set up the scenario explicitly to make that work.
Okay.
And then, Phil, would frequency division multiplexing obviate the need for this? I'm assuming these transmitters are on the same frequency.
The transmitters are on the same frequency, otherwise you're going to violate the premise that you want to use the same spectrum. And so you want to use the same spectrum which is causing the interference, and that's how MIMO in general works. So you want to increase the capacity by reusing the spectrum with independent data streams.
And so in MIMO in general, is the assumption that both the transmitters are operating in phase? Or however many transmitters, they're all in phase?
In normal MIMO, there's no consideration given to the phase relationship between them. It's more general, but it requires multipath to make it work. If you tried to take a standard MIMO system and set it up in this fashion, it would fail, unless you very carefully made sure that you had the right separation for the distance.
Okay.
So, one more question. Is it 90-degree phase difference, or can it be 360 plus 90,
Yes.
720 plus 90?
It all collapses to the same thing. By the time you get to that summing junction over here, as long as you have to have the inputs off by 90, and you end up creating a complete out of phase result over there.
Question here. So, both the antennas are exactly in a straight line. I understand that. Now, couldn't you just move the one antenna backwards or forwards and create the same effect?
That was an example. It doesn't have to be, in that same geometry like that, but you do need to make sure that you have the separation between the two on both ends. So you can lay them horizontally, do them vertically, but you can't put one over here and another somewhere else. You want to keep it in that plane. Remember, I had talked about there was an ideal ideal relationship over here, if those two planes are tilted off like this, you've introduced some angles, and you will not get the full benefit of the process. It will degrade as the angle increases. Questions back?
So if you're carefully adjusting the distances between your transmitters and your receivers so that you get a 90-degree phase shift, why do you need such a complex system to separate them? You've engineered that they're 90 degrees out of phase, so if you just add them together, they go away.
Okay, it doesn't have to be perfect. Okay, so
okay.
The system with the tap delay line processor over here is adaptive in nature, and so you can, for example, have transmitters, let's say, on an aircraft, and two ground receivers. The aircraft is moving, and as it's moving, those phase relationships are changing a little bit, and so the tap delay line processor will take care of that. But if you get to a point where the antennas go like this, then you'll have a huge reduction in capability.
Well, I have another question about polarization. Are you using polarization?
I can't
Are
hear
you using polarization?
I'm going to talk about polarization here in just a minute. That's good, because polarization turns out to be another dimension that you can use to solve some problems, which I was just about to start talking about. So, I said earlier that I was going to talk a little bit about IQ, and in case there's any confusion about what IQ is, assume that there is some LO in the system that establishes a phase relationship, and you happen to have a signal that is offset in phase relative to the initial reference signal. So with this signal, you can break it down into a component, this vector, the quadrature component, and the in-phase component. And if you were to sample the signal in IQ, you can do many wonderful things with it. So for example, when you send digital data, you send them in terms of symbols. What is a symbol? A symbol is an IQ data pair, basically. And so in this very simple example, you can imagine if you have 4 states and you transmit this symbol versus this symbol might represent the data value 0, 0, whereas this one might represent 1, 1. So with a QPSK system like this, you effectively take a 2-bit data word and you encode it into a symbol and you send that one symbol. If you were doing BPSK, you effectively only have 2 states. You're still sending one symbol. So you can see as you go from BPSK to QPSK, you can send more data in that one symbol. So that gives rise to many higher ordered modulations. So I mentioned the BPSK case here to plot differently, which you saw in the previous one. But basically, BPSK allows you to encode 1 bit per symbol. If you're doing Morse code, for example, this is what you would be doing. It's on or it's off. If you're sending QPSK, every time you send a symbol, you're sending 2 bits of data in that same bandwidth. Well, why stop there? You can go to 16 QAM, so you can see it's a little more complicated diagram. These are referred to as constellation diagrams. Here you have 16 possible symbol values, and any one symbol that you send corresponds to 4 bits of data, same bandwidth. So it seems like, wow, why don't we just move over here or beyond? This is 256 QAM, and there are people that use 256 QAM, mostly in fiber, but it's starting to get used in radio communications. But you can see that with 256 QAM, this maximum amplitude range represents your dynamic range in your receiver, and these points get closer and closer together. As they get closer and closer together, you run into problems. It takes, you have to be more careful because of linearity issues. If you have an amplifier chain that's not perfectly linear, that is slightly nonlinear in performance, if you're trying to set this equivalent symbol over here, it might get confused because of the nonlinearity in the amplifier and show up as this one. And so that would be a problem. You'd be sending the wrong data. And you can use error correction to help, but eventually you run into problems. Also, noise gets to be more of a problem because as these points get closer together, noise being somewhat random tend to get in the way. It confuses the decision. This slide gives an example. Here are two 16-QAM constellations. The way these diagrams are formed, you send a long data stream, many symbols, and you collect the data over a period of time. And the center of each of these blocks is where the data point really should be. But because of, in this example, signal to noise ratio, this one only has half a dB and this is 9 dB. You can see that for low signal to noise, it smears together and it's very easy to make mistakes. And so you need to have higher signal to noise, but as you have more and more of these points in the constellation, it becomes increasingly more difficult to resolve the differences. So going to higher order modulation is great because you get lots of bits per symbol, but it also gets to be more complicated. When it's done in fiber, because fiber propagation is not 1 over r squared at best, but 1 over r, you tend not to have as many problems as you would with RF propagation. But there is a clever way, this is getting into polarization, which one of the questions came up, that you can send the same amount of information using a simpler constellation. So for example, take the case of 256 QAM. That gives you 8 bits per symbol. What if you were to send that instead 4 bits of the 8-bit word on one polarization and the other 4 bits on the orthogonal polarization? When you do that, you have a constellation diagram that's equivalent to 256 QAM, but you're actually only sending 16 QAM, and that makes it a lot easier to demodulate without errors. So, effectively, each antenna in the 2x2 MIMO, each antenna transmits dual polarization. So it could be right and left circular or vertical and horizontally polarized. Either way will work. But you take your input data word and you split it in half. And you send half the bits on one polarization and the other half the word on the orthogonal polarization. And of course you have these 2 data streams, so each of the 2 data streams gets split in half on each of the orthogonal polarizations. And at the end, when you go through this process, you get the equivalent of the 256 QAM kind of performance. So this curve shows you what you might expect. I've got this blue curve, which is referred to as CISO. This is single input, single output. This is what we do all the time in amateur radio. It's just one antenna on the transmitter side, one antenna on the receiver side, and I'm comparing the performance of a 2x2 MIMO with a single antenna. And what you see, for example, you can cut this different ways. If we look at what's shown here, this is signal to noise ratio on the x-axis, and this is the capacity in bits per second per hertz. So Obviously, the higher up you go this way, for the lowest signal to noise ratio, the better, because signal to noise ratio corresponds to transmit power, for example. So if you wanted to achieve 4 bits per second per hertz, which is the equivalent of 16 QAM, what you see is that with MIMO, in this example, you would only need a 5 dB signal to noise ratio, whereas with the CISO, to get that same capacity, you'd be up around 12 or so dB. So it takes 7 dB less transmit power, everything else being equal. You can also look at the difference in this dimension. If we had a 15 dB signal to noise ratio with CISO, you'd get the equivalent of about 5 bits per second per hertz, but with MIMO, you get about 10. So either way you look at it, you get either greater capacity or reduced signal to noise requirements. The other thing that's interesting about this is that let's assume that this was, the blue curve was being done with 10 watts, just a number. Turns out the MIMO case is also 10 watts, but half of it is in one antenna and the other half in the other antenna. So it's 5 watts on each transmitter. And so you might ask, how does MIMO with 5 watts on each antenna get double the capacity? And the answer is that you have 2 equal antennas on the receiving side, so you've got a 3 dB gain on the receiving system that effectively cuts your transmit power that you need in half. So in this example, in say a 1 megahertz wide channel with a 15 dB signal to noise ratio, you can easily pass 10 megabits per second data. Now I mentioned in the beginning that it was kind of a stretch to do 20. To be able to do 20, you need a little higher signal to noise ratio, but the problem that you run into is the number of equivalent bits per second per hertz in that output, and that constellation once again gets really tight, and it requires extreme care and linearity in both amplitude and phase. And so 10x is easy to do, 20x is very, very difficult, because not only is there the linearity issue of amplitude, where the amplitude error, amplitude nonlinearity causes the points to shift from where you want to be, but there's also the issue that as you change the amplitude going into the transmitter, you can cause a phase variation with that amplitude. And if you remember, the constellation diagram has many different possible amplitude levels. If you have many amplitude levels, there's the possibility that the change in amplitude will cause the phase to advance or retard a little bit. And if it does, you can move it to the equivalent constellation point that's a different data value. So you need extremely high linearity to push beyond the 10.
Weather conditions are going to change all the time, and that's going to cause absorption, and what effect is, and that's going to reduce power levels, and that's going to throw your constellation on. So
weather,
deal with it.
So weather effects below about 25, 30 gigahertz are not terribly significant. The work I'm doing right now has a lot of effort in 75 to 85 gigahertz, and that turns out to be a really big problem because of 2 things. One is rain. Rain not only causes loss, but it causes depolarization. So if you're trying to take advantage of the 2 polarizations here, you end up causing interference, self-interference, where what's being transmitted on, say, right CP is showing up on left CP because of rain. And if you're going through clouds, there's another
significant issue that shows up again over 20-25 gigahertz, where the cloud loss, even if it's not raining, can be very significant. But mountaintop to mountaintop, if you stay down in frequency, it's not that big a problem.
I was presuming you just make it down.
There's to a point you can deal with it, because those weights, are changing all the time. So this digital processor isn't fixed. You know, it's constantly detecting how well it's doing and sending feedback to adjust the weights. So until you run out of range of compensation, it'll take care of itself. But things like the depolarization, at some point it's going to fall apart.
So you've talked about 2 antennas. What happens when you go to 4 on either end? Does it get twice as good again, or does it get 4 times better, or what's
You'll get double the capacity with 4, because you'll be able to separate out 4. And the interesting thing with the 4x4 MIMO is it's the same power as the 2x2 as the CISO. So if it was 10 watts in the CISO, it's 5 watts on each, or 2.5 on a 4x4. It just becomes more and more cumbersome, and at some point you just have to decide where the practical limits are. But 4x4 has been demonstrated.
Excuse me. Yeah, I was just wondering, what's the maximum attenuation that you can get, channel separation that you can get in dB?
The maximum channel separation
between the 2 links?
Currently, for example, the limitation is driven by polarization isolation and depolarization caused by weather effects. And so the systems that we're looking at, if you have antennas that have very good cross-pole isolation, say 30 dB or better, when the weather effects come in and it degrades down to 16 dB or so cross-pole interference, that's getting to the limit.
Thank you.
So I'd like to thank John, who gave me some constructive comments on the presentation, and I'd like to thank MicroHAMS for giving me the opportunity. And I'd like to just throw up some other practical questions, and I think many of these might have been addressed, but let me talk about a few of these, just to give you an idea of where the state of the art is, or maybe just a little bit beyond the state of the art. I mentioned applications at 75, 85 gigahertz. This is referred to as E-band, where the channel bandwidths are 5 gigahertz wide, instantaneous bandwidth. So with 5 gigahertz wide channel bandwidths, you can see that you can get 30 or more gigabits per second through the system. 30 to 60 gigabits per second. It's really amazing.
Or really high fidelity volts.
Very high. In fact, it's almost like you're in the same room. So, you might ask, how would this apply in amateur radio? And I don't have a real answer to that. It's a new technology, and my hope today was that this would help spur some ideas. I gave the mountaintop to mountaintop application. I'm sure there are others, but with many new technologies, the applications come later. So this is very new. It got started with some DARPA work that I mentioned just in the past couple of years, and there's a lot of interest now. There are a lot of people looking at very, very broadband satellite systems for which this might be a contender, given the amount of spectrum that's available, which is very limited.
How do you spread the antennas far apart enough on a satellite?
Well, you remember this curve, here we go. It all depends on what the frequency is and what the range is. So in a satellite application, range isn't 50 miles. It may be geosynchronous, for example. It's also been done at much higher frequencies. And so typical separations on the spacecraft are single-digit meters apart. And on the ground, they're not single-digit meters, they're kilometers. And so there's some other complexities to make that work, because you've got to bring all of the data to a place where you're doing the digital processing, and you don't want to introduce additional errors. So you have to date it and time tag it and keep that coherent that way. Yeah.
Would this work for moonbounds?
I think that may be stretching it, but I don't know how you maintain. But I don't want to say no, beyond what I've ever thought about. I think the interesting application is, given the limited spectrum, this does provide a way of stretching and getting more capacity in that spectrum.
Part of the rationalization for this system was that you were assuming a certain signal-to-noise ratio and other characteristics, and then trying to optimize bit rate and bit rate through the system. So if you said, okay, I'm not really trying to optimize my bit rate, I'm trying to optimize signal-to-noise ratio for a given bit rate instead, there's a lot of scatter modes that are used in amateur radio, off weather, off reflectors, off the aurora, a bunch of other things like that. So have you considered the idea of optimizing for signal-to-noise ratio with that same dynamic adaptive filtering technique? Would that possibly work?
Actually, it could work, because you will get multiple copies of the signal being reflected in. So instead of having multiple antennas, you're artificially creating multiple antennas. It may be possible with the adaptive weights to sum up and coherently add those individual returns. It's looking more like standard remote because it's a multipath scenario, but by properly aligning the phase relationships in each case, which is not a single phase shift, but it's probably has multiple taps on the ley line, such that when you add up each individual response, they'll coherently add. So that's an interesting idea.
So this is really fascinating to me, because I went to college about the same time you did, and we studied this tap delay technology in digital communications class theory. So if I were engineering a point-to-point link today, is it possible to just go buy off-the-shelf hardware that implements some of this? Really?
Well, the tap delay line processor is, once you sample the data, it was easy to do. I implemented some of these in side lobe cancelers 25 to 35 years ago. So if you have, for example, a link and there's another signal that's causing interference, either intentional or unintentional, coming in, say, your side lobes, you can have an antenna that's low gain that's picking up both, and with a tap delay line processor, you can subtract out the interfering signal. And so that's been done for many, many years. But trying to use it in line of sight MIMO is very new.
Interesting. Thanks.
Hi. You commented earlier with the question just prior to this. The person was asking a question about the multipath correction. Yes, you can do it, and I'm one of the authors on a patent on doing it.
Great.
So the answer is yes.
Great.
So you mentioned it
it's adaptive, is it, I saw you had a training portion up there that you didn't mention. Does it adapt real-time passively, or do you actually have to go?
Real-time.
So you don't have to go through a training portion and then go back and
The
forth?
purpose of training is when you first turn on the system, to be able to help it get started. If you send a known bit sequence, then you can get it to converge. And once it converges, then it'll just follow from that point on.
Any more questions? Well, thank you very much.
Thank you.
So, oops, we need my little tub of Did everybody get their, not everybody got their tickets in.
Oh.
It's your last chance to get your ticket in.
One more.
Exactly. It's not only need this one. Everybody have their ticket in? All right. Any of the tickets? We all in here? Hey, Ward, would you,
Those of us who have our tickets don't want to put it
So no, the answer is no. No more tickets. All right, so here's what I'm going to do. I'm going to lay out our fabulous prizes. Fabulous. So we have a couple of copies of Office 2016. This is real Office, not Office you have to pay for every year. And Alex has donated one of his lift kits here. And there we go. And here's the Idea Stick 300. That's the whole PC. You have to supply your own monitor and keyboard. Thank you, Vanna. And we have some nice gifts from the ARRL. What do we have here? A $50 certificate and two $25 certificates. So I will lay those out, and Ward will draw from the tub. Here, Wheel of Fortune.
Didn't I see a Facebook thing of a dog trying to get kibble out of a protein bottle?
Look, there's one trying to get out right now.
Here we go.
We might need some interactions here. There we go.
Nothing up my sleeve.
And let's see, who do we have? Oh, I guess it's a number. 4945.
4945.
4945. Grant. Don't drop me. You'll break the little card that has the key on it. Yeah. All right. Next. And we have Eric Nelson.
Yes.
Oh! It's good that you're short, Eric. Not an MLB player. Hey, this time, K7QOG. Eric, you don't have to duck this time. We have to pick someone in this side of the room now.
I was going to say that. We're very lopsided.
All right. David W7CF. This doesn't seem right at all. Did you buy this thing?
No, I did not. I bought it. Or you owed me the money. So where's my check, David? Huh? Where's my check?
It's a Lenovo Idea Stick 300. It's a whopping $99, but it's very cool actually, that thing. Exactly, yeah, it's got a nice rounded edge, yeah.
Oh, this was
Oh, fancy.
specially bent.
Fancy. That is you. Kurt. Tricky. Yeah. All right. And who do we have? We have Jeff Chang. Where is he? There you are. I saw you back there somewhere. Yeah.
Finally.
And right. All right, one more.
That'd be like the Alice and Bob, cup of tea.
And finally, Andrew what is that? KL7 RW? Is that right?
C7RBW?
RB, okay, what's your number here? 4851.
Yeah, that's me.
That's you. All right. That's a KC7. All right.
Terrible handwriting. You can tell what it is.
Just got back from Alaska with the KO. Thank you very much. I hope you had a good time. I want to thank all the speakers for coming. Thank you very much for your fantastic information. And we have the pizza feed over at Round Table. Starts with an R, wrong with you.